Come on in. It's time. Don't just look at me. You got to come in. Conversations everywhere. How are we doing, guys? Welcome. Welcome. Make yourselves comfortable. I love you guys got your notepads ready to go. It's like a lecture at university, isn't it? Yeah. No mucking around. Yes. This is being like filmed and that, so I guess because I feel like I'm missing out. I'm here reading my notes while Max is talking. I'm not listening to a single word he's saying. Man, I'll just come to you guys. I'll come to you guys after. Give me the hot topics. Yeah. Come on in. Welcome, welcome. I got no more dad jokes for you today, I'm sorry. I've retired the dad jokes. Hey, brother. Some vegan jokes. I only had the one yesterday. Well, yeah, I don't want to be too polarizing. Look, Max brought this up to me yesterday. We're already having a go at the meat industry, which apparently our people, we're having a go at the meat industry. We're having a go at all these we're sort of like polarizing everybody, really. The vegans are going to hate us. The big farmers are going to hate us that disagree with us. So, I suppose, like Eminem said, if you got haters, you're fucking making it. Right? Would someone be able to shut that door? Please? Please and thank you. The dad joke haters already hate me. They already hate me. I see some of the looks yous are giving me. I deserve it. I'm from Lismore. I do deserve it. What's the furthest some of you have come, actually? Like Gold Coast? We got a Perth man in the house. Bloody hell. That's dedication. When is it coming to Perth? Mystery. We're not allowed to reveal that yet. I'm asking when's it coming to bloody Lismore? So I'm asking Simon. Fucking Perth. Oh, he did. Tristan, he stopped it. But I'm still, I don't know. He's working. Sanjeev, he's from Perth. I think he takes the cake. The carnivore cake. All right. Welcome, everybody, to day 2 of Regenerate Albury 2024. Make some noise. Thanks for coming out to what I know is going to be another ripper of a day. We've got some newbies in the house. Whoever wasn't here yesterday, welcome. Welcome to the party. And, of course, to the live streamers. Oh, the cameras are here. Welcome from your own home. You're here with us in spirit, like Grandma. Pay respects to Nan. Relax. I'm Scotty Brizzle. I'm going to be your MC again for today. So, you're welcome and I'm sorry. But yeah, we've got another 5 great speakers today, guys. It's going to be insane. I know it is, because it's all going to be surrounding the topic of a discussion is going to be light and how it affects our health. So I hope you've brought your blue blockers, because these guys are going to be shining. Yeah, that's right. That's right. It's funny because I don't know, I was thinking about this morning. You know when you got bikies and they identify themselves with their patches and their colours? I feel it's the same with blue blockers, right? But just the opposite end of the spectrum, like total quantum nerds. Like, because when I'm out and I'm wearing blue blockers and I see someone wearing a pair of blue blockers, you look at each other and you give the nod. My guy. And then you go up and you give them like the full light spectrum handshake. You know? It's true. You know what I'm saying. You know what I'm saying. Anyway, so we're going to be focusing on light, circadian and quantum biology, the electromagnetic spectrum and the role in health. And this is a cutting edge and innovative area of health that is, I'm pretty sure we figured out this is the first ever quantum health summit day to be held in Australia. So we're making history today, guys. Make some noise. I think Uncle Jack Cruz would be very proud of us, right? Anyway. Before we get into it, I do want to give a shout out to the absolute legends and the made it all possible. Max Gulhane, Simon Lewis, the creators to Regenerate. Thank you so much. They're the ones that made it all possible and for us to be here together. And where from the outside it definitely looks like we are some creepy cult. But look, I'm wearing it. But speaking of, bring the Kool-Aid out. We got them, guys. We got them. No, we just got grass-fed steaks for you. There's no Kool-Aid. So bit of stock standard housekeeping. We've got the cult toilets just through here. We've got the cult water and coffee and that just out there. We've got the fire pits for the cult circles. And Alistair, my man, he's my number one fan. But yeah. So, are you guys ready for your first speaker? Oh, yeah. Are you guys ready for your first speaker? That's what I'm talking about, guys. Making history. All right. Our first speaker for the day is a nutritionist, a health coach, and pulmonary scientist who has worked with thousands of patients. He has a passion for circadian and quantum biology and the role of the electromagnetic spectrum on human health. He is the host of the Ricky Flow Nutrition Podcast, presenting his epic talk today, Sunlight, the Foundation of Health. Put your hands together. It's Cameron Borg.
Thank you for that, Scotty. That was pretty good. I just want to thank Max and Simon again for putting all of this on. It's a pretty big deal to have something like this going on, and thanks for being silly enough to ask me to speak. I appreciate it. So my talk is called Sunlight, the Foundation of Health, and I think that pretty well frames the kind of thing that I'm going to go through today. I really do believe that the light that we get, the energy we get from the sun, is really the basis of life on Earth, and we've sort of forgotten about that. So yes, I'm a nutritionist, I'm a podcaster, I work as a pulmonary scientist in the system, and I'm a nature enthusiast. As far as disclosures go, I'm working with Kiera and Jalal Khan on the Quantum Health Academy that's going to start at the end of this year. So that's really the only thing that I've got going on as far as that's concerned. I just want to storyboard sort of what we're going to go through today, because I think it's important just to get an idea of the flow, because I want to try and tell a story, essentially about how we got where we are today and the philosophy that led us there, and perhaps what we can do with the way that we think about these problems to make sure we can turn this around. So we're going to start out just by talking basically about what is light, because it's a pretty esoteric topic. It's not easy to pin down what light really is, so we'll try and get a handle on that. Then we're going to talk about health and light. So I just want to go over a few observations, a few epidemiological studies, just to give you an idea of the type of impact sunlight has on human health, just to set us up before we go deeper. Then I want to really get to the crux of what I really want to talk about, is how we got it so wrong. How have we ended up in a place today where we're using lights that are completely alien to us and that do not resemble sunlight at all? How have we got to the point that where we are today where we've made so many mistakes after mistakes after mistakes. What's the philosophy that got us there? That's what I'm really concerned about. Then I'm going to talk a little bit more about light-life interactions, so how biological systems are using light in order to function properly. Then we'll touch on circadian rhythm, and I guess those 2 points there, the light-life interactions and the circadian biology aspect, I really want to convince you that those are just two sides of the same coin. These are not separate things going on. They are exactly the same, and at the moment there's a bit of a chasm in the research between those two things, and really they need to be unified in order for us to really understand how to help people utilize sunlight for health. And then I'll talk about, potential solutions, hopefully, and some good things that are happening, because it can be a little bit depressing thinking about all this. So I want to start, before we get into the first thing, I want to talk about how humans have adored light for as long as we've been anatomically modern. Probably 300,000 years we've been worshipping the sun. Ancient Egypt, Stonehenge, tracking the cycles of the sun, tracking exactly the seasons to the precise day. Machu Picchu, again, one of these megalithic structures that perfectly tracks the equinoxes and the solstices, so that the people there knew exactly what was going to, from a food point of view, from a weather point of view, what was going to be going on. This is a site called Gigantia in Malta. I've had the pleasure of actually going there, and there's a few sites there, and it's very obvious when you go that these cultures were obsessed with the sun and tracking not only the sun but the stars, and clearly this was hyper important to them, because this would have taken generations. So imagine starting something that you're not going to see the end of. You're going to die before these structures are even finished. So clearly the drive to do this was so great, it had to be extremely important to them. And all cultures, all successful cultures have embedded in their practices the use of sunlight and the adoration or worship of sunlight. And in The Undiscovered Self by Carl Jung, he writes this passage. I know it's not good to have large pieces of writing on slides, but bear with me. So he writes, every morning at dawn, he went to an East African tribe. He said, every morning at dawn, they leave their huts and breathe or spit into their hands, stretching them out to the first rays of sun, as if they were offering either their breath or their spittle to the rising god, to what they call Mungu. When I asked them what they meant by this act and why they did it, they were completely baffled. They could only say, we have always done it. It has always been done when the sun rises. They laughed at the obvious conclusion that the sun is God. The sun is not God when it is above the horizon, they say. God is the actual moment of the sunrise. So you can see these cultures had embedded into their practices sun worship. And we'll get into later how important that is from a circadian point of view. I was reading this going, these guys had the best circadian rhythms ever because it was culturally embedded into their practice. They didn't know why, from a scientific point of view, they were doing this, but they knew even deeper why they were doing this. Their knowledge was embodied. Ours is more intellectual, ours is more up here, but they were embodying their knowledge, and I think that's even more important. So they knew what we're only now rediscovering on an intellectual level. They knew at a deeper level and more fundamental way. So he was talking about the Sabini tribe in Uganda, and sunlight has essentially been the only source of light for as long as the Earth has been around. Fire is a relatively new invention from the perspective of 4.6 billion years. And the energy that sunlight provided is the foundation upon which life emerged and thrived on this planet. Without sunlight, you get nothing. And some of you might be thinking, what about, sulfur-reducing bacteria at the bottom of the ocean? They get no direct sunlight, but their whole metabolisms are based around the oxidative capacity of sunlight. So sun provides the charge separation events in water that allow them to use proton gradients at the bottom of the ocean. So if there's no sun, even organisms that never get exposed to sunlight directly, their whole life cycles break down completely. So every single life, every single organism on this planet is completely dependent on the sun, whether it's directly or indirectly. So we'll get into what is light. So light is electromagnetic energy. And it's pretty weird to think that we only interact with a very, very minuscule portion, a very narrow slice of the electromagnetic spectrum. We've all probably had X-rays before. We've all probably listened to the radio before. All of these wavelengths are still light. So it's weird to think that, you know, when you're using your phone connected to the internet, those are photons that are using to communicate. It's just not photons we can see, so we don't really think about it like that. We only really think about light in this extremely narrow slice. You can see how small the visible portion is, wedged between ultraviolet and infrared radiation. And we seem to forget that the electromagnetic spectrum is so much broader than the part that we interact with. And I think this sort of sets us up when we try to intellectualize too much to think that what we're seeing is all that's going on. And I'm going to try and paint a picture of how that sort of led us down the wrong path. And light has unusual qualities. It has quantum properties. So the act of observation, the interaction with consciousness actually changes whether light is a wave or a particle. The conscious interaction with light sort of collapses it and makes it decide where it is and what it's doing. And this sort of goes back to the quantum thought experiments of Schrödinger. Anyone familiar with Schrödinger's cat? The cat, you know, Schrödinger's cat was dead and alive at the same time, which sounds completely counterintuitive. So his cat was dead and alive at the same time. But has anyone heard of Schrödinger's dog? Who's a good boy and not a good boy at the same time? I was expecting a bigger response there, but that's okay. So when we're talking about light, we're really talking about sunlight. I think that's the thing most people think about when they say light. We're typically not thinking of compact fluorescent lights when someone brings up light. We're always talking about sunlight. So what are the characteristics of sunlight? So above our atmosphere, sunlight's obviously a lot stronger, and there's a lot more of the spectrum that's outside of our atmosphere. But our atmosphere's got lots of stuff in it, and that makes it sort of filter the light as it comes through. So you can see there's a few different spectrums here, but the red one is what I want you to look at. It's got all these gaps in the infrared, so you can see well beyond where the visible portion is. You've got all these gaps, and those gaps are where infrared light is being absorbed by water, carbon dioxide, and even to a lesser extent ozone. And ozone is cutting out the UVC, so the extremely high-powered photons it's cutting out, which is great for us because we probably wouldn't have been able to evolve very well with UVC. It's very, very high-powered photons. They tend to break things and make molecular complexity a little bit difficult. So we're sitting in this really good spot where we get UVB, which is really powerful and useful, but not so powerful that it breaks too much stuff. And you can see here photosynthesis happens in the blue and the red. Chlorophyll pigments don't really like green, which is why they reflect it out, which is why leaves tend to be green. It's because they don't use the green. Something about the energy of the green photons that they don't like. And you can see here, overlaid on what we get, so this red portion that we see when we go outside, overlaid is we've got the big loop of the tungsten filament. So these are the old Edison bulbs. So when you run a current through a filament, you generate lots of long wavelength light, and you have to run quite a bit of current through it to get visible light, which is why the incandescent bulbs that we used to use take up a lot of energy, because in order to get visible light to make it useful as a light globe, you have to use a lot of energy. But the benefit of that is you get a lot of long wavelength light, just like you do in the sun. And over time, we thought, how can we make this more efficient from an energy perspective? Which is quite a noble pursuit, really. And what we've done is we've come up with iterations, so compact fluorescence, halogen lights, and finally we've got to LEDs, which are a phenomenal technology. But as we've gone through and eliminated more and more energy, because we don't see the near-infrared and the infrared, so it's not useful for vision in that sense. And you can see the white LED. So you get a huge peak at about 420 to 450 nanometers, which you can see in sunlight, there's no such peak. You get a very broad, and because the sun is a thermal emission source, you get a very different sort of emission spectrum. But white LEDs are very, very peculiar. They're very alien. We've never before in our evolution would any biological system have been exposed to narrowband light. And you can see just how big the difference is between the old style lights and the new style lights and how they match up to the solar spectrum. So I think it's important to note that sunlight cannot be replicated. It just can't. You need a black body radiator to do what the sun does, and we just can't do that here. It would be too hot. So the sun's broadband thermal emission spectra and interaction with the Earth's atmosphere generate a unique energy source that supplies critical portions of the electromagnetic spectrum that facilitate the union of physics and chemistry. I think this is really important. Without solar radiation, the initial conditions for life on this planet just simply would not have been met. So sunlight was really the prerequisite for life. Without sunlight, you just don't get the life that we see today. So I want to talk briefly about health and light and sort of these connections. I'm going to try and not be too sciencey here, but there are a few papers that I think are really telling. The first one you probably heard of was set up by a Swedish gentleman, and they were looking at figuring out how sun exposure habits increased melanoma rates in Sweden, because that was the assumption. And this went over about 20 years, and they had, I think, just under 20,000 participants, so huge, huge study. And they expected to find that basically the people who had the sun exposure habits, the highest sun exposure habits, the people who were trying to get outside as much as possible would have the most melanoma. What they found was the exact opposite. So they say, we found that all-cause mortality, so not just melanoma, death of any cause was inversely related to sun exposure habits in a dose-dependent manner. So the more sunlight you got, the less likely you were to die of any cause. The mortality rate was increased twofold amongst avoiders of sun exposure when compared to those with the highest sun exposure habits. In this study, focusing on avoidance of sun exposure, the women with normal sun exposure habits were not significantly increased risk of malignant melanoma or malignant melanoma-related death. So they found the exact opposite of what they originally set out to look for. And these graphs are really quite telling. So the more sunlight you get, the longer you live. And there will be people out there who say, oh yeah, but the people in this study who got the most sun got the most cancer, which is true. Why did they get the most cancer? Because they lived longer. What's the number one risk factor for cancer? Is age. So, of course, if you're living longer, your risk of cancer is going to go up. But that's a real straw man argument here. And another thing they got from this study was the smokers in this study who had the highest sun-seeking behaviors had the same life expectancy as non-smokers who had the least sun exposure habits. So we can see that there's very, very powerful things going on here. Another study headed up by Professor Richard Weller, 376,000 patients. This is not a small study. This is a massive, massive study. Published, I think it was only last year or the year before. They found that greater behavioral and higher geographical related UV exposure, so basically the more you sought sun and the closer you were to the equator, this was in the UK, and the closer you were to the equator, so the further south you were in the UK, was associated with the lower risk of all-cause cardiovascular disease and cancer mortality. So again, this is not just a singular effect. This is not just affecting one disease process. We're really looking at something that is at the foundation of human health. It's affecting everything. This study adds to the growing evidence that the benefits of UV exposure may outweigh the risks in low sunlight countries. And we'll get into some of the nuance about higher sunlight countries like Australia a bit later. This is another study by Sean Kane, who's an Australian, and they were looking at the UK statistics. So again, over 85,000 people. It's a massive, massive study. And there's 3 points here I wanted to get to. This was in their discussion. So circadian rhythm disturbance is a common feature of many psychiatric disorders. I think all psychiatric disorders. Light is the primary input to the circadian clock, with daytime light strengthening rhythms and nighttime light disturbing them. Greater nighttime light exposure was associated with increased risk for major depressive disorder, generalized anxiety disorder, PTSD, psychosis, bipolar disorder, and self-harm behavior. Independent of nighttime light exposure, greater daytime light exposure was associated with reduced risk for major depressive disorder, PTSD, psychosis, and self-harm behavior. Avoiding light at night and seeking light during the day may be a simple and effective non-pharmacological means of broadly improving mental health. Again, we're looking at something that's not just affecting one disease process, it's affecting mental health across the board. And just seeking more light, getting outside during the day and dimming the lights or turning them off at night costs absolutely nothing. It would probably save you money from electricity. But these are extremely powerful things to do. So then we start to look at some of the studies. A few decades ago, there was an enormous amount of hype around vitamin D, because a lot of people were doing epidemiological studies. They take a big population and they look at the vitamin D levels in that population and they follow them. And the people with the highest vitamin D levels are protected from almost everything. So they come up with a hypothesis. They say, okay, what happens if we... So vitamin D has received widespread attention for its potential role in preventing cardiovascular disease and type 2 diabetes. Pretty much every epidemiological study that they've done, you find the people with the highest vitamin D levels do better across the board. Doesn't matter really what disease you look at. So then you think, okay, what happens if we get a cohort of people, we divide them, and we have a control, and then we have a group of people who we give vitamin D supplements to get their levels up to where the people who do the best. Clearly, that's going to prevent cardiovascular disease, that's going to prevent diabetes. So you get all these studies with interventional trials giving people vitamin D, saying, well, if high vitamin D is better, then we'll just give them vitamin D and it'll fix everything. And you look at these systematic reviews and they find absolutely nothing. It doesn't move the needle at all. So what we're looking at is vitamin D measured in the blood, the circulating form, is but a proxy marker for sun exposure habits. When you're looking at vitamin D in the blood, what you're seeing generally is how much time is this person spending outside. And it's not a vitamin D dependent story, because the vitamin D supplement trials all failed. They don't work. So it's something that the sun is giving us other than vitamin D, and it's probably giving us 1,000 things that we don't even know about. And that's why the messaging around vitamin D is confusing at times, because it really doesn't work to prevent cardiovascular disease, it doesn't work to prevent cancer, and it doesn't work to prevent metabolic disorders. Even though the people in the population who have the highest level are protected from them. That's because they're out in the sun. So vitamin D is but a small part of how sunlight regulates our bodies. Now, I want to show you some of my favorite statistics ever. So this is the association between UVB radiation, vitamin D status, and incidence of type 1 diabetes, so autoimmune diabetes. Now, this is the most perfect depiction of the effects of high energy photons on disease processes. So you can see where it's at the lowest, we're on the equator, so 0. The further away you get from the equator, either south or north, the more you get type 1 diabetes in the population. Now, to my knowledge, this hasn't been settled, but it looks to be not a vitamin D dependent process. So again, if you give people vitamin D supplements, it doesn't prevent them from getting type 1 diabetes. So again, there's something else about the sun that is providing protection from these types of conditions. This is multiple sclerosis risk plotted by latitude. Again, we see there's essentially no MS on the equator. It doesn't exist. It's actually quite remarkable. The associations that you get here, it's clear as day. And this is known for sure that this is not a vitamin D dependent process. The studies have been done. This has nothing to do with vitamin D. There is something else about UV light that is preventing the incidence of MS when you get closer to the equator. And unfortunately, vitamin D research has monopolized the research into the effects of sunlight. Everyone just thinks everything has to do with vitamin D. It's not. And unfortunately, so much has gone into vitamin D when, again, it's just such a narrow slice of what's actually happening. And we know that MS is not a vitamin D dependent incidence. It has to do with something else that's going on with UV light. And we don't know what that is. And unfortunately, we're probably not even looking in the right places because vitamin D research takes all the funding money. Again, this is a very interesting association. Serum cholesterol levels, of course, when you have more UV light available, your cholesterol levels go down. And these are in populations, these are in just normal populations, so these aren't even sun-seeking populations. So really the ebbs and flows of blood lipids is actually probably much greater in people who are living an outdoor life. But this begs the question, could our mass migration indoors over the last century be a primary contributor to chronic disease? And I'm going to try and paint the picture that I think it is. So all life evolved with the expectation, I think that word is really important. Our biological system expects that sunlight and the energy therein is available to use every single day. Every single day. Whether it's cloudy, most of that light is coming through the clouds, but we can't see it. So our bodies have specifically evolved expecting that that's there, because why wouldn't it evolve to expect that that light's going to be there? But when we move inside and we live inside all days, those expectations are not met. And when those expectations are not met, the body runs at a deficit. And that's just the way it is. There's really no way around that. How do we get it wrong? This is, I think, the main thing that I want to get across to you today is what led us from the point where we were worshipping the sun to the point where we're spending probably, I think across the population, people spend 90% of their time indoors. How have we got it so wrong? I want to tell a story about rickets because I think this is important to the topic of getting across how we philosophically got it wrong. So the first mention of rickets, 1634. It was a really, really hard time in certain parts of Europe. Rickets was also called the English disease because that's where they struggled with it most. And rickets is characterized by deformation of the bones, particularly the long bones. And it's lifelong. It's not something that can be reversed. Once those bones don't ossify correctly, they're stuck like that forever. So really, really debilitating disease. And for centuries, it was really unknown what was going on. They suspected there was a dietary element. They suspected there was an environmental element. We weren't really sure. But throughout Europe, there were quite a few doctors who realized that sunlight was important. Didn't know why, just knew that it seemed to work. Tuberculosis seemed to be able to be cured by exposure to sunlight. Rickets seemed to be able to be cured by sunlight. So a lot of these forward-thinking doctors in Europe decided to put their hospital beds outside. And they were getting really, really phenomenal results, which shouldn't surprise anyone. And Auguste Rollier is probably the main proponent of this. He set up all of these clinics in the Alps, in Switzerland, and got everyone, in their underwear. It was very cold. He thought that the cold had something to do with it as well. But the reason he had to go up in the Alps is because the further off sea level you get, the more UV light there is. He didn't know that at the time, but he didn't need to know. It worked, and patients got healed a lot. And we also had cod liver oil, which at the time was very cheap. And in Europe, there are periods of the year where there's no UVB light, so you can't synthesize vitamin D. And if you haven't stored up enough over the summer and you haven't laid down enough fat to store it, you probably do need to have some sort of intake of whether it's fatty fish or cod liver oil. So cod liver oil was touted as bottled sunshine because it did the same thing as sunshine did. As far as they were concerned, it cured rickets, which was a really big deal, and cod liver oil was very cheap, and they made it in the UK at the time when rickets was really quite a big problem. So it was really useful in Europe, where there were periods during winter where there was no UV light. And then we see this was 1931, US Department of Labor. This is an old pamphlet, Sunlight for Babies. And as I was saying before, rickets is very debilitating. If a child gets it, they're basically at a deficit for their whole life. It's really quite a strain on the economy. And they would hand out these pamphlets, and there's so many great paragraphs in this pamphlet, but I'll just read a few passages. So, the sun that tans the child's skin helps him grow normally. It gives his body the power to use food so as to build straight bones, strong muscles, and well-formed teeth. Every mother who wishes her baby to have robust health should give him regular sunbaths from early infancy until he is old enough to play in the sun himself. Dark-skinned babies need more sun to tan them and to protect them from rickets than fair-skinned babies. Everything written there is 100% true. They got it right. They didn't know why it was right, they just knew it was right. And this worked phenomenally well. Rickets got eradicated in the early part of the 20th century. So I want to ask, how did the messaging go from that to don't be caught in the sun, which the subtext there is ever, don't ever be caught in the sun, and don't let the sun see your DNA. This is, standard messaging we see here in Australia. I think we have it the worst. And that's also a picture of a child that had tuberculosis that was cured by sunlight. You can see how pale he was before and how beautifully tan and how wonderful his skin looks after. And, your grandma knew this. Oh, you look pale. Are you unwell? Everyone knows that. When you have a tan, you're healthy. So how did we get, in the space of just several decades, how did we get this messaging? We're on the polar opposite end of the spectrum. And I think this quote really puts it all into perspective. So one of the most highly developed skills of contemporary Western civilization is dissection. The split up of problems into their smallest possible components. So good, we often forget to put the pieces back together again. And that's exactly what we've done. We've sought to find out precisely from an intellectual point of view what's going on. And by the time we get there, we don't even know what we're looking at anymore. You just have no idea how to contextualize that in the real world. So in the late 1800s and 1900s, doctors knew sunlight could cure rickets. It could cure tuberculosis. It was, and they had a phrase, malaise, which was generally used for things they didn't know what was going on. They knew it was cured. They had no idea why, but they didn't need to. It didn't matter. Sunlight cured it. They didn't need to know what was going on. They knew that cod liver oil worked, particularly during winter when the intensity of the sun wasn't as great. Didn't know why? Vitamin D hadn't been discovered at that point. They didn't know why it worked. They just knew that it worked. Who cares why it works? It works, and it was cheap. We knew what worked, but that wasn't enough. We've got big fat brains. We want to know why. And in the late 1910s, and this goes back to even before Niels Finsen using mercury arc lamps, which had a UV spectrum in it to treat tuberculosis, we see in Europe and America the use of special UV emitting lamps could be used to treat rickets. So we're sort of getting closer. We go, okay, sunlight works, but it's something we can narrow it down a little bit further. It's a portion of the sunlight that's working. And we knew that because if you radiate one arm with UV light, the bones ossify in the other one. So we were going, okay, so it's not a direct effect. Something's going on where it's going into probably the circulation that's having abscopic effects that's going all over the body. So we're getting even closer. We know something's happening in the skin. It's going into circulation. 1920s, we see Harry Steenbock radiating yeasts with UV light. And then what you could do is you make yeast extracts and put them in milk, and that would cure rickets. So we're getting even closer now to figuring out the precise thing. We're zooming right in. So we know that there's something made. Something is made, a molecule. When we extract it, we can put it into milk. It will cure rickets. Then, in the 1930s, the pre-vitamin D is discovered, and then 2 years later, the vitamin D itself was discovered. And Window had already won the Nobel Prize 7 years prior to that for his work on sterols. So he was on the right path from the beginning. So finally, we've got from sunlight is curative to we know the molecule, which is great. And we come to today. And I work in a hospital, and I see this every single day, people just on 1,000 units of vitamin D a day. And I often ask people, how often are you out in the sun? And their knee-jerk response is, oh no, I'm on vitamin D, my doctor put me on vitamin D. So we can see just how zoomed in we've become that we don't even know what the problem is anymore. We don't even know what questions to ask. And the implicit assertion of this recommendation by doctors is that the only thing that the sun gives us is contained within a capsule of vitamin D. Whether they say that or not, that is the subtext of what they say when they prescribe. They say just take a vitamin D capsule once a day. That is what they're saying to you. That's the only thing that the sun gives you. You don't need to go outside. We've solved the problem. So, but as I showed before, the studies that look into the interventional trials where they give vitamin D, it doesn't work. So they should know that that's not all that's contained within sunlight, and that vitamin D is but a small aspect of the symphony of things that's going on with sun exposure. So today we have widespread recommendations of sun avoidance, and the vitamin D supplement market is an enormous market, and I think that's probably not a good thing, because people just think they can out-supplement actually getting outside. So we see this process of, we know sunlight and cod liver oil is curative, but we don't know why. So, we're doing all the right things there. Then we move along, we know a little bit more. We can use UV lamps and we can use yeast extracts to treat it. We're zooming a little bit in. And then we get to today. We know exactly how everything works. We know the enzymes in the kidney and the liver. We know exactly the kinetics of those. And the recommendation is just take a vitamin D supplement. So what's happened is the more knowledge we've gained, the further away from the truth we've got. We've zoomed in so far, we can't see the forest for the trees anymore. And I think this is exactly what's happened with our lighting environment. I think the exact same philosophical underpinnings have led to, we've got compact fluorescent tubes in here. Why have we got to the point where this is sort of the first choice for indoor lighting? The more we have zoomed in and isolated the problem, the more we have systematically generated solutions that are limited in their utility and sometimes even anti-useful, which is where I think we're at today. They're anti-useful. They're actually detrimental. So I really like this picture because it highlights how things have changed. So for 4.6 billion years, for the whole time the Earth has existed, what we've had is just solar radiation. That's it. But 100 years ago, that changed for the first time. And we started to get lights that have emission spectra that do not match the way that our bodies have evolved. They've evolved to perfectly use solar radiation. And you can see the more into it we've got, the more adulterated the spectrum has become. And our bodies only know how to effectively use sunlight. These other spectrums of fluorescence and LEDs, and even to a lesser extent incandescence, but incandescent lighting is probably the most favorable thing we have. But of course, just like raw milk is illegal, incandescent bulbs are illegal. So again, this is sort of where our philosophy has led us to a point where the only really safe lighting option is illegal. It's a hard thing to sort of wrap your head around. And again, LEDs are a phenomenal technology, but we've zoomed in so far, we just don't understand. We just don't understand what we're doing. And the problem is not only the spectrum, but sunlight is so much more powerful. Everyone knows this when they're inside all day and they go outside and they have to squint, even though it seems like it's the same, it seems very bright inside. When you go outdoors, you realize how weak indoor lighting really is. And what's really important to understand is that we don't see most of light. We just don't see it. So it's very difficult to know when it's there and when it's not. The main way to know is whether we get warm or not, and that's why old incandescent bulbs used to get hot, and that was because they're emitting long wavelength light that heats things up. But modern lighting has 0 near infrared, and we don't know because we can't see it. So it's a really nefarious problem because it's like Wi-Fi. You can't see it. It's very, very intangible. But the old lights used to have lots of near infrared. Now we have none, and we cannot tell the difference. Like if I had 2 bulbs that had the same spectrum, one had loads of near infrared, the other one didn't. What we've experienced with our lighting environment is a qualitative change, not a quantitative change. This is not, the intensity's been lowered a little bit, there's a little bit less near infrared. No, it's completely different. It's a qualitative change. Our bodies have absolutely no idea how to use modern lighting fixtures. But because of the way our vision has evolved, we never needed to see any of that because we were always just outside. Sunlight was our only option. We haven't even noticed. No one knows, and I think this is why it's such a nefarious problem, is because most people are aware that processed foods are bad for you. No one going to McDonald's is thinking that this is a good option. They're there despite the fact that they know it's not a good option. But no one knows their LED fixtures in their homes and their offices are detrimental to their health. So that's why I think it's so much worse a problem than the food problem, because people do not even know that it's a problem to begin with. So let's talk about light-life interactions. So I just want to preface this by talking about how varied human beings are. So on the left, we see the Sami people of Scandinavia. You can see how little pigment they have in their skin. And then we look at the Hadzabe of East Africa. It's basically where Homo sapiens started in the East African Rift. And you can see the pigmentation differences are enormous. So in order to talk about light-life interactions, we have to establish that there is an extraordinary variation in the way that our bodies are able to accept and use light. It's a very, very big difference, and blanket statements don't work. They simply do not work. And I'll read the first study I showed you several slides ago. Had a comment by Nina Jablonski, who's an anthropologist, and she looks at skin color and the biological and social importance of skin color. And she writes, from an evolutionary perspective, there must be a selection advantage in being less pigmented when living far from the equator. Otherwise, differences in skin pigmentation would not have emerged. Fair skin might confer an evolutionary advantage in regions with low solar intensity by preventing vitamin D deficiency and thereby increasing longevity and reducing infections. However, a fair-skinned individual, for example, emigrating from the UK, would not derive any additional benefit from the light skin in Australia, where pigmented skin is an advantage due to high solar intensity. So we can see that there's nuance here with sun exposure guidelines, which is unfortunate because everyone gets the same message here, which is never go out in the sun, which is an absolute disaster for people coming from who have heritage closer to the equator with more pigment in their skin. And this is one of the big reasons why ethnic minorities tend to do worse with health, because they need more sunlight than we do. And the fact that skin depigmentation has evolved at least three times, it's suspected that it's much more, is irrefutable evidence that our skin requires a certain amount of UV photons. Otherwise, our skin wouldn't have depigmented. We'd all be completely covered in melanin if UV was bad. The fact that we depigmented is, like, you can't get better evidence that we need some, absolutely. And the further north we went, the more depigmented we became. And the reason that is because if you can't make vitamin D, your bones don't develop properly. And if a woman's hips don't develop properly, they cannot birth. And these are, on the right, that's a skeleton from someone who obviously had rickets. And you just cannot give birth. So depigmentation would have been highly, highly selected for. And you can see here, this is a native Australian. Now, they are perfectly adapted to the environment here. I'm much more pale. So obviously the amount of time I'm going to be able to spend outside in direct sunlight is significantly less than them. They are perfectly designed to spend all day, every day outside, starkers in full spectrum sunlight. Me, in summer, I can't handle that. And it's just about being smart about the recommendations that we give. So pigmentation type is also somewhat fluid. So I can tan quite well. Some people can tan really, really well, others not so much. And we just need to understand that we're living in a place that is not our ancestral home. So we need to be careful because UV lights, these high energy photons, can be dangerous. The important word there is can. They're not dangerous a priori, they can be in certain situations. So this is a very interesting take on UV light from a dermatologist, believe it or not. He's a brilliant guy. UV radiation as an initiator and driver for biological evolution, he starts. UV radiation is enough to drive chemical reactions independently on metabolism and to damage the cell. DNA effectively dissipates energy of excitation and can store genetic information, including only a limited number of UV-induced mutations. The cell also gets information on UV to set off the processes for repair and photoprotection, thus maintaining homeostasis, preserving enthalpy, and facilitating evolution. So basically what he's saying there is UV light played an indispensable role in creating chemical complexity. And also that UV light itself is the initiator for repair. So yes, it can be damaging, but it's also the initiator for repair. And where UV light hits on the skin, I mean, everyone knows our skin sloughs off every 20 days. The reason it does that is because the region that's exposed to UV light, our body knows, yeah, that needs to be restored every 20 or so days because that's where the high energy photons are hitting. So this is a bit of a tangent, but I want to talk about iguanas. So in America, a lot of households have iguanas. And when you go to buy a pet iguana, you have to buy special lights to put in their enclosure. You have to. They need UV light. For the same reason we do, the underlying physiology is exactly the same. You need to give them broad spectrum infrared light and you need to give them UV light. Otherwise, they get breaks in their long bones. Our physiology is exactly the same, but we don't do this in our preschools, we don't do this in our nursing homes, we don't do this in our schools, we don't do this in our workplaces, but we do it for our iguanas. What is going on here? This is cognitive dissonance at its greatest. Why are we know, oh yeah, you can't have a pet lizard, it needs full spectrum. Quick word on skin cancer. I didn't initially have this in my talk, but I think it's probably important because it's always the first thing everyone asks. So I want to talk about some paradoxes that exist in the current messaging surrounding melanoma. First of all, there's three main types of skin cancer. Melanoma is the big one. That's the one that's fast metastasizing, very, very dangerous. The other two, squamous cell carcinoma, basal cell carcinoma, we don't even count them in our cancer statistics. They're very slow metastasizing. They get burnt or cut off or you just leave them. They don't kill people, generally speaking. They're cosmetic. So we don't even count them in our cancer statistics. They are not in there. So melanoma is really the only one that everyone really cares about, but the big C word is there. So one of the paradoxes, melanoma patients have the lowest vitamin D levels, and those with the lowest vitamin D levels have the most unfavorable prognosis. If melanoma was caused by sun exposure, the patients who are diagnosed with melanoma would have the highest vitamin D levels, no? This doesn't make sense, and there's quite a few publications showing this. Melanoma rates are only increasing in indoor workers. Outdoor workers are protected from melanoma, even though they get 3 to 10 times more annual UV exposure. So that's another paradox. Epidemiological studies fail to report consistent associations with sun exposure and melanoma, with some finding inverse associations. Chronic or habitual sun exposure appears to have little effect on melanoma incidence and may even have a protective effect. So a lot of these epidemiological studies are showing the people who spend the most time outdoors are actually protected from melanoma. And the people who spend the least amount of doors and particularly have intermittent exposures, so people who are sitting in their office for 6 months of the year, they fly down to, Bali or whatever, they go out in the sun all week and then they go back. Those intermittent exposures are what are associated with melanoma. Chronic exposure is protective. So if you're outside all the time, you're protected. Melanoma risk appears to increase alongside decreasing personal UV exposure. So the less UV you get, the more melanoma risk you have. And this is coupled with the vitamin D story as well. So the higher your vitamin D levels, the less likely you are to have melanoma. And many melanoma are found on the least sun-exposed areas of the body. If anyone's ever got a skin check, they check between your toes, and you're thinking, why the hell are you checking there? And the reason is because these melanomas are not caused by direct exposure to sunlight. The squamous cell and basal cell carcinomas tend to show up on the most sun-exposed parts of the body, on the hands and on the face, but not melanoma. It's a very, very complex, very different story. And the idea that sun exposure causes melanoma is, in my opinion, completely unsupportable with the available evidence. And the last one, and this is my point, I don't have any references here, but we've never spent less time outdoors evolutionarily. Populations have never spent less time indoors, yet we have the highest and growing rates of melanoma ever. How do you square those two things together? To me, it doesn't make any sense. And if anything, it suggests that our detachment from sunlight is what's causing melanoma and these problems with the pigmentary system. So that was sort of the UV portion. I want to talk about the other side of the spectrum that we don't see. And to start, there's a lot of nomenclature that gets thrown around, near infrared and infrared. What's the difference? Can I use them interchangeably? From my understanding, and this is the way that I characterize, near infrared is a thin part of the portion of infrared that is not strongly interacting with water molecules. So they are able to bounce around and scatter. Whereas infrared interacts very strongly with water molecules, which is why you get when you go outside and you put your hands over the fire, the infrared light is interacting with the water molecules and it's heating you up. Near infrared does not do that. Near infrared is not strongly absorbed by water. It's not strongly absorbed by very much at all in the body. And what that allows it to do is scatter. So it hits the body and it bounces through like a pinball machine. And this is a great sort of look into it. So the folding of the brain is actually a light guide. And near infrared goes straight through the skull. Even if you've got hair, it goes straight through and it's being scattered around. And you can see it shows up in the middle of the brain. Near infrared is going all the way through the body. Not directly, it's bouncing around, probably millions, billions of times. But it's getting very, very deep, not directly, but it's bouncing around. And a good way to think about this is the analogy of IKEA. Everyone's been to IKEA. They make you walk all the way around everywhere and you have to see everything before you can go out. That's what a near infrared photon is doing. It's going in, and it's bouncing around, going around everything because it's a weak absorber of most things in the body. So it hits something, weakly absorbed, bounces off, keeps going, and what that does is it increases the opportunity for that photon to hit something that it does interact with, which is present in the mitochondria. So that's the difference between infrared and near infrared broadly. Infrared has that heating element. Near infrared does very specific things in the body because it doesn't interact with water molecules, and of course we're mostly water. So I'm going to show you a series of images by my friend Bob Fosbury. These are near infrared photographs. And what you'll notice is when you're outside, plants and natural surfaces reflect near infrared almost at 100% efficiency. We cannot make anything that does anything remotely, anything like that. And the whiter the image, the more near infrared, the darker, the less near infrared. And you can see here, obviously you're standing up straight taking that photo. All of this near infrared light is being reflected at you horizontally. So even if you're standing in shade, you are being imbued with all of this long wavelength light and you can't see it. You don't know it's there. It's not infrared, so it doesn't have a thermal effect. You know when you're standing in shade because it's colder, but all that near-infrared light is being reflected straight back at you. And it's filling up the body because as it scatters, those photons stay in your body longer than it takes for another one to get in. So it's like inflating a balloon. When you're outside, you're getting gradually increasing the photon density within your body. And again, you don't have to be in direct sunlight to get this benefit. You just have to be outside. Windows get rid of this near-infrared. You can't be indoors. And that's one of the key things, like I was saying before. I can't be outside all day on the summer solstice. I will burn to a crisp. But once I've got enough UV, I can just go in the shade and I get the benefits of all of the other parts of the sunlight. And when you're in the shade, you get a change in the ratio as well. So you get less visible light and you get more near-infrared. It's very healing to sit in the shade or go for a walk under forest cover because the ratio of visible to near-infrared goes down. You get much more near-infrared. It's very healing for the body. And you can see all of these different natural places. Even though you can't see it, you can't necessarily feel it. You're getting absolutely hammered by near-infrared photons. They are everywhere outside. And the beauty of photosynthesis is plants don't like near-infrared light. And what they've done, I'm anthropomorphizing here, but they've donated that light to us. They've said, we don't want it. It's not useful for us. You have it. And of course, plants evolved before us, so we've gone, hey, there's heaps of near-infrared out here. Let's use it. And we have. But indoors right now, there's none. And this is a photo of Bob Fosbury's hand. So you can see the near-infrared basically goes straight through. Again, it's not direct, and the only strong absorber is the hemoglobin in the veins. And this is his olive tree. He puts this olive tree outside of his window, so he opens up his window in his office, and he's getting hammered with near-infrared photons. Even though he's inside, he just has to open the window, and this olive tree is donating all of this near-infrared to him, which is great. So the next slide is a picture of a near-infrared photo inside an office building. I haven't forgot to put the slide in. It is near-infrared dark. There is no near-infrared at all. It's not like there's a little bit. There's zero. Again, it's not a change in magnitude. It's a change in kind that we're experiencing. Again, this is his hand, and if you look at the optics literature, they say near-infrared light only penetrates about 1 millimeter. And you see this in some of the photobiomodulation papers, and you go, all right, every 5-year-old with a flashlight who puts it under their chin knows that red light goes much further than that, and that's because they don't understand scatter characteristics. This light is penetrating about 1 millimeter, but then it's scattering all the way through. So, our liver, our guts, our kidneys, when we're outside, are all getting near-infrared light. Not directly, but it's bouncing around, it's getting down to there. And you might be thinking, do I need to be naked? No, you do not. Near-infrared light is clothes are basically transparent to near-infrared light. So me even going outside with all this on, the vast majority of that near-infrared light is going straight through my clothing. So you may think, oh, there's no point going outside because it's too cold to take my clothes off. Get outside. Even if you're covered up from head to toe, all those near-infrared photons are still reaching your body. So just a brief look, I don't want to get too sciencey, but basically long wavelength light, this near-infrared and infrared portion of the spectrum has very, very powerful effects on bioenergetics, how we make energy. So when we're exposed to long wavelength light, the kind of light that is completely absent in this room, ATP production goes up, reactive oxygen species go up because they always go up together. Nitric oxide goes up, very important signaling molecule. Metabolic water goes up because you're producing more ATP, so you're generating more water, you're hydrating yourself better from the inside. Cell membrane potential goes up, which is very important because one of the primary signs of cancerous cells is their membrane potential drops. That's maybe the initiating factor. Magnetic field strength goes up because you've got more spin of that ATPase. Glucose goes down because you're using sugar. CO2 goes up because you're burning sugar. Biophoton release goes up because you're generating lots of reactive oxygen species. And your NADH to NAD ratio goes down because, again, you're using that NADH to drive a proton gradient. So many things are happening. This is really, really pivotal. And when we're standing inside right now, none of this is going on. We're not getting, and remember, this is the expected state. This is our body's expected state. It wants to be like that all day. And Newton was harvesting photons that were making his mitochondria function optimally. That's how he figured out gravity, when he was sitting under that tree. Didn't have to be in direct sunlight. He was getting all of that near-infrared photons reflected off that landscape right at him. So I want to briefly talk about circadian rhythm. I think this frames it really well. Nature does not hurry, yet everything is accomplished. Circadian rhythm is just like that. We just want to follow what it's guiding us to do. I'm going to read a passage. 5 minutes, okay, perfect. I can do that. Because it's very difficult for me to freestyle this, I'm going to read a short passage about what I think the importance of circadian rhythms are. So, evolutionarily, light has been the anchor of biology. It is the primary environmental input that determines periods of activity and rest, and is ultimately a primary vector for the limits of biology. Sunlight provides vital energy to all life on Earth. When it is absent, organisms must change their activities accordingly or risk potentially lethal limitations in energy metabolism. This stimulus of constant and reliable light-dark cycles, constant and reliable, drove the evolution of circadian rhythms. These rhythms are the roughly 24-hour cycles of activity and rest that are essentially exhibited by all organisms. These cycles govern countless physiological functions, including alertness, strength, hormonal secretions, appetite, gastrointestinal motility, uresis, thermoregulation, and even nasal dilation. The Earth's light-dark cycles have been so reliable and unchanging that evolution cemented it as the foundation upon which biology functions. The sun has always risen and set every day since the Earth has formed. So really, the point I'm trying to get across is biology really put this at the foundation. These light-dark cycles, can't get around them, they're there every day, so we need to orchestrate everything around them. And we've not done that because we can see nighttime illumination. And the more illuminated a place is, the higher the risk of cardiovascular disease. And there's a lot of people saying, oh, well, it's other factors, but when you understand the impact of light on human health, you see why this could be very well true. And we can track the light pollution across the last, half century. And the worse it gets, the worse the health outcomes get. And this is another study that also found increased risk of cardiovascular disease depending on the light density, artificial light density in the person's locale. So I think this really sets it quite well. Yes, circadian rhythms actually do affect almost everything. And I'll quote Rob yesterday. He said, when the clock's broken, anything can happen. And I think that's about as good as you can get. Rhythms allow the cell to anticipate regular changes so that the appropriate cellular activities happen at appropriate times of the day. Cells whose internal rhythms are out of sync with their environment do not grow as well as cells whose clocks are in tune. So I won't go too much on about there. So where to now? I really want to sort of unite these light-life interaction researchers in with the circadian researchers, because we've got this huge chasm between the two, and the reality is we need to realize that they're just two sides of the same coin. They are the same thing, and until we unite them, we won't be able to have really helpful advice about what to do. And I think we need to shift our vocabulary. I think this is really important to say that being outdoors in sunlight is not good for you. It's just normal. That's the normal expected state of affairs. It's not making your health better. It's just bringing you back to baseline. And I don't want people to start thinking, oh, I'm using my red light panel, it's good for me. No, it's not good for you. It's just you're deficient in light, and it's helping you get back up to baseline. Being in an outdoor natural environment is the body's expected baseline physiological state. I think that's the main thing I want to get across. we're meant to live outside all day. All right, not necessarily outside cooking with our clothes off, just outside. You just have to be outside. I want people to realize that these red lights, they're not good for you. They're just slightly better than the alternative. Remember, these lights have no near infrared, so they're still just as alien as the blue LEDs. They're not good for you, they're just a little bit better than the alternative. I want people to realize that blue blockers aren't good. They're just slightly better than the alternative. It's not the goal. We don't want to, again, we're narrowing down, 450 nanometers is what interacts with melanopsin. Therefore, if I block that, I'm good. Again, we're so zoomed in. What's the problem here? Like, we don't even know what it is that the problem that we're looking at. Blue blockers are, they're useful, but they're not a solution. They're just slightly better than the alternative. And we've got amazing companies like the Daylight Computer. We've actually got people out there who are looking out for their customers and trying to make technology safe, which I think is something we can all get behind, because we're not going to let go of technology. We need to actually learn how to use it safely and effectively. And this project makes me very optimistic about the future, because there are people out there going, we can do this properly. We're smart enough to actually do it correctly. And a friend of mine, Scott Zimmerman, he's actually found a way to get around the Department of Education, Department of Energy, and make incandescent bulbs that meet their standards. It took him a very long time to do that. And these bulbs have broadband near infrared. And before anyone asks me, they're not available in Australia yet. I'm working on it. But this is a massive step in the right direction. So this is where humans are supposed to be. This is where we're supposed to thrive, outdoors. That's the main message. Thank you.
Cameron Borg!
We're going to do questions or no?
We sort of went over time. They said we'll have to wrap up. Yeah.
If anyone's got any questions for Cameron, we can do it in the break. He loves to talk, but that was incredible. I've already burnt my blue blocking glasses, bro. Thank you for that. They're gone. All right, we've got to keep the show rolling. But if anyone wants to go to the toilet, have a little quick stretch for a second, we've just got to set up here. Have a stretch. More than welcome. More than welcome. It feels good. Yeah, just shake it out. Don't go outside. Yeah, no, it's not a break. This is just like, have a breath. Have a breath. Where are you going? Where are you going? Well, I suppose because I got the microphone, I'd like to ask Cameron a question. Yeah. Hey, Cameron. Since we're just having a bit of a stretch, and I said there was no questions, but I've got the mic. I did have a question. What's your thoughts, even if you want to come up here, beautiful. What's your thoughts about the whole idea so when I went carnivore, right, and I cut out a lot of linoleic acid, omega-6s and that, seed oils, I used to get burnt so quickly, about 10 minutes in the sunshine. I was like almost translucent sort of skin. Yep. But then I got rid of, seed oils, jumped on the carnivore diet, upped my saturated fat, and my tolerance to the sun absolutely increased. Like, it was day and night. Yep. What's your thoughts around that? Is there a correlation there? Is there something going on there?
If there is something to do with linoleic acid, I don't know about it, but there's probably 1,000 things going on. In reality, what you were doing was completely changing your nutrient intake. Lord knows what the downstream effects of that was. More zinc, more copper, in better ratios. Just who knows? And you were probably doing other things at the same time. If there is a relationship between burning and linoleic acid, this gets thrown around a lot. If there is, I don't know about it. It wouldn't surprise me, but I don't really know, because where omega-6s are available, is close to the equator where there's more UV light. So
Oh, wow.
I don't know. I suspect it's probably less important than people say it is. But at the end of the day, I mean, you don't want to be eating any sort of vegetable oil anyway. So it's kind of like, well, doesn't really matter. You know, don't eat it. And if that does happen to make an impact on whether you're burning or not, great. But the goal is the same. So who really cares what it is that's helping you stay out in the sun longer? Again, we don't need to zoom all the way in. We just know that it works. So don't eat things that are not food and that are engine lubricant, and you'll probably do better.
Yeah.
But there's probably 1,000 things going on when people are eating more meat-based diets and cutting out engine lubricant. Who knows what's going on? But I suspect that might be a small part of it, but it's certainly not the whole story.
Yeah.
But again, you don't need to know why. Just know that it works.
Know that it works. And I suppose as you're saying that, there's many things happening at once. I was watching the sunrise, getting red light on my skin, I guess developing the solar callus, if you will.
I suspect that was having a bigger impact. But again, it's all part of the same story. You're trying to make your body more capable of recognizing where it is and what exposures it's being given. So, yeah.
Awesome. All right, thanks, brother. Cheers. All right, we ready to rock?
I better give this back to you.
You all good? Find your seats, guys.
Thanks, Cameron.
Unless you're weeing, do not find your seats if you're weeing. I repeat, do not find your seats if you're weeing. Come on in. Well, while we're waiting here, who came to the cold plunge this morning? Yes. We had about 20 there. My toes are still as cold as a polar bear's toenails, that's for sure. But we got a hot shower in afterwards, which was nice. Not together, we just had a hot shower afterwards. It was beautiful. All right, yeah, come back in. Let the kids go, they're fine. Not interested in quantum health, whatever. All right. Are you guys ready for your next speaker? Yes, that's what I'm talking about. You might have seen this guy around the traps, just saying. He is a practicing medical doctor, GP registrar, a circadian and quantum health advocate and educator, the host of the great Regenerative Health podcast, and the co-founder of Regenerate. Please welcome to the stage, presenting his deep dive talk today called Artificial Light and Diabetes, No Food Required. Give it up for Dr. Max Gulhane.
Thank you, Scotty. And my talk today is going to be very much a continuation of the themes that Cameron has so eloquently and comprehensively talked about. So what I want to do is to give you guys an idea about what artificial light is, how it's different to natural sunlight, and how these environments that we've created, these sunlight, infrared deficient indoor environments, how they might be contributing to one of the most important diseases in society today, which is metabolic disease and type 2 diabetes. So a little bit about me as the kind introduction. That's all you, more of the same. And some disclosures: I don't have any funding by any company or organization, and there's nothing else relevant from that point of view. I want to start with a quote, and this is from quite a esteemed circadian researcher named Dr. Martin Moreed. And in this paper, he makes the point that for the first 10,000 generations of Homo sapiens, the contrast between bright daylight, between 10,000 and 100,000 lux, and nocturnal darkness robustly entrained the human circadian timing system to the Earth's 24-hour rotation. However, For less than 4 generations over the past century, this natural 24-hour cycle of daylight and darkness has been replaced in the developed world by electric light. Approximately 90% of our time is now spent indoors under electric light that is typically 100 times dimmer during the day than natural daylight and 1,000 times brighter after dusk than even the brightest moonlight. And this is the study, and it was done in 2001, and it surveyed around almost 10,000 Americans. And what they found was that the time that these people and these average people were spending in their daily activities amounted to 87% of their time indoors and an additional 6% in a vehicle. So close to 90% of their day was in a light environment that is unnatural, that is filtered light. And this is going to be very relevant for the whole talk. So what was the ancestral human existence? Again, it was very bright daylight throughout the day and a nighttime sky predominantly dominated by moonlight, which was reflected from the sun. Where do we live today? We live in these chambers under compact fluorescent light lamps, under cool white LEDs. And at nighttime, we've illuminated our environment. So the question that I want to really examine in this talk is the implication of artificial light for obesity and diabetes. And I hope by the end that you'll take away some points that the light environment is critically important to your risk of developing type 2 diabetes, for depositing dangerous visceral fat, and for generally suffering the chronic health issues that are attendant and go along with metabolic syndrome and metabolic dysfunction. So let's start again with an overview of natural sunlight. And this image is measuring the spectral emission of the sun with a spectrometer close to sunset. And it, as you can see, it has some very, very unique characteristics down on the screen here. It is giving us a broad emission of both visible and non-visible light. It is a thermal light source, meaning that it is emitting so much energy that we can perceive that as heat, standing all that distance away on planet Earth. And quite importantly, it has a constant light output. There is no flickering of natural sunlight. And that's going to be in stark contrast to the lights, thankfully, that we're sitting under today that we've turned off. Here's another pictorial depiction of what is happening throughout the solar day. And what you can see is that there's variation in the wavelength and color temperature as the sun rises and sets throughout the sky. And in the mornings and in the late afternoons, it's dominated by visible light, but also by longer wavelength infrared and red lights. And then as the angle of the sun climbs in the sky, the ability of the atmosphere to absorb the shorter wavelength photons is less, and they get through first as UVA or ultraviolet A light, and then when the sun is beyond a certain angle to the Earth, then we're getting the most high energy UVB light. The key point that I really want everyone to remember is that blue light is always paired and balanced with red and infrared light in nature. Here's another way of thinking about or essentially depicting natural sunlight. And we've got the wavelength on the bottom, and we've got essentially the amount of energy on this axis here. As you can see, UV, the much maligned ultraviolet light, is only making up a very small part of the solar spectrum. But here, in this massive area, is non-visible infrared light. And this is a critical light nutrient that we're going to talk a lot about in this talk. So while most of the power, the solar power, is in the visible spectrum, by percentage of photons, the greatest are in this non-visible infrared area. So why is this important? It's because solar radiation, not artificial light, were the optical conditions of existence for all life on Earth for the past 3.4 billion years. And no matter what domain of life, bacteria, archaea, or eukaryotes, all of these, plants and animals, we all evolved with natural sunlight, and that cannot be replicated. I want to give you a little history overview of how artificial light was invented and how our relationship has been with light throughout history. Depending on which source you read, it's suggested that humans domesticated fire between 1 million and 780,000 years ago. Prior to that, again, it was simply sunlight during the day and moonlight during the night, with perhaps occasional lightning strikes. In 1879 was the invention of the Edison's incandescent light bulb, and there were a whole bunch of scientists working on this problem. But the innovation of artificial light was one that was swiftly taken up once that technology barrier was breached. In 1893 was a really inflection point, because that's when electrification was really proven on a large scale at the Chicago World Fair. 1939, the first fluorescent bulb was displayed in New York at the World Fair. And then fast forward to 1996, the first white LED light bulb went on sale. 2007, somewhat of an inauspicious time, and that was that both the Nobel Prize in Physics for the invention of the LED light bulb, but also the passage of a legislation in the US, it's good now, I turned it on, it's fine, that essentially is beginning to act as an effective ban on incandescent bulbs. And I'm going to explain why that is such a problem. So, an incandescent light bulb. These emit both visible and non-visible light. And you can see by these spectral graphs that there's this balance here. And although they only end at, or just go beyond what we can see, if you extended this graph, you would see a nice big emission of infrared. The halogen is a form of incandescent bulb that has made some changes to increase its lifespan, and they are similarly emitting this non-visible light and therefore termed inefficient. But what the problem with that depiction of inefficiency is, it really misses the point that this infrared light is a critical light nutrient. The other way of term is called a thermal light, and that is obvious because it emits heat. So what if we contrast this with a non-thermal, or this light that was invented more recently? These are the emission spectrum of a cool white LED. Look at that massive peak of blue and a lot of green, and there's almost no red and infrared. Similarly, the fluorescent bulb, the compact fluorescent bulb, is even more of an alien spectrum with almost unrecognizable characteristics, light characteristics, compared to natural sunlight. The other problem with this type of lighting is that there's flicker, and that is just a fact of how the technology is designed, is that it is rapidly turning on and off and on and off. And that has significant consequences for our health, especially with conditions like migraine. And this is also called visible only light for obvious reasons. So I think if there's one diagram for you to take away from this presentation, it will be this one. And that shows you so clearly how different our light needs are today, are historically, compared to what we are existing under in today's day and age. So let's frame this problem. The modern indoor lighting problem. Most people are spending 90% of their time in these hermetically sealed chambers, exposed to less than 10% of the natural solar spectrum that their body needs to run physiological processes and operate optimally. I thought this was a very telling and interesting study, and this is self-reported use of melatonin supplements in US adults from 1999 to 2017. And melatonin, it's obviously being used by people who are self-medicating to assist in insomnia or poor quality sleep. What happened in 2007? That was the effective banning of this infrared lighting. Thermal lighting that contained some degree of infrared. And you can see quite prominently how this use of this essential supplement medication is increasing. So the question is, how does light interact with our bodies? And this is a very, very complex topic that I'm going to touch on in brief. But importantly to know is that the light interacts with our eyes and our skin, and it does so in analogous but also quite unique ways. This image here shows how the different wavelengths of light that we've discussed influence the depth to which the light is penetrating. And the shorter wavelength, higher energy light is more superficially absorbed, and the visible light penetrates even deeper the longer you go. And as was mentioned previously, near-infrared, through its ability to scatter, can penetrate quite deeply, several inches or up to 10 centimeters at least. The critical thing to understand, and I think this is a paradigm-shifting moment for anyone in conventional medicine or in any form of alternative or complementary therapy, is that each wavelength of natural sunlight is in itself can be thought of a nutrient or a medicine. And that means that you can't exclude one of them and expect to be meeting these basic light needs that we've developed over these billions of years of evolution. There's some overall categories of ways of thinking about these light nutrients. There's UV light, vitamin D production, pro-opiomelanocortin stimulation, nitric oxide stimulation, that's all occurring with this shorter wavelength UV light. Circadian signaling is something that's happening with this more of the visible, particularly blue, green, and a little bit of UVA light. And then the longer wavelength, red and infrared, is really what is happening with it's causing water interactions and stimulating mitochondria. I'm not going to talk about the UV light because I really want to focus on the circadian side of things and the red and near infrared. And that is because the domain of UV light it's sunlight, and that is what we've heard so eloquently from Cameron so far. But the spanner in the works that this lighting, these artificial lights are having, are predominantly in the form of a toxicity, an excess and toxicity of visible blue wavelength light, and a deficiency of red and infrared. So circadian biology, this is a process that underlies so much of what is going on in your body. And how it works, and it's quite complicated, but it is incredibly important to understand, is that the light wavelengths, predominantly blue, are received by the eye. And these signals enter the eye and are essentially passed along a neuronal superhighway, an incredibly fast neuronal connection between the retina and the hypothalamus of incredible speed, and where that light informs the programming of a clock, and it's not just any clock. It's your master clock. It's your Big Ben, and it is running and having hierarchy. It is orchestrating the clock timing of all the other clocks in your body, and that is why the light signals are the most impactful in terms of programming your circadian rhythms. And not to say that light signals on the skin aren't important, they are, but in terms of the hierarchy of importance, the light through the eye is key. And when we think about what is happening today with rampant device usage, people on screens, 10 centimeters from their eye till 11 p.m. every night, and you understand how critical that ocular information is to orchestrate all these endocrine and hormonal programs, then you really start to understand what kind of damage is being done to kids, to adolescents, to everyone. One of the key pathways that this light signal, the circadian blue light signal, is regulating is that of melatonin. Melatonin production from the pineal gland. We mentioned it briefly before, but melatonin will put you to sleep. It helps you maintain the depth of sleep. It kicks off repair mechanisms in your cells and helps do cellular garbage cleaning. The pineal gland, when you get that blue light, it stops making melatonin. That's a natural thing that should happen when you go out and see the sunrise and you get that blue wavelength light. That is normal and healthy. But what is not normal and healthy is exposing yourself to artificial light at night and turning off melatonin when it's supposed to be helping you fall asleep. Melatonin is not only made in the pineal gland, and we're going to talk about that, but this is the circadian circuit that is very, very important and really underappreciated by medicine and by mainstream treatment. The last point I'll make is that there's a special light detecting protein, and that's called melanopsin, that is particularly responsive to blue wavelength light. And it ties back to this little critter, the African claw frog. And you might be thinking, what on earth does this have to do with light reception? Well, it turned out that the African claw frog was the first animal that we discovered the presence of this melanopsin blue light detecting protein. And this frog has this melanopsin protein in these what are called melanophores, or little, cellular compartments that help it change its color based on the ambient light in the environment. So it is sensing light, it's sensing daylight through these blue light detectors and helping it adapt its skin color to anticipate changes, to avoid predators and the rest. The other point is that melanopsin, like I mentioned, a blue light detector, it's not the only one. Neuropsin and enkephalopsin, and there are whole families of other of these opsin proteins that biology has evolved in different species at different times to help sense different light wavelengths and therefore help the organism essentially survive. The interesting thing is that melanopsin is present in us. We have an ancestral relative in our eyes, in our retina, as I mentioned, in our retina, and in our skin of melanopsin. But not only in our skin, but also in our blood vessels, in our fat cells, and in deeper brain regions. And what it's doing is it's taking in environmental information. It's taking in light information from our environment and as well as temperature information, and feeding that in to the circadian machinery so your body knows exactly what time of day it is, what season it is, and it's using that information for a range of critical functions. So we are walking blue light detectors. What do you think the implications are of putting blue light above us 18 hours a day if you're a walking blue light detector? Sounds a bit to me like a spanner in the works. So how do we think about circadian biology? This is one way of thinking about it. I don't know if anyone's seen The Wolf of Wall Street. It's a very busy office. They're calling people constantly the whole working day. what is happening in the office during working hours is not the same as what needs to happen after hours. After hours, the place needs to be cleaned, the toilet rolls need changing, the carpets need vacuuming. What would happen if the cleaners came onto the floor at 11 a.m. when these guys are trying to scam people with cheap stocks? It would be chaos. It would be complete chaos. Circadian biology is cellular timekeeping to coordinate opposing physiological processes in the body. That's not the only, but that's one critical way of thinking about it. So you don't eat, the time you're sleeping, you're not eating. And there's a reason for that, because they're opposing, and you don't want to be doing it at the same time. And it's not efficient for the organism to be able to do them at the same time. How else can we think about circadian biology? I like this, and it's a yin and yang, the Taoist symbol, with a clock overlaid. The yin and yang signifies duality and symmetry. Just as bright daylight is critical, so do you need a complete absence of light, or simply moonlight. You can't have one without the other. You need both. And it's not good enough to be outside, but to be illuminated with devices at night. And so it's suboptimal to be sleeping when the sun goes down, but to not get enough sunlight during the day. Why is the clock important? Because the clock is telling the time and feeding that information in. The other point is that this clock and your circadian clocks are not quite 24 hours. And they're not quite 24 hours because they require that constant updating and synchronization from the environment via those melanopsin and other opsin light sensors. And why do you think this might be the case? Well, think about what happens over a season. Is the day length the same? No, the day length is changing. So the organism and your body needs to change its internal timing to match the timing that's occurring in the environment. So it's cellular timekeeping to synchronize to environmental light signals. Now this is a technical slide, but I think it's important to briefly touch on, which is the clock mechanism that I've described involves a very complex and intricate but very elegant way of conducting timing. And that's when these clock proteins, they go into the nucleus and they make some other types of circadian operating proteins that then go back into the nucleus and act as a negative feedback to stop their own production. This is how this negative feedback loop, it's called a transcription translation feedback loop, is how the body tells time. It's incredibly elegant and it's conserved, meaning it's happening in every cell of your body, and almost every organisms have a similar mechanism. How does this relate to diabetes and metabolic health? Well, it turns out that there's clock timing mechanisms in every single one of your most metabolically active tissues. So clock timing and circadian timing is regulating your master clock that's influencing your whole body insulin sensitivity, your food intake and your energy expenditure through those pathways into the hypothalamus. It's regulating your gut clock, and you can think about how important that would be so that your body's ready to absorb food at the right times. It's influencing your pancreas, and it's influencing the secretion of insulin and the timing of when that insulin is going to be sensitive and received appropriately. So the key points is that we are set up to be metabolically healthy if we're getting light signals at the right time of day. When there's chaos through artificial light, then we have chaos through our metabolic health. This study was a very elegant study, but it essentially exposed two groups, one to bright light and one to dim light. And it was only for a single night, and these were in healthy participants. These weren't in people with pre-existing diabetes. And what they found was that the serum blood glucose levels and the serum insulin levels were significantly associated. The bright light was associated with a significant increase in both of these plasma glucose and insulin, suggestive of glucose intolerance. And you can see how effective the bright light was, because it knocked their melatonin down, as we mentioned earlier. So this all occurred with no food. There was no food ingested. This is an elegant explanation or proof of concept that we don't need to eat the donut. We don't need to eat the Krispy Kreme or drink the can of Coke to raise our blood glucose and raise our blood insulin. It's simple. It's sufficient to be under artificial light to do that for us. Excess blue light causes diabetes, and this review, the metabolic implications of exposure to light at night, lessons from animal and human studies, it shows that artificial light and circadian disruption alters the expression of clock genes in the brain. It alters clock and metabolic genes in the liver. It contributes to lipid accumulation. Has anyone been told they have fatty liver? There's a circadian reason for that. It reduces glucose sensitivity and insulin secretion, and it dampens these amplitude of these key oscillating proteins. What about in large populations? This observational study showed that the prevalence of obesity, diabetes, and hypertension was significantly higher in older adults with light at night compared to those with no light at night, after adjusting for a priori covariates of age, race, sex, and season, as well as measures of sleep and activity. That basically means if your grandma sleeps in her bedroom with a light on, with light pollution in her bedroom, depriving herself of complete darkness that we've explained is necessary, then she's at risk. She's at risk of developing insulin resistance, of putting down fat around her abdomen, getting insulin resistant, hypertensive, and eventually diabetic. How's another way of thinking about what's happening? Circadian misalignment, when we're exposed to light at night, or if we are intaking food too late, if we're eating at 10 p.m., 11 p.m. at night, we are desynchronizing those peripheral clocks that I talked about in the gut and in the liver and the pancreas from the central clock in our brain that is being received through our eyes. And that desynchronization, that circadian misalignment is driving in large part these disturbances in our metabolic health. I could go on. Circadian rhythms disrupted by light at night and mistimed food intake alter hormonal rhythms and metabolism. Chronic circadian shift leads to adipose tissue inflammation and fibrosis in a mouse study. And these mice were essentially replicated on shift work. They were given a shift work schedule. And they were given the same food as the other mice. But after 6 months, they had fibrotic fat, they had more subcutaneous and visceral fat, and they were insulin resistant. No change in the food. Circadian dysfunction induces leptin resistance in mice. The pathways are consistent and well demarked to connect artificial light at night to metabolic disease. Let's talk about red and infrared and how that is relevant. And like I mentioned, it's a critical nutrient that we are now becoming deficient in. This study is possibly the most elegant and simple illustration of the effect of red light on blood glucose. And all that happened was a group of people and a group of controls. One got 15 minutes of 6-7 nanometer red light on their back prior to a glucose challenge. And people might have drunk the 75 grams of glucose through their doctor. Through Dr. Rob might have written a script for that, or not anymore. And what they found was that the pre-treatment compared to placebo was that the blood glucose in those who received the red light was significantly lower. And that's an incredible finding. It was up to 27%, because these people they had the same amount of glucose. They had everything else was kept the same. It was a randomized controlled trial. The important point to note was that in this group, they measured an increase of carbon dioxide coming out of the mouth and the nose of these people, meaning that the red light was revving the mitochondrial engines up. The exhaust of your mitochondria is carbon dioxide. So the red light was essentially turning up the engine and essentially burning more glucose. It was sucking the glucose out of the system. Melatonin and the optics of the human body, possibly one of the most landmark, most important papers of the past 5 years, longer, that I don't believe has received anywhere near amount of the reception that it requires. What Scott Zimmerman, who's not even he's actually an optics engineer, he's not medically trained at all. What he did was optic modeling of the absorption and scatter of light of the human body. And what he found was that this near-infrared light, this light was penetrating deeply into the body, and it has a critical role in generating melatonin, but not in the pineal gland, in the mitochondria. And the critical difference is that melatonin is not only having a sleep effect, but it's having an antioxidant effect. And just like people take vitamin C, they take the latest superfood to get an antioxidant effect. Well, it turns out that your body over more than 3 billion years, because melatonin is found in single cellular prokaryotic life, it's innovated the most efficient antioxidant basically known to biology, and that's melatonin. So melatonin is being generated inside your mitochondria on exposure to near-infrared light. And that is why it is such a profound light nutrient, because melatonin is how you defend against cancer. Melatonin is how you defend against oxidative stress. And this is critical. What do they say? They said that near-infrared photons are scattered several inches into the body, even through the skull. And Cameron mentioned the exact same finding. Due to the low optical absorption and an isotropic effect, the scatter of the scatter in the human body at this wavelength range. So what's it doing? This near-infrared light from the sun is penetrating through our body. It's getting into cells. It's getting into these mitochondria, these little organelles, these power plants of our cells, and it's helping us make this antioxidant compound melatonin. And it's, in terms of the total body production of melatonin, this melatonin actually dwarfs the amount that gets made by our pineal gland by something like it's an order of magnitude at least, which is, again, something that is unknown to the circadian researchers and most of science at this point. So humans are optimized to harvest near-infrared light. Just like I mentioned, we are designed to sense blue light. We are designed to harvest near-infrared photons. And this is the same diagram that was shown previously. And what they say is that the cerebrospinal fluid, the liquid around your brain and your spinal cord, optically acts as a light guide, distributing the near-infrared photons, scattering off the surface of the brain, even into the deep folds of the brain. And they needed an optics engineer to find this out. No one in medicine had the skill set, the intellectual paradigm to even ask this question. But Scott Zimmerman, who is approaching this problem from a completely different perspective, did these measurements and noticed strikingly the optical characteristics of our body was similar to that he saw in aerospace, that he saw in automotive industries that are using different configurations and designs to essentially reflect light. And it turned out that Mother Nature has done the same thing. So what that means is that this infrared must be so critical that your body has given you an ability and wants all this near infrared to enter, and then as Cameron mentioned, ping pong around. The near infrared photons aren't absorbed like blue is by that melanopsin type protein. It's not absorbed easily like UV light is to cholesterol. It ping pongs around, and in the process of ping ponging around, eventually penetrates deeply and then is having this effect to stimulate melatonin production in the mitochondria. It's also structuring the water inside your body, but that's a talk for another time. What else? And I think this is relevant for Mel and anyone who's in obstetrics and women's health, because it turns out that it's not only the cerebrospinal fluid that is concentrating this near infrared light. The fetus is surrounded by the amniotic fluid, which has a peak transmission in the near infrared, forming a dielectrically filled integrating sphere surrounding the fetus, ensuring uniform exposure to the near infrared photons impinging on the mother's belly. I mean, how profound is that? That means that Mother Nature has designed a system that values near infrared light, the light that they've taken away from you with this artificial light here. It values it so much that it is essentially encasing your baby in a fluid that means that it can harvest as much of that light and as many of those photons as possible. Yet we're being told to avoid the sun. What are the implications? It's so profound that we're only scratching the surface of what this means. And it also speaks very strongly of the requirement for women to get outside and get some sunlight, not necessarily with exposed, but there's other benefits, but simply be outside in natural sunlight. What is another way of thinking about how these effects? Well, red and near infrared light are directly being absorbed by these cytochromes on the electron transport chain in the mitochondria. These are like the pistons of the engine. These are the pistons of the power plant, the battery of your body and your cells, and they're directly receiving this light. So what is it? It's like a mitochondrial lubricant, because it's helping the head of this fifth complex spin better. So without red and near infrared light, if you live indoors in a cave, you're depriving your energy making apparatus in all your cells of the lubrication it needs to operate optimally. I mean, we've got a lot of farmers in the audience. What happens if you don't change the oil in your tractor for years on end? It's going to seize up. Your engine's going to wear out and seize up. Well, the same thing is happening with you if you avoid the sun. And what else? The subcellular melatonin that we talked about was being generated. That is acting like a coolant, because this process of energy generation is developing reactive oxygen species. And those reactive oxygen species damage mitochondrial DNA. And when the mitochondrial DNA damage occurs, the cell stops being able to produce energy properly. And all of chronic disease, 95%, depending on who you talk to, Dr. Doug Wallace of the Children's Hospital of Philadelphia, of chronic disease is a bioenergetic failure. You get diabetes, you get neurodegenerative disease, you get cancer when your cells stop making energy properly, when your mitochondria stop making energy efficiently and your cells have a brownout. The cellular brownout, if that continues over decades, manifests as cancer, it manifests as diabetes. It just depends which organ that problem manifests in. And that's also related to genetic predispositions and a range of other things. So red and infrared light, this forgotten part of the spectrum, is fundamental to improving mitochondrial function. How do we know this is, another way we know this is effective and efficient? Well, there's a whole scientific field of photobiomodulation that relies on the therapeutic use of red and near infrared light. So people who are saying, red light is quackery, you can just jump onto PubMed and find the therapeutic effects that the clinicians and scientists are getting by applying these light wavelengths to an amazing range of diseases, from improving symptoms in Alzheimer's disease, improving muscle recovery in musculoskeletal injury and athletic performance. So it's fundamental. This is photobiology. This isn't quackery. It is fundamental photobiology. So there's a twofold problem here that I hope you are appreciating as we've got this far. The first is blue light toxicity. It's an excess of artificial light at night, and it's causing circadian disruption, and it's causing a disruption of our circadian cycles. And the second is an absence of full spectrum sunlight, including near infrared and red, from indoor living. Insufficient sun exposure has become a real public health problem. So this is another way of looking at the same problem. And we already know that a lack of sunlight leads to poor health. Those with lower vitamin D levels live less and suffer an increased incidence of almost all chronic diseases. Well, why do you now know why that might be the case? Is because when you get insufficient sun exposure, you're getting a lack of both UV light, which is showing up as vitamin D deficiency, but also UVA and near infrared, and all those non-vitamin D related pathways that Cameron mentioned earlier that are critical for health. So how do you create diabetic lighting? I'll give you a recipe. You disrupt circadian rhythms with blue artificial light at night. You provide an environment where blue light is present without red and infrared. And you deprive yourself of 90% of the natural solar spectrum, and you do that every day for 20 years. Well, it just turns out that is what is the reality today. And that is the reality that's actually been created and facilitated by your government, by government regulation, by government intervention in our right to choose human appropriate lighting. This is a provocative point that I'm going to leave here, and it's very rhetorical. In the past 140 years, and since the development of the electric grid, do you think that there's been a comparatively radical shift in the composition of the human food diet versus these light changes that I've just discussed? And this is a meat, potatoes, and veg dish that probably could be from 250 years ago, and it's a burger and fries. Something for you to think about. So let's talk solutions. What do we do about this? We need brighter days and darker nights. Very simple. Be outside during the day, and when the sun's gone down, turn your lights off. And I don't think I've heard as elegant a circadian appropriate routine in a long time as yesterday Cindy's routine. And I think that is a model of to copy and to aspire to. And that is appropriate, circadianly aligned routine that will ensure that you are respecting your circadian rhythm, that you are giving your body these critical light signals, and that you are essentially creating molecular order, allowing those cells to do what they need to. You need more time outside, and we can't see infrared, but specialized camera technologies can. And the ground, the leaves, the chlorophyll-rich leaves are reflecting this light for us. And maybe if you want to take a theological bent, you might think that, the plants are providing this for us. They're reflecting it for us to use. Whatever your perspective is, you need to be out there, because that is how you can get it. And yes, you can get it through clothing. And that is courtesy of Professor Robert Fosbury, who's an astrophysicist, like Scott Zimmerman, who's approaching light and biology from this radically unique perspective, and really having profound breakthroughs in our collective understanding and education about these topics. What else? You need more daytime sunlight. You ideally would be sampling a little bit of this light information at every part of the solar day. If you're pale-skinned in Australia, there's a mismatch there. You don't have as much melanin in your skin compared to the Indigenous people, compared to the Indigenous Australians. That's okay. You just need to be careful with a high-intensity UVB. You can still be out. You can be completely naked early in the day and night, because there's not a large UV yield to do a lot of damage. You just have to use the shade. The opposite problem is actually much worse, which is if you are darker skinned and you're living in Tasmania, if you're from the equator and you're living in Tasmania, that's a mismatch that is much more difficult to reconcile. And the first advice that I would always have for someone like that is you need to move. It's harsh, but it's who's seen a coconut? Who would plant a coconut grove in Norway? It sounds ridiculous, doesn't it? Imagine trying to grow coconuts in Norway. Our photobiology is different, but is not so different from plants that analogy is somewhat applicable, and that is why people with darker skin types do so poorly in psychiatric illness, in metabolic health, infectious disease, COVID susceptibility, if they're living at a latitude that is so far north and different to the ambient light conditions that they evolved with. the light should be unfiltered, because there was no sunglasses, there was no sunscreen, there was no contact lenses in our ancestral past. And that filtration, it changes the way the light messages are sent and received. You can even build your solar callus, and that is, again, to harness health benefits, including the ultraviolet light. So you want to minimize light at night. Again, ideally there's none. Ideally it's darkness, but we all have lives, we all have work, we all have things that we have to do. So one option is candlelight. One option is an LED, but it's a red LED. And if you put these closer to the ground, at ground level, your interference with that pineal gland's melatonin secretion is less. Again, it's not ideal. These are mitigation steps, but it is preferable to going home, flicking on the LED downlights, and blasting yourself at 10 p.m., 9 p.m. with a daylight signal. You can block blue light, and remember, the eye has the most concentrated density of those melanopsin blue light sensing proteins. So if you have to, this again, it's mitigation, then wearing a pair of blue blocking glasses, it will definitely help. Put infrared light back into your environment. And incandescent bulbs, they're now contraband. I don't know, maybe someone will start running light bulbs in a smuggling operation. You guys will be the first to hear about it. But these are banned now. And they're banned because they are inefficient, in inverted commas. But now, they're not truly inefficient. They're giving you an amount of this red and infrared that you truly need to thrive. And yes, it'd be better if you were outside and you had your office outside and all the rest, but this is the next best. Again, Professor Robert Fosbury, he's made this really elegant workaround, and what he's done is he's got a really small incandescent bulb running at a very low voltage, and that gives us that nice big red and infrared area, and he's paired it with a visible only LED. So what it's allowed him to do is generate a more human-friendly light environment, it's actually quite easy for everyone to do. And you can see that if you take a photo with that near-infrared camera, then it's emitting some. And really, we need to start advocating against this visible-only lighting, because it is optimization in the wrong direction. It's a misguided attempt at improving human health, but it's so myopic that it doesn't realize that it's really, the law of unintended consequences is doing a lot more harm than good. And these decisions are being made by bureaucrats, by people who have no understanding of the data that I presented to you and the effect of light on health. So in summary, humans are walking blue light detectors and near-infrared light collectors. Modern artificial light, indoor lifestyles, and sun avoidance are driving obesity, diabetes, and metabolic disease. In part, not the only mechanisms, but in part via circadian disruption, near-infrared deficiency, and mitochondrial inefficiency. Collectively, we need to shift attention away from pharmaceutical, supplements, and diet-only therapies, and to understand the critical importance of light. We need to increase outdoor time and sunlight. We need to reintroduce human-appropriate lighting and consider the use of things like photobiomodulation where appropriate. And consider, based on everything that I've said, that your health issue might not be first and foremost a light problem. And that speaks to the centrality of light and circadian health to what is happening in your body and in biology. If you want to learn more, I've got a couple of courses that deal with the yin and the yang that I mentioned. Circadian reset for avoiding light at night, and solar callus for safely getting and harvesting UV and daytime light. Thank you for listening.
Dr. Max Gulhane, everybody. We're running a bit behind, so if anyone has any questions for Max, let's do it in the break now. We've got 15, 20 minutes. get up, go stretch your legs, get in that sunlight. We've just learned all about it. And we'll see you back here in about 15, 20. Keep chatting amongst yourselves. So we got the latecomers. Come on in. Let me know if I got any like liver or kidney in my teeth. I was just going ham on that grassland nutrition. You can smell from there. You can smell it. I'm so sorry. You guys tried that? You had any samples of the Dries fried? I could imagine fried up would be next level. Yes, come in. Grab that door behind you when you're good. Come on in, Max. It was so good after the cold plunge this morning. We jumped out and Max disappeared. And I'm like, where's Max? And we look over in the children's playground and Max is on the rings just doing chin-ups. What a beast. You should see him without his shirt on. Jeez. What's that? It's so warm in your bed. I don't blame you. But bro, you missed out. We were snuggling in the Tarago. You missed out on that. You missed out, dude. You say it again? A tribe, yeah. We overcame some adversity together, didn't we? I was crying on the inside. That current is strong, man. That took me. Look at me, man. I'm like 60 kilos. I was gone. I didn't want to say it, but I was panicking. I wanted to look cool. I wanted to look good. What's that? Yeah, I know. Tell me about it. Yeah, the Lismore floods. Don't give me my PTSD. No. It's fine. I was born in Lismore. I don't really mind. I get it. It's something that happens to that town. I just now see Lismore as just kind of like a shit sea world. That's fine, right? That's fine. All right. Are you guys ready for your next speaker? Are you guys ready for your next speaker? That's what I'm talking about. Bring that energy. All right. Our next speaker today is a quantum health clinician and educator, an advocate for preventative medicine with a focus on mitochondria and circadian healthcare, helping clients reclaim their health, living aligned with nature and its natural rhythms. She's the co-founder of the Quantum Health Academy and the host of the Health Standard podcast, presenting her talk today called A Quantum Health Perspective on Hormones. Please go wild. It is Kiera Lee. Keep it going. Woo!
Hey guys, how you going? That's good. So before I start my speech, I just want to say a few things and thank a few important people who have helped me along my journey to becoming who I am today. Because I feel like in our society, we like to think that we get to where we are all by ourselves, but that's not true. Whether it's a grandmother who stepped up when our parents were absent and supported us in a time of need, or a great-grandmother who prayed over you before you were even here. You're sowing the seeds of someone else's work. Whether it's a positive compliment from a teacher that you've cherished and held with you for most of your life. We didn't get here alone, but we like to think that we did. And I definitely didn't get here alone. I want to thank Dr. Max for supporting me and helping educate me through my journey. I would like to thank someone very, very important that most of you know if you're at this crazy event, and his name is Dr. Jack Cruz. Give him a clap. He is a remarkable man. He has taught me so much about myself, about life, about how to interact with people in different manners, and it's really helped me develop my character, so I appreciate him a lot. Lastly, I would like to thank somebody called Dr. Jalal Khan, and I think if you're here, you probably know who he is as well. Dr. Khan is a dentist. He's down in Sydney, and he's been my mentor for the last 3 years. And that man is actually incredible. If you haven't listened to his speeches, you know what I'm talking about. If light was a person, like that is Jalal. And so you're not here, Jalal. Thanks for your support. You're in Bali having the time of your life. But I expect some free mentorship when you do see this come out. So Max has asked me to talk about hormones today. I work a lot with women between the ages of 20 to 40 years old. I'm quite well known in the holistic fertility space. Reversing infertility seems to be the thing that I'm good at. So let's get into it. Okay, so hormones at quantum view. Can everyone hear me good? Like this? Cool. Does this even work? Okay, so before we start, this is not medical advice. Please seek the guidance of your general practitioner before making any changes to your healthcare routine. Not medical advice. He's a funny character, that one, isn't he? Do you reckon he'll win? Maybe. All right, so who am I? My name is Kiera Lee. I'm a quantum health clinician educator. I'm not a doctor, so don't listen to anything that I'm about to say. Only listen to Max. I have a background in nursing and psychology, so registered nursing. I left that over COVID to pursue what I'm doing now, and I've been having the time of my life ever since. I'm literally obsessed with light and health. Like, my friends are going out on the weekend, and I've got like my red light on, my laptop, a Jack Cruz blog, and I'm set for the night, some relaxing music. I'm like, yeah, this is great. This is how I spend my weekends. I'm always learning. Anyone who says that they know everything is lying to you, because the principles of quantum mechanics tells that everything is relative to your thoughts and the way that they're interacting with the light that you can see and that you can't see in your environment. Actually, that's not true, because our perception only influences the light that we can see, and that might be the reason why we don't see infrared and we don't see UV. That's another story for another talk. So I healed myself naturally. When I was in nursing school, I was studying at USC, so on the Sunshine Coast, and then I got a scholarship to attend a university which I shall not name here. You just stop naming it, actually, in the city, in Brisbane. So I went from living very rurally. I grew up on a farm. I was picking beans with my parents on the weekend, just doing all the Circadian things, but like that was just my normal life because I was being a normal person and acting like we're supposed to act. So when I moved to Brisbane, I got quite sick. And this isn't a talk that's extremely scientific. I do get quite scientific on my Instagram, on my blog post, on podcasts that I do. But I was talking to somebody, who was it? Oh yeah, how can I forget? Cindy. I had a fangirl moment on Wednesday. I had lunch with Cindy O'Meara. I know, I was really nervous. More nervous than I am now. And I said to Cindy, I don't know how deep to go in my talk. I don't know what to touch on because there's just so much. When you really start to understand light and health, you know, we can say go in the sun and the key takeaways are always the same. Get cold, eat seasonal, all the things, right? But the science, like, I love to nerd out on it, and I want to give that to everyone else. Because I think a big problem in our system is that we have offloaded responsibility as individuals to somebody else. And we don't understand what health is anymore. We're so busy every day making money, looking after our kids, going here, going there. We don't have time to learn this stuff. Or we think that we don't have time to, because we've been brought up in a society that doesn't prioritize that or allow us to prioritize that. And so we go to our doctor, our trusted medical professional, and he tells us what's best for our health. And we think this person's gone to university for X amount of years, they know what they're talking about. We implement these things and maybe we get better and maybe we don't. But we've got to a point where we're not getting better. And so everyday individuals, and give yourself a pat on the back because that's you guys doing a fantastic job educating yourself. They've actually said, okay, I'm done with this paradigm. I'm done with being told that saturated fat's bad and that eating insects and veganism is great for your health. My ancestors ate butter and they didn't have all these diseases that we have today. And so they started to think for themselves and they've gone, okay, well, I actually have to learn about health and onboard responsibility to myself again because I'm not getting the answers that I want. And so that's what I did. When I got really sick, when I moved to Brisbane, I was asking my professors, I'm quite academically gifted, not so life smart, but more academics. My mum would have something to say about that. But so I was friends with my professors. So basically the smartest of the smart at my university, I was asking them, you know, I have chronic fatigue, vertigo, what can I do to heal my health? And they said, go vegan. And I did that and I got worse. And I was like, well, if these are the best of the best, that's a bit sad because I'm not getting better. Anyways, let's talk more about that as this goes on. Oh, that's a nice photo of Cameron and I, by the way. We co-founded the Quantum Health Academy together. He's so brilliant. I wasn't here for his speech, but I heard he made a joke about Schrodinger's dog. I heard it was both a good joke and a bad joke at the same time. So today I'm going to teach you that you are not broken, but your environment is. I am sick to death of industries profiting off broken women. I'm so sick of it. It starts when we're young with marketing. Your hair's not the right colour. Your skin's not the right colour. Here's a product that can fix you. You're broken, you're broken, you're broken. And you're lucky that we have a product that can fix you. So from such a young age, we already have this fundamental thought process that we're thinking that we're not good enough. We have to have an external substance to fix us. And I believe that doesn't just stop at products. We look for external validation through so many modalities. And again, that's another talk for another time. But the notion that I want you to understand, especially if you are female in this day and age, because we are more sensitive to our environment. There's a reason that the people that I work with are predominantly female, because they're the people that are really suffering. And that actually is because we have higher leptin levels than men. We're designed to be more sensitive to our environment so that we can encode this information from our environment through our mitochondria to our children so that they know what type of world they're coming into. And that's a beautiful, beautiful weight to have on your shoulders. And then the man's job, Dr. Max was talking about yin and yang. I see the male and female dynamic the exact same way. So while we're more sensitive to our environment, the man is nurturing and protecting his home so that the female can be healthy, her mitochondria can stay healthy, it's not under stress, and then she can pass on the right information to her offspring. But yeah, so you are not broken, but your environment might be, and perhaps by the end of this, you'll understand why. Okay, so this is a photo of me at nursing school. That's from Snapchat. I don't use Snapchat anymore because I'm not as low dopamine. But it's okay, so this was taken... Yeah, I know. Yeah, well, let's not talk about it. So this photo was taken in the Sunshine Coast. So I'm getting ready to go to nursing school. 3 months later, I look pretty happy, do you think? Look pretty healthy, my skin's pretty good, my teeth are white, my eyes are glistening. Oh, it's beautiful. Anyways, 3 months later, I get diagnosed with PCOS, chronic fatigue, severe hormone imbalance, migraines, anemia. I was someone who never had a painful menstrual cycle in my entire life. I don't know if I want to say this publicly, but I thought that it was something that women made up to have a week off work. I actually didn't understand. I was like, what are they talking about? Oh, I found out what they were talking about. I went from not even understanding painful cycles to being in fetal position crying every single month for a whole week because I was in so much pain. I had chronic vertigo. Max, I might go over, I'm really sorry. I yap a lot. So I had chronic vertigo to the point where I would wake up in the morning, stand up, and I would pass out because my vertigo was so bad. And that was just a few weeks after changing my environment. So I went from 0 diagnoses to 5 and a whole bucket load of symptoms in just a couple of months. And what changed? My diet didn't change. My family dynamic didn't change. I didn't have any major traumatic events. It was my environment that changed. So 3 months after this photo was taken, I moved to Brisbane City to take my scholarship and my employment mentoring first-year students at a university. I went from living on ground floor in a home in rural Australia to living on the 19th story apartment building with a Wi-Fi router next to my head, drinking fluorinated water for the first time, processed foods, and I was surrounded by blue light. I was so blue light toxic that it's just so sad thinking about it. Because I would work at the university too. So I would wake up, I wouldn't see the sunrise, I would make my food, I would drink coffee, I would go to university, I would work, I would go to class, I would go to placement, I would go back to university and work until 7:30 at night, then go home. I was literally never outside and I was swimming in blue light. So basically, my environment changed. My environment previous to this was giving me very healthy, natural input signals. Our body is constantly sensing our environment so that it can make the right decisions internally for us. And this includes what hormones to make, when to make them, when to make us go to sleep, when to make us wake up. And I went from having these beautiful natural input signals, natural sunlight, natural water, natural air, natural magnetism, to now having all of these dirty input signals from Wi-Fi routers, from artificial blue light, never seeing the sun. My body went from being in an environment that was supportive of its function, which led to me being an extremely, extremely healthy young woman, to being in an environment that was basically designed to set me up to fail. And I'll show you a great photo, which I wasn't going to show, but I will, to get my point across of what that looks like. So I used to wear AirPods and train in a gym when I went to Brisbane because I didn't have any parks to train in. I used to train in a park, used to climb trees, and then I was wearing AirPods and training in a gym and using Snapchat a whole lot more. But doing that gave me this. So my first symptom was I had chronic acne. I had never had acne in my entire life. Can also notice that I'm quite pale in that photo, and we're going to talk about that soon. So I used to live in my state's largest city. Thought I was really cool. I had the sunrise coming up then that I didn't watch. Had all these beautiful artificial lights to look at every single night. I lived in like this nice apartment. I thought it was great. But living there gave me this. So then I was diagnosed with PCOS. So that's me in the Royal Brisbane Hospital. I don't know, maybe getting some IV fluids and things, because probably my environment was making me chronically dehydrated, which I now know, but I didn't know then. Okay, so as a registered nursing student, I thought I knew everything about health. No one could tell me anything about health because I was the first person in my family to go to university. I knew everything. When anyone was sick, they would ring me, and I had this ego where I thought I knew everything, right? Boy, did that change. Until having a mindset like that left me looking like this. So that's 3 months after this photo. Now, some people, it doesn't take them this long to get sick. Some people, it's a little bit longer. Some people, they get sick a little bit quicker. Why did I get so sick? I think it's because, thankfully, I hated it then. Now I'm so thankful to my mum. I grew up on a property. I always had no clothes on. Like, if you look at baby photos of me, you can't show them to your mum because I'm always naked. I'm like always barefoot, swimming in creeks. Our neighbours grew cattle, so we ate local meat. We grew our own produce. So my body was used to having really appropriate input signals to design its function. So my body was stuck together like glue through good signals. Now my family lineage had no time to adapt, and I don't actually believe that we ever do adapt to artificial input signals. And so I feel like that's why I felt the results of EMFs, of artificial blue light, just so heavily. And so I was never going to share that photo, but I feel like it's important. All right, so conflicts of interest. Nice photo of Cameron, Dr. Khan, and myself. We co-founded the Quantum Health Academy together because I got sick of being on client calls from 4 a.m. until 10 o'clock every single day, helping women achieve better health. And I said, I just can't do this because it's taking my health. But I'm so passionate about it. How can I continue my work but offload some responsibility to other people? And Dr. Khan said to me, Kiera, I think it's time that we train other practitioners. And so that's what we're doing. And there'll be hundreds of thousands of us, hopefully. We aim to reach 1 million people in the next 5 years and change a larger amount of lives than we can on our own. So I also run something called Solar Culture Retreats, and we also have a school group where I educate people because I believe that the future of healthcare really comes back to education. So putting the power and onboarding responsibility back into individuals' hands is really important. So Solar Culture runs its first retreat in El Salvador. We have leaders from across the globe, Alexis Cowan, Dr. Pran's going to be there as well, Jalal, and we'll all be educating for 5 days in that place. We chose El Salvador because it has high magnetism, good water, lots of sun, and it'll be winter, I think, in America, so everyone will want to escape and go back to the sun. And then I also own Kiera Wellness, which is a coaching program. So yeah, they're my conflicts of interest. So back to the original topic. You are not broken, but your environment is. So as I said before, I feel like from such a young age, especially me, I'm 26, I feel like I really was that first generation that got access to social media. So I went from being exposed to my family, the people I went to at school, to hundreds of thousands of people every day, every second. Social media is full of marketing. And what do people market you? Products. so that you buy them and then they can profit off you. And turns out sick, broken people are really easy to profit off. And so the marketing that I was exposed to was marketing that tried to tell me that I was sick and broken, and they had the solution, whether it be a hair dye, a product, a hormone supplement, and that I needed to buy it. But this makes me angry, because health doesn't come from a supplement. It doesn't come from an external substance that we take. Our body is designed to function optimally when it's in an environment that is supportive of that function. We aren't born out of our mother's womb with a little carry bag of like omega-6s, asthma inhaler, I don't know what else, gummy collagen drops. Like, that's not how it works. God said, I've prepared you perfectly for this environment that I've also created you for. And when we get a mismatch there, that's when things start to break down. This isn't really a scientific talk. I was talking to Cindy and she said, Kiera, it doesn't have to be scientific. You just need to tell people what they need to know. It's not about you. Think of the things that you wish you were told 3 years ago and tell them that. And so that's what I'm doing. So our society tells us, especially as women, you're not good enough, but here's a product that can fix you. So let's go through some of these. One, we have Bondi Sands up here in the left-hand corner. So that's a fake tan. Cindy, you would have a heart attack if you looked at the ingredients on that. We put this on our skin to make us tan, but what they really should tell us is that, yes, being tan is attractive because it's a sign of good health, but you can just go outside and make that tan yourself if you take your sunglasses off and your POMCs and your photoreceptors are working well. And it's safe and it's effective, and you're not lathering yourself in all of these chemicals that are going to give you a whole bunch of side effects that are going to lead to a whole bunch of supplements and a whole bunch of diagnoses. We have collagen peptides. Now, collagen's a funny one. I got in trouble on Twitter recently for a very controversial post I made with Carnivore Aurelius, if anyone knows who that is. So we think that collagen in a powder form is the same as collagen from an animal product, a natural animal product, like a bone broth or something that a lamb roast. It's not. So I'm not going to go into it today. I think there's a previous Regenerate video that talks about deuterium. Deuterium is something that we need in certain amounts of ratios. Nature doesn't make mistakes. So we eat something that's local and seasonal. The deuterium ratio in that product is perfectly quantized to suit our environment and also us and the animals that it resides in. Now, collagen supplements, they are so heavy in deuterium, and basically you just need to know that the ratio is completely off and it's very detrimental to our health. So the whole point of me putting this in here is just to say that supplements, they're not natural. They're concentrated. Sometimes they're from 10 different animals from across the globe and they're all mixed up together, and that information that our body senses is completely backwards. Down in the bottom left-hand corner, we have some hair dye. This same company will also tell you that going blonde is, it's attractive, it's good. And then it'll also sell you hair repair products in the next 6 months because your hair is going to be extremely damaged. But you're beautiful just the way you are. You don't need to dye your hair. You need it to grow long and luscious and healthy. And having good hair is a sign of good internals. It's a sign that you're living in coherence. So it's not something that we want to change. We want to sense that as a signal and say, okay, like my nails are brittle, my hair's falling out, what's wrong with my environment? What do I need to fix? We shouldn't dampen symptoms. We should look at fundamentally what's going on, what is the root cause. We have some really pretty girls here with some sort of greens powders. I don't understand athletic greens. I think Huberman was promoting them. Again, not the same as natural organic. These are also loaded with pesticides, GMO products. Again, they're greens from all across the globe that are mixed up together and put into a packet. They all carry different information. It's quite confusing for us. Here we have breast implants. I swear in 5 years, 10 years, we're going to look back and be like, what is these BBLs, these breast implants? It's literally just telling women you're not good enough. The way that God designed you isn't good enough, and here's a product that can fix you. Now these, it's actually getting into the media, are so detrimental to your health. The amount of toxins that are in those, the leakage that happens, and then the issues that women experience with breastfeeding later in life after having these surgeries is just so catastrophic. And unfortunately, it's not something that can be undone easily. The result of these surgeries and the negative implications they have on us are lifelong. So they are quite serious decisions. We have some weight loss products. They won't tell you that leptin resistance, I think Max talked about it before, is why everyone is struggling to lose weight and maintain homeostasis. And they won't tell you that artificial blue light at night raises your blood glucose levels, raises your insulin, so that leptin doesn't dock and you become leptin resistant. They won't tell you that, but they will sell you these products that will fix you, that are focused on diet, that will cause more symptoms and mental health issues when they don't work, because you feel like, again, that you're doing something wrong. So I call this probably like 9 years old to 20 years old marketing, right? Moving on to this next slide. So we're already primed. Us young women, we already think we're broken, we already think we're not good enough, and then we start having hormonal issues. Your hormones, okay, who's ever been told their hormones are imbalanced? Did anyone explain to you what a hormone is? Can anyone tell me what a hormone is? Cameron, not you. Okay, well, yeah, woohoo! Yeah, so hormones are, they're messengers, they're chemical messengers. They are quantized to our environment, and we'll talk more about that. But what they will do is they won't tell you what the root cause approach is, but they'll happily sell you a supplement because you're broken and you need to be fixed. And your body can't do what it needs to do, so you need them to fix you. Pregnenolone, a massive supplement I see clients on. They don't know that if you have healthy mitochondria and you watch morning sunrise, that your body will actually make pregnenolone for you. You actually don't need to sign up for a lifelong prescription. And they won't tell you that pregnenolone, artificial pregnenolone, actually influences the growth and development of your baby in utero in a negative manner. But they'll tell you to take it, and they'll tell you that it'll fix you. Estrogen for women. It's an artificial blue light story. We can talk about chemical signaling and the rate at which signals fire, and the way that impacts testosterone and estrogen and the leveling of that in our body. Hormonal birth control. I don't think I need to talk about that. So let's look at some statistics. So the hormone replacement therapy market. So in 2023, it's worth $22.5 billion. In 2033, it's going to be worth double that. So they're making money off broken people. These are industries, these are companies that are both marketing to people to tell them they're broken. They're not solving the root cause, and instead, they're providing a solution through a product, which will ultimately lead to more symptoms, which will lead to more products and more profit for them. Let's look at the key players in this. Bayer, I don't even know why they're in this market. Pfizer, Novo, no surprise. So the key takeaways, they're making a lot of money off you guys. I love memes as well, Jake Welke. So we have here in the middle supplement companies. Women's best interest, but they're too busy looking at profitable industry. So let's have a look at a snapshot in time, 2024 women's health. So the things that I see come through in my clinic, and these aren't things that were around 150 years ago. Our hospitals were filled with acute injury, whether that's someone came off their tractor or someone had some sort of cardiac event, which has increased exponentially in the last 10 years as it is. It was all acute, mainly. Now it's not. Now our hospitals are filled with chronic illness and the doctors can't fix them, but they pull out their prescription pads and they prescribe you something, a pharmaceutical or a supplement. Functional medicine will provide you with a supplement, and allopathic medicine will provide you with a prescription. But this doesn't address the root cause. They're not asking the question, why all of a sudden are all these women so sick? What is happening? Is it their environment? Is it the water they're drinking? Is it their stress levels? Because let's face it, cortisol, it tanks fertility, and we're going to talk more about that. If you look at the average woman's life, she's running a business, she's caring for children at home, she's looking after her husband, she's looking after the animals, she's taking care of her family. Like, that in itself is so much work. And that cortisol is not normal. We're actually meant to work in community. We're meant to have shared ventures and shared priorities amongst us. We're not meant to live this fast-paced lifestyle that we do today. Our cortisol isn't meant to be this high. Now, a lot of these women's health concerns, PCOS, endometriosis, well, it sounds like my diagnosis, really. Infertility, chronic fatigue, adrenal fatigue, these weren't around, and these can all be tied back to our circadian, root cause approach. And if we look at when artificial light, and I know I'm preaching to the choir here, was first introduced, I think it was 1949. Paris first lit up their town at night with streetlights. And this is really when we started to see all of these issues come in. Then we invented the Wi-Fi router, and now we all have phones that emit 5G, and now these are just every second person has them. And they have multiple, it's not just one. Let's look at men's health, because yes, men, you have hormones too. So low testosterone, high estrogen is massive. Diet plays a massive role in that as well. Supplements, stress levels, artificial light, sunlight, or absence of sunlight, and then also fatigue. So this is what I'm dealing with in my clinic. This is what I see a lot of. And I have very, very high success rates in reversing these when people come off their supplements, when they bring their stress levels down, when they pay attention to the water they're drinking, to the thoughts they feed themselves, to the ground they're standing on. It's really not that hard. I kind of feel bad coaching people because I'm like, I'm just telling you to live like a normal person. But apparently we forgot along the way, so people need some reminding. Okay, so that's the introduction. We'll get into a little bit more of the science. I think Cameron and Max touched on this quite a bit, but I really like the way that I explain it, not bias. But maybe this will stick in someone's head that didn't really understand it before. So we are tied to light. You think of the light outside, us, we're best friends. We should never be disconnected. If you think of a puzzle, you can think of the light as one piece of the puzzle and us as the other. Now, when we have natural lighting and then you have us, they fit together perfectly. Those two pieces fit together really well. When we have artificial lighting, not so much. So on the bottom left-hand corner, you can see here that light is changing. So I want to introduce to you this concept of time and how we actually tell time. So just because my consciousness, my conscious brain, because I'm a smart person, knows that this conference started at 9 a.m., my body doesn't know that. My body doesn't register that time. My body tells time through the light in its environment, specifically the blue light in its environment. So our body uses that blue light frequency. It's not infrared, it's not all these other ones, violet. It's the blue light frequency we actually use to keep time. And this is changing all through the day. So your phone screens, how blue they are, that's actually set to mimic midday sun. Now, something that's really interesting is blue light also influences a hormone called cortisol. Now, cortisol's not bad. Everyone thinks it's bad. We need cortisol to be low, low, low. But actually, if cortisol's really, really low, we start to get some other issues that aren't great. Cortisol is fine. Every single hormone inside of you is fine when it's balanced with its partner, when it's working in line with your environment. So, when you get up in the morning and you go outside, your brain, your suprachiasmatic nucleus, your hypothalamus, looks and it interacts, and the photoreceptors on your skin and in your eyes interacts with natural light. And it says, okay, I know that it's 7 a.m. You might know that it's 7 a.m. Because you've looked at your phone. But if you're looking at a bright phone screen in the morning, your body doesn't sense 7 a.m. Your body senses midday. And what's that going to do? It's going to drive your cortisol up. So you're already starting your day stressed, in a stressed out state. However, when you go outside and you see natural lighting, your body says, okay, good morning, Kiera. What a beautiful day. It's time to rev up your thyroid. Oh, it's a bit cold today, so I think your metabolic rate should be XYZ. I think that your body temperature should be like this. This is the time of the cycle that it's in. This is where you are on the planet today. And it can sense that information. So straight away, waking up, giving yourself that right input signal, putting in that information is really, really important. And that changes all through the day. And we'll talk about some key takeaways later on. But I also want to note that a lot of people in the circadian space, they're scared of darkness now. They're scared of winter. So I had some friends recently go and visit the equator to get out of the Australian winter. But that's not actually appropriate. We need both sides of the coin. Just like, unfortunately, men and women do need each other, and we do all need to get along. To light a candle is to cast a shadow, and you can't have one without the other. So if you want to have light, you also need to have darkness. This concept of yin and yang is really, really important. I won't talk about it too much because Max beat me to it, but it can get quite philosophical. It's quite nice. So we went through this. How does our body tell time? So this is a slide from a Dr. Jack Cruz webinar I watched. So blue light varies daily and seasonally. The light that we're around, the artificial light, it doesn't change. It's the same, day in, day out, year in, year out. And that's a big fault, and it impacts our hormone production. Here's another slide. So we actually only see 1% of the electromagnetic spectrum that we're around, and I think Tristan will talk about this more in his presentation. We don't see near infrared, we don't see UV. That's all we need on that slide. Okay, so who knows about circadian rhythms? Do I need to talk about them, or are you pretty well aware what they are? Okay, a few of you, maybe I'll go on. So, when it comes to circadian rhythms, it's a clock that's basically programmed in our body. So if you think back to times when people lived on farms and we didn't have electricity, we used the light outside to tell time. Right, there was actually a really nice philosopher, and he actually built a flower garden. So I think it was in 1920. He wanted to make a clock out of flowers. So he realized when he walked outside, depending on what season it was and what time of day it was, some flowers would be open and some flowers would be closed. And so he planted these in the right order in a round circle. And so when he would go outside, he would know what time of day it was depending on what the flowers were doing. And that's actually how our body responds hormonally to the changes in our light environment. So here's an example of circadian rhythms. I don't actually agree with everything on here, but it was a nice picture that I found. The key takeaway is that different things happen at different times. It also correlates quite heavily to the traditional Chinese medicine. So they say like your liver goes through recycling at 3 a.m. and then your qi comes back at 4 a.m. and all these types of things. So basically in the morning we get a nice surge of cortisol, it wakes us up. At nighttime, the light goes away, we get this release of melatonin that we actually made in that morning if we had access to sunlight. And that sets our circadian rhythm. It sets and kind of governs all the jobs that our body does throughout the day. Because our body knows what jobs to do depending on the light that's in our environment. So the uncoupling of the system, we kind of went through this. So in 1887, Edison invented the light bulb. In 1891, Tesla invented the power grid. So these are really the first times we changed our electromagnetic spectrum from the Schumann's resonance through natural electromagnetic frequencies to these alien electromagnetic frequencies. So if you believe in God, you'll believe that this environment, our natural environment that's outside right now, was perfectly designed to suit our function. Now, if you believe in evolution, then you believe that as we adapted to our environment, they're in no way separate from each other. As our grass changed, as our trees grew, as we moved from Africa to Norway, our body changed with our environment. And so we were designed to function with the Schumann's resonance, with these natural electromagnetic frequencies. Now, when Edison and Tesla, they did what they did, they changed these input signals. And our electromagnetic environment really is the glue that holds our physiology together. So when we change that, things change fundamentally inside of us. The shape of our mitochondria changes. The shape of our respiratory proteins changes. The way our metabolism functions is determinant on the electromagnetic spectrum that we're around. Functional medicine doctors don't know that. So let's quickly recap centralized endocrinology. So this is the traditional symptom. If you would go to the doctors and you're like, okay, I'm not feeling too well, I'm really tired all the time, this is what happens. So you have your symptom, patient develops the symptoms in line with hormone disorders. You go to your doctor, maybe your doctor will put you on oral contraceptive just to shut down your hormones completely, or if you're lucky, he might do some testing. So the patient seeks some medical advice of their GP, who refers them to an endocrinologist. They go to the endocrinologist, they do some more testing, they don't address the root cause, and they simply prescribe a hormone replacement therapy. Not always, but commonly, and through the people that I see in my clinic, they come to me on these types of medications. So the medication has side effects, and the root cause of the original issue still remains. So they've never actually said, okay, so why is Kiera feeling this way? Is it the water she's drinking? Does she have no DC electric current in her body? Is she around blood? Like, what is wrong with her? Why can't her body do its job? It simply said, your body's broken, here's a product that can fix you. But that issue's still there. That initial attack on your body is still there, but now you can't feel it. So it's like taking a medication. It's like an alcoholic who has trauma and they just continually drink, but it's still there. The trauma's still there. And it doesn't go away. In 12 months' time, you just get a new symptom and you get a new medication. And then you get another symptom 6 months later and a new medication. And you see where it's going. It's an endless cycle. And that's the loop that the centralized practitioners and the centralized patients are stuck in until they learn better. And it's not going to come from endocrinology. It's going to come from a ground-up movement. So hormones are quantized. So this is a peek into my work and how I work. So we look at how centralized endocrinology works. This is the things that I focus on. So when someone comes to me and we do some blood work, or by the time they get to me, they usually have $10,000 worth of blood work that I can go through and utilize, which is just ridiculous. So I look at the electromagnetic environment. So the light you can see and the light you cannot see, and the light we make internally, all impact our quantum machinery and our ability to interact and sense our environment. Now, you and I, we could both go outside right now and we could sense very different environments depending on the damage that's been done to our photoreceptors. That's why you see things like red lights coming out, or chroma lights, the opsin regenerator light, because sometimes your quantum machinery is that broken through a poor environment that even if you do go in a good environment, you actually can't sense that. Your typewriter's broken, your printer's broken, it doesn't work like that. So I look at, is their quantum machinery intact? Or do we need to do a little bit of work to fix that? Can this person sense their environment? I look at information. So our body requires the correct information to make the correct decisions about how to run its internal timing mechanisms. So how does our body sense our environment? It senses the electromagnetic spectrum. So I look at, does this person have good input signals? And that is the circadian health. That is the grounding. It's all of these things that come into that. I want to make sure the signals that they're feeling through their eyes and their receptors on their skin, that their mitochondria are sensing, are all natural. I don't want any artificial signals in there. Trauma. Now, trauma is a massive one. It's one that's really missed in the circadian space. Trauma impacts the way in which our body forges coherence with our environment. So we actually store memory, not in our brain, but in, it's quite controversial, in the hydrogen bonds of our water network. Now that can impact your fascia. It can cause emotional blockages, and it completely can change the way that you sense reality. It can even actually change the density of the photoreceptors in your eye. So it needs to be addressed. And until you release that trauma, it's still going to be there. It's still going to be there as the root cause. And I would argue that almost every single client that I work with has been through some sort of trauma that they haven't dealt with that has then manifested into a physical symptom. And you need to work with them simultaneously. I think that the higher your redox is, the better you are at dealing with trauma and dealing with stresses. Let's think if we went through a very traumatic event, like let's say my mother passed away, God forbid, and I was not feeling well before this. So I had headaches, I had vertigo, I wasn't feeling very well. Do you think my body would say, Kiera can't even function every day as it is? Do you think it's a good time for her to deal with this trauma, this death that's happened in her family? Or am I just going to repress it somewhere until she feels better and she's in a safer environment to deal with that trauma? That's exactly what happens. So in the trauma space, we talk a lot about dealing with trauma, deal with your trauma, fix your trauma. But actually, if you're forcing that trauma out there when your body's not ready, that can be extremely detrimental to them. When you get your redox up, when you give your your body a safe environment that's supportive of its function, your body will decide when it's ready to deal with that trauma, and it will happen naturally. Nutrition, Cindy covered this beautifully. It's not just about the food that we eat in terms of micronutrients, it's also about when we eat and the context of the environment. Just like Cindy said, if you live in Australia, there's no reason you can't eat carbohydrates. But if you're living in Wyoming in the winter, you probably don't want to be eating bananas from Queensland because food is stored light. The way that the electrons spin, the information, the biophotons that are encapsulated in those electrons give information to your body. And so if I'm eating bananas from Queensland when I'm in Wyoming in winter, that's a complete mismatch. Also, cytochrome 1 in our mitochondria, where carbs go into, is a UV light receptor. So UV light turns that on and allows you to process carbohydrates properly and efficiently. If you're in winter and you're eating carbs, your mitochondria turn that off. It's like, oh, it's cold, there's no UV, no carbs will be growing, I don't need them. That's the way that it works. So also look at the internal environment. So this is massive. This is the work of Dr. Jalal Khan. He talks a lot about posture, fascia, physical trauma, pre-existing nutritional deficiencies. I know Cindy's work deals with that. And also your hormone status and the homeostasis of your body. So posture is massive. What's happening with your fascia, because as we said, fascia is a superconductive highway that literally pushes information at the speed of light throughout your body. Biochemistry isn't the way your body talks to each other. It's all through proton flow. Okay, so from this, I developed a new framework. How long do I have left? Cool. Okay, so this is a new framework, very different to what we saw back here. I should probably, what's it called when you like, I need to patent it, so don't look at that. So trauma, first thing I address. I don't address it straight away, but I might put that in my back pocket and be like, okay, once this person's healthy enough, I do know that I need to go there. Whether it's with me, because I kind of work as a primary care physician, I kind of oversee someone's care. I might refer them to someone else if I think they need trauma work or some sort of additional therapy. I'm a big fan of functional patterns. I'm a big fan of myofascial release, because that's really working with that water. That's that stored memory, perhaps. So then we go into the information, we address the electromagnetic environment, we look at nutrition, we look at the internal environment. Now that's the framework that I've built. People get better on that framework without supplements, without pharmaceuticals, without all the side effects, and it works. All right, so practical applications. I was looking through my notes, and I thought, what's the most common thing that I'm seeing at the moment in my practice? And it's something called PSS. So it's pregnenolone still syndrome. I'm just going to skip this because I don't think I'm really going to have time to go through it. So pregnenolone is our master sex hormone that is divided up to become all of our other sex and steroid hormones. So that's synonymous. So for pregnenolone to be made, you need cholesterol, and you need cholesterol from animal products. So if you're not eating animal products, chances are you're going to have issues with pregnenolone. Now, depending on what's happening in your environment that your body senses, pregnenolone gets divvied up to become everything else that you need in your body, all the sex and steroid hormones. That's how things are meant to function. But today, we're seeing a lot of this, which is pregnenolone still syndrome. I love memes. So we see here cortisol on the right. We have pregnenolone here, so pregnenolone's being made. Now, it can become every other sex and steroid hormone, or it can become more cortisol, depending on your stress levels and what your body's experiencing at that time. If your cortisol is really, really high, because remember we said that our body's always acting in our best interests, your body says, oh, now's not actually a really good time for Kiera to make a baby. She's actually really stressed. So I'm actually going to turn this pregnenolone into more cortisol because I want to keep her safe. I want her to be ready to deal with whatever she has to deal with in the day to keep her safe. And it won't make our fertility hormones because it said, let's just downregulate fertility right now. Let's just put that on hold because if we have a baby right now, chances of survival in this environment is not looking too good. So that's called pregnenolone still syndrome. So let's look at things that raise cortisol. So artificial blue light will raise your cortisol. So looking at your phone screen first in the morning before going outside, it'll cause this pregnenolone still syndrome. It's actually really common, and I see it a lot. So yes, our body is always acting in our best interest. Now, it's not just artificial blue light. I know in the quantum space we talk about light, and the functional people like you need to talk about nutrition because it's important. And I've tried to incorporate more of that into here. But what else causes high cortisol? Because yes, it's not just artificial light. We talked about one of them. That's busy schedules, it's constant stress, it's high workloads that we're not designed to have. It's emotional stress. So are you fighting with your partner? Are your relationship's not very good? Your body will actually raise your cortisol as a defense mechanism. Trauma, stuck in flight or fight, that'll raise your cortisol. Physical stress. So there's actually a negative feedback loop through the muscles in the tops of our thighs. Now, something that I see in office workers a lot, if any of you work in an office, when they're on their computer all day and they're typing away, they might get an email from a boss and getting up them for something, or maybe their girlfriend texts them a message and she's angry, he doesn't want to go home now, and all these things. What happens is your body goes into flight or fight and you tense those muscles and you get ready to run. But only you're not actually in physical threat, it's just an email. But your body doesn't know that. So over time, those muscles, they become engaged, and that sends a negative feedback loop for your body to stay in fight or fight. So until you actually deal with that through myofascial release, that negative feedback system remains the same. It's not spoken about much, but it's actually something that can move the needle quite a bit. And that's just one example of physical stress. Fascia, Your environment, so artificial light light that we can't see, so non-native EMFs, will do the same thing as artificial blue light in terms of raising our cortisol. So all of these things will raise our cortisol, and our body goes, well, not a good time to have a baby. And now we live in a world where everyone's infertility rates are, like, infertility is running rampant. I see it all the time. And it can take some time to repair. The good thing is it's quiet. It doesn't take long. I'm going to share a case study with you soon. All right, so let's look at a case study. I'm actually really proud of this one. So I'm not going to give a name, but she's happy for me to share her photos. So this was my client goal, was fertility. She wanted to have a baby. She's 37 years old. She's been trying since she was 21 years old. Diagnosed with unexplained, and this isn't the only one, there's so many of these, unexplained infertility and unable to conceive naturally. She had done everything, acupuncture, trauma work, every modality under the sun, no pun intended. Well, she didn't do them under the sun, let's just say that. To no avail. She was so upset, and I met with her, and I started working with her, and just a few months later, she is having her little one, so I think she's like 25 weeks there. She actually just gave birth 3 weeks ago to a beautiful, happy, healthy little boy, which is very exciting. Now, her issue, I sat her down and I used that framework, and I looked at her environment. Her issue was literally that she was just looking at her phone, and she was doing office work instead of going outside in the morning. And she did that for a month, and she fell pregnant. This is how these simple changes can lead to such dramatic effects. And they're not expensive. Your body's not broken. It's just trying to function in an environment that is not supportive, and it's perhaps made to be not supportive of your optimal function. So this is a nice feedback that I got from this lady. She said, I don't mind that it took me this long to fall pregnant because my pregnancy has set an example for the rest of my family and friends. I have had no morning sickness, no swelling, no edema, no weird food cravings, and I've had abundant energy. This is what pregnancy is, well, meant to be like when you're healthy. And that really touched my heart because that's how pregnancy is meant to be. We think that our body is always working against us. Our menstrual cycles are meant to be painful. We're meant to have chronic fatigue. Fertility is not something that comes easily to us. That's what God designed us to do. That's our primary function. Morning sickness, it's not normal. That's tied to circadian disruption. That's tied to your mitochondria and your baby's mitochondria doing different things. When you align the coherence, everything falls together nicely. So if women knew, okay, Kiera, if it really is this simple, why doesn't everyone know about it? Well, if women knew that their physiology was determined by light, what would the world look like? I cried the other day when I went and visited a family member in hospital. It was 11 o'clock at night. Don't ask why. I had a good reason to be awake, okay? And I saw a pregnant nurse in her 3rd trimester working at 11 o'clock at night, surrounded by blue light. Do you think that women are going to want to go to work like that? Do you think that people are going to want to work in offices under blue light, doing jobs they already hate? Do you think that people are going to want to work shift work? Our whole society needs to change to live in line with circadian principles. And unfortunately, everyone, all these industries, have big money built on top of sick people, built on top of sick women. Like, we looked at how much HRT is worth. It's billions and billions of dollars. They're going to fight to keep that because that's their wealth. So is it women or is it their environment? Thanks.
Thank you, Kiera Lee. One more time. Incredible. All right, guys. If you've got any questions for Kiera, we're about to have lunch. Let her eat, but then line up. So, got about an hour and a half? We'll see you back here. Get amongst it. Thanks, guys. Yes, come on in. Come on in, guys. Find your seat. No, that's fine. Do you want me to take it? You guys are beautiful. You guys are a radiant family. New friendships are being made. This is what Regenerate's about. That touched me. That really touched me. Feel the warm fuzzies in the heart. Yeah, come on in. Don't be shy. Get him in, Jake. Round him up. Do that whistle. He's good at it. Oh, speaking of, I bought my first Walkie steak last night, right? Who's staying at the Atura Hotel, just quickly? Right, okay, yeah, a lot of yous. There's no cooking facilities, right? I buy the steak. Nowhere to cook. So you know what I did? I ran some hot water over just in the packet, bit of hot water. I opened it up with my teeth, and I'm standing in the bathroom, and I eat the whole thing raw. And I'm like there watching myself in the mirror, eating this steak raw. I got pictures for you. It's pretty creepy, but it was delicious, man. But I got the round steak, and Jake's like, "Oh, that's a tough one. You usually tenderize that." I'm like, "Oh, that's why it was so like." I was having to chainsaw it with my teeth. Honestly, I hear that's when it's its most nutritionally dense product. So the gut felt a bit weird, but it was absolutely tasty. I should have filmed it, bro. I'm sorry about that. Send me, yes. Well, you got a customer now, man. You sold me. While we're still coming. Oh yeah. I'll tell you another gross thing that I ate. So I had my Filipino neighbor come over to me, and they were like, "Hey, we heard you're a carnivore. We got a gift for you." And I'm like, "Oh, bring it on, okay." And she gave me an egg, and I'm like, "Oh, okay, cool. What's this?" And she's like, "Duck egg." And I'm like, "Oh, what's this?" And she's like, "Balut." And I'm like, what's balut? And she's like, "You'll find out." And she just told me what to do with it. And you have it, and you crack the top, and you got to get it off, and you got to like drink the juices that are apparently in there. I found out it was a duck embryo, and so I filmed myself. It's on my Instagram. Check it out. It's me eating balloons. It's like real-time reaction to this, so I am like freaking out because I see. Look, I'm sorry, but I see all the veins and like it's little, like it's all curled up. And I just down it. I just down it in one go, and it was like there was crunchy parts. It was full on. But honestly, the consistency was the only weird part. It tasted like just a duck egg. What do you guys? She gave me two, and I got the other one. I'm like, fuck that. Threw it away. I just threw it down the paddock. Oh, anyway, go look at my Instagram if you want to see that, Scotty Brizzle. Anyway, all right. Are we ready for your next presenter? Lucky that you've had lunch already. Lucky you had lunch already. I just seen this went blue. Is this all good? This is all good here. It's blue behind me. Oh, wait. No. You're welcome. That was me. All right. We're going to be late this Harvey, guys. I hope you brought your swag. We're sticking around. All right. Oh, and by the way, shout out to Discovered Whole Foods. How good was that, man? Yes. Big ups. It's delicious. Holding it down. All right. Our next speaker is an electrical engineer, health coach, and the host of the Decentralized Radio podcast, the author of the book Bitcoin and Beef, educator on the harms of non-native EMFs, and had a big part to do with the new and incredible daylight computer, which is mind-blowing. Presenting his talk today called Health Effects of Man-Made Electromagnetic Fields. Please put your hands together. It is Tristan Scott.
All right. Hello, everyone. I feel like I'm giving a sermon with this microphone. So it's after lunch, so I figured what's the most boring title I could come up with? Electromagnetism and human health. I could have called it why 5G is, activating vaccinations and frying everyone's brains, but we'll save that for next time. But seriously, it's a pleasure. Max, Simon, thanks so much for having me. I mean, anyone who gives me the floor to talk about EMFs for an hour, I'm going to fly across the world to come here. So being the only non-Aussie feels special. I'd rather be here. This is Wyoming, a picture of my buddy who I go hunting with. You've all heard of Wyoming a few times now, I think, throughout the day. So it's a place maybe most Aussies not familiar with, but it's the least populated state in the United States. It's a ton of nature, very low EMF. Big fan. Let's see if I can figure this out. There we go. All right, so who am I? Scotty gave me an amazing introduction there. So by degree, an electrical engineer, but kind of went right into the business side of engineering and the electronics semiconductor industry. So, and it's really funny because I realized in school I wasn't that passionate about electrical engineering or electromagnetism, which is what I'm here to talk about. It was only recently when I really dove into my own healing journey after suffering one too many concussions about 6 years ago, mostly from soccer that I played in university, and started to realize that electromagnetism, electricity is actually really important when it comes to our health, when it comes to our biology. And I was realizing this simultaneously while I was reconnecting to nature. And anecdotally, I felt the more time I spent outdoors, the more time and, just connection I had to nature, the better I felt. I completely healed myself after having post-concussive syndrome for 15 months, daily headaches, sensitivity to noise, light, sound, all the classic concussion symptoms. And neurologists told me, just take it easy, man. You'll get back to your normal routine. And that didn't do anything for me. It wasn't until I overhauled my lifestyle habit and kind of doing a lot of the things here that everyone's talked about the past 2 days. And really, the past couple years, I realized I had this background, this insight as an electrical engineer to kind of bridge the gap in terms of knowledge that people have, because this is a complex topic, right? Even light, anything EMF related, it's complicated. We don't learn basic physics. We don't apply this to health topics. Most engineers don't know anything about biology, and most people who know about biology and doctors and practitioners know absolutely nothing about electromagnetism and electrical engineering principles. So I don't claim to be an expert in either field. I know 99% more about biology than know more about biology than 99% of electrical engineers, and I know more about electrical engineering and electromagnetism than 99% of doctors. So that's where we're at. It's kind of a fun path to pioneer, and everyone who's talked here today and yesterday, especially today on the health side, we are really at the frontier of this. And I can tell you the past 12 months, I've talked to a lot of people, some of them very big names, in the health space, millions of followers. And they ask me questions about EMFs and, seasonal eating and things that are more esoteric but have a lot of science behind them. So it's just been a pleasure. The fact that I get to do this now for my work at Daylight Computer, which I'm going to talk more about, is just a dream come true. And yeah, we're just paving the path forward for what it really means to understand how our biology functions and how we can improve our environment. So really exciting. And then I wrote a book 3 years ago, it seems like a lifetime ago, called Bitcoin and Beef. So really big on decentralization. We'll tie that into the picture here. Big on Bitcoin and individual sovereignty. And that kind of was my foray into putting myself out there on social media and connecting with like-minded individuals. And this is a picture of me hiking with my nephew back when he was a lot lighter, carrying up a mountain. It's a lot of fun. So that's what we like to do in Wyoming. So here it is. Here's my statement that I've said many times. Most of the time, people don't listen to me, or they listen and they're like, yeah, okay, whatever, my roommates and people, parents. I really think EMFs are the most pervasive environmental toxin in our society today. and I'll talk about exactly what that covers. It basically means that modern technology is the biggest toxin in our lives. And it's an unfortunate circumstance because that's what we're glued to, that's what we use for our work, and it's ubiquitous, it's pervasive, it's unavoidable, but it's toxic. So I'm going to talk about first why that's the case by setting the scene, having you understand the electromagnetic aspects of our world, of our biology, and then getting into the difference between native and non-native EMFs. But it includes everything on the electromagnetic spectra, so radio frequencies, 4G signal, 5G, the Wi-Fi in your house, power frequencies from the electrical power grid, which is 50 hertz down here, it's 60 hertz in the US, and then also artificial light that we can see. I don't need to touch a ton on it because Max, Cameron, and Kiera as well touched on the light aspect, but light, visible light, is also part of the electromagnetic spectrum. So artificial blue light from screens, from lighting, is also a non-native EMF. And if you take all of this, I really think this is affecting our health at the greatest level because it's so ubiquitous. We eat 3 times a day, maybe some of you 1 or 2. We drink water maybe 5, 6, 7 times a day, 10 if you're really dehydrated because you're in a Wi-Fi room on your phone all the time. But we consume electromagnetic inputs 24/7, 365 days a year. Every second of the day, you're taking input signals from your environment of the electromagnetic type. And that's why I think it's so important for us to understand that. So in order to understand it, we need to go through some basic overview of what even is electromagnetism. And it can get complex. There will be a quiz afterwards, so write everything down that I say. But we can kind of get started and then make some relationships to what you actually understand. But at the high level, what they teach you in electrical engineering and physics is that electromagnetism was a unified theory that James Clerk Maxwell kind of came up with in the late 1800s. It's this revolutionary time for physics, Newtonian physics, and then kind of the early days of quantum physics. He basically came up with these set of equations that helped everyone understand, the connection between magnetism, light, and electric fields and the electrical nature of the planet, of the world, the universe that we live in. And this is what I was taught in electrical engineering. So don't think that a lot of this stuff I'm talking about, I already knew when I graduated. And also don't forget that I had basically brain damage my last year of college, so I forgot everything. But this is what electromagnetism is to most engineers, physicists, people. But in reality, it's magic. But in reality, it's light. So it's light that we can see, as everyone, Cameron, Max, Kiera have talked about, but it's also light that we can't see. And what's important to grasp here, again, is this is just around us all of the time, and we're always taking it as an input signal. But really, electromagnetism is light. It's photons that are oscillating at a certain frequency, and they have a wavelength associated with them, and they have energy associated with them. And the important thing to consider here is that what an electromagnetic field is, what an electromagnetic wave is. These are all like words that people throw around, and I just want everyone to understand the basics, that this is all light, and light is a wave, but it's also a particle. So this is this dual wave particle theory that's been proven. It's a quantum kind of aspect of light. It's very important, but to keep it simple, this is an electromagnetic wave, and it has a magnetic field component to it and an electric field component. So sometimes you'll hear people talking about magnetism, sometimes you hear people talking about electric fields. I'm going to talk about both of those things, but they're directly related, and depending on the frequency, sometimes they're separated in terms of measurement and discussion, if you're measuring EMFs with a meter, and then sometimes they're combined into one wave. But they're always connected. They're actually oscillating in phase 90 degrees apart from each other, and that's really important to grasp. But more importantly is what is generating electromagnetic fields. The main source, of course, is coming from the sun, but from a non-native aspect, what's important to get is that electric fields are generated by charged objects or voltage. So this might be a term that people are familiar with, the voltage in your plug in your house. So when you're turning a lamp on, you need voltage to power that lamp. So when you plug it in, there is then a voltage potential being propagated from the power that's in your house, that's coming from the transmission lines, to the lamp. And when it is powered on, but it's not switched on, so you didn't flick the light on, it just has an electric field component to it. However, magnetic fields are generated by moving charges or current. So when you actually turn that lamp on, the light is on, then you have both an electric field and a magnetic field. So that's an important distinction, and you can get into the deeper physics that like changing magnetic fields induce an electric field and vice versa through Faraday's laws, but that's not really that important. However, when we talk about mitigation tactics, this is all helpful to know, because even if something's plugged in, but it's turned off, especially if it's ungrounded, two-prong plug, you're getting electric field propagating outwards in your house. So don't leave things plugged in for no reason. And then what's also important, we saw a lot of light spectras up here earlier that had nanometers, which is measuring wavelength of the light. Wavelength is measuring the tip-to-tip length of one wave cycle. And then the frequency is inversely proportional to that. That's measured in hertz, which is typically what you'll hear when you're talking about Wi-Fi or cell signal or power. The energy of the wave is proportional directly to the frequency. So as we go up in frequency, we go higher in energy, and we go lower in wavelength. We get smaller wavelengths. So this is a really important picture. This is the electromagnetic spectra. This is everything, right? So everyone earlier mostly talked about visible light or slightly above that with ultraviolet radiation and infrared radiation. I'm here to talk about everything else. And it could be as low as 0.01% that the visible spectrum makes up of this. So it's like a tiny, tiny amount. And that's what everyone's focused on, because that's what we can see. So the reason why this is such an inconvenient situation and people can't conceive it is because they can't see it, right? It's hard for us to conceptualize things being bad for us that we can't see. But if you could see all of the electromagnetic waves bouncing around this room, and I'll turn my EMF meter on at some point, and you'll be very annoyed when I turn the sound on because it'll just go nuts. But this is really what we're dealing with on a daily basis. So in the low frequency realm, we have our power at 50, 60 hertz, and then throughout the years, radio frequencies have kind of taken up a good portion of the rest of the spectra. So radios, TV broadcasts, and then now at phones, we're operating in the hundreds of megahertz to low gigahertz range. And the difference between your power outlet, 50 hertz, and Wi-Fi is drastic. It's 50 wave cycles per second, and then Wi-Fi is 2.4 billion. And it's also that difference in the energy of that wave. So if someone's selling you a sticker saying that this will solve all your EMF problems, ask them how that's possible, that it's addressing such a vast difference in electromagnetic waves. And they won't have an answer for you because they don't understand basic physics. And the other thing that's really important to know, especially for combating naysayers, people who don't really understand biology, is the component of non-ionizing radiation and ionizing radiation. So most people are taught in school, ionizing radiation is bad, it's harmful. That's like, the end of ultraviolet, X-rays, gamma rays. That's why we have to worry about, going to the dentist, getting too many, having too many transcontinental flights, because it's ionizing radiation. The waves have so much energy that they'll actually break the bonds in the molecules in your body. It'll knock an electron completely out of its orbit, whereas the rest of the spectra just doesn't have that much energy. So how could it have a biological effect if it doesn't have enough energy to be ionizing? Well, we're going to get into why that is exactly. But shorter wavelengths equal higher frequency equals higher energy. Longer wavelengths equals lower frequency and lower energy. So here's two examples. Blue light is 450 nanometers, 670 trillion hertz, so 670 terahertz, and then it has an energy of 3.1 electron volts, which probably means nothing to you. But Bluetooth, which is completely different, is 2.4 gigahertz, 12.5 centimeter wavelength, so vast difference, and then the energy is 9.9 times 10 to the negative 6 electron volts. So vast difference in magnitude in the energy, both affects our biology. So that's kind of what we'll get into. And here's another thing. I just want to harp on this, right? Like, everything is electromagnetic, pretty much. Not everything, but it's really a major component because the source of life on this planet is coming from the sun. We have a magnetic field, a natural magnetic field that we'll get into on the Earth, and it's really the core principle of biology is electromagnetism. Yet they don't really teach any of this in academia. They probably gloss over it. I mean, you learn about the basics in physics and chemistry, but it's not educated about how vastly important this is to our biology. And it's funny because, we're out here with our tinfoil hats, literally protecting against EMFs, and we're the crazy ones. And this is really a subject where woo-woo and esoteric thinking meets science, and you have to bridge the gap. So it's a struggle. But now I want to get into the difference between native EMFs and non-native EMFs. So here's a good depiction, right? Like, we talk a lot about meat. Yesterday, a lot about farming. So I see native EMFs as a Jake Wolke ribeye. It's legit. It's proof of work. It's good stuff, good marbling. And then non-native EMFs is like, the Beyond Meat of food. It's fake. It's soy. And if you consume a lot of it, you're going to look like, people who consume Beyond sausages, if people actually buy that stuff. And if you eat Jake Wolke steaks more than you eat Beyond sausages, you're probably going to look pretty damn good. So what are some native electromagnetic fields on this planet? So the one that might be the most important, the one that actually is the reason why we're even able to exist as a species, and there's a big difference between us and Mars, which are both in this Goldilocks zone in our solar system, is our natural magnetic field. So the magnetic field is generated because the Earth has this molten iron core. And iron is a charged particle. It has movement because it's lava. It's moving around. And remember what I said earlier is that we have charged particles moving, then we have a magnetic field. So that's what's generating this Earth's magnetic field. And then that magnetic field is interacting with the sun, the solar storms, the solar flares, and everything that is just assaulting our planet constantly. And it's what's protecting us. It's what's filtering out the really ionizing high-energy electromagnetic waves from getting to the surface of the Earth, and it's protecting us, as you can see in these graphics. And it's really cool because without it, we wouldn't exist. And that's not the end of the magnetic field of the Earth being very important, but the strength or the oscillation, it varies from being static, which means it has no frequency associated to it, to peaking around 10 cycles a second or 10 hertz to dropping off around 30 hertz. So low frequency. So in that realm, a little bit lower to where our power is. And that's going to be important later on. And then we have other electromagnetic activity going on. We have what's called the Schumann's resonance, which I think probably some of you have heard of. So the Schumann's resonance is a phenomena where we have the natural magnetic field, and then we have a lot of lightning strikes as well going on. And the map on the right here is a map of lightning strikes and thunderstorm activity in the world. And those lightning strikes are generating a substantial amount of electrical potential, and it's interacting with the already ongoing charged particles in our atmosphere, and is creating a resonance frequency that's known as the Schumann's resonance. And this has a first harmonic at 7.83 hertz, second at 14, third at 20, which goes down in strength as you get to higher harmonics. What's cool as well to note is that the incidence of thunderstorms is very concentrated around equatorial regions. So I think there's 70% of all thunderstorms within plus or minus 30 degrees north, 30 degrees south latitude. So you get a lot stronger electrical field activity at equatorial regions. And then going back to the magnetic field, we have this molten iron core generating a dipole. So the Earth is literally a giant bar magnet underneath, and it's very close to our geographical poles, the north and the south, but you'll also get stronger magnetic field activity towards the poles. So it's tying into this theme that your local environment matters tremendously. So when I take a flight from the US to Australia, as I did, I'm in a completely new environment. I'm in a completely new electromagnetic environment, and my body is picking up input signals constantly to adapt and, fine-tune my biological processes to thrive there. So electrical field activity is higher towards the, equatorial regions, as mentioned, and that's going to be important for things such as grounding, which I'll talk about in a bit. But this is a cool graph on the left because it shows the natural EMFs, right? So it's this tiny little amount in the low frequency range. Lightning strikes can oscillate in the thousands of hertz, and then visible light is in the trillions of hertz or cycles per second. So remember that picture because we'll come back to it. But it's cool, and this graphic on the right comes from Richard Feynman, the Nobel Prize winning quantum physicist who wrote about this in the 60s and lectured on it, I think, maybe 70s. So this was known, and this was taught to the world's top students. But where did it go? Why did we lose all of this education around the electromagnetic aspects of our environment? And we'll touch on that a little bit. And the rest is the solar spectrum. So I think this has been shown at least 4 times today. So we get that from ultraviolet to visible to infrared. We have solar radiation reaching the Earth. And then we also, like I mentioned, have this atmospheric window. We have an atmosphere that's protecting us, a magnetic sphere, magnetosphere, that's protecting us from other solar radiation reaching the Earth. And this kind of depicts what is actually making it to the Earth. And it's fascinating because there is actually a radio window of radio frequencies from outer space making it to the Earth. However, if you put one cell phone on the moon, according to this one researcher, it would outweigh all of the natural radio frequencies that is making it to the surface of our planet. So that's kind of prefacing the amount of unnatural frequencies, especially in the radio realm and range that we are being exposed to. So here are non-native electromagnetic field sources. And I'll probably rant for quite a bit because I don't have too many slides on this, but I could probably talk about 5G for like an hour. I think I have on Max's podcast. And I could talk about AirPods and Bluetooth and high voltage transmission lines. These are all really unnatural sources, and they're all different frequencies, or they vary. So in the top, we have the electrical power system, right? 50, 60 hertz, 50 hertz down here. And again, it was outlined already today. When did that occur? Why did that happen? And what was the reason for that? And did we see change in our health as a society? And in the late 1800s, Tesla and Edison actually had a battle, right? The DC versus AC power grid battle. It's a really cool one to look up because Tesla was a fan of alternating current and Edison was a fan of direct current. And if we had gone with direct current for our power grids, the world may have looked a lot different. But there was issues with high voltage transmission, so Tesla won, and Westinghouse bought them out, and they electrified the world, mostly to power lights. So artificial lights wouldn't have transpired as a ubiquitous issue if we didn't have the electrical grid. And then all of a sudden, every city in the world by like 1940 had electrical power. So an AC field alternating that we never had before in human history. And there was already an incidence of chronic disease starting to proliferate. And a good book to read on that is called The Invisible Rainbow. Again, this is all like very correlated data, so we can never, and it's a problem with EMFs in general, is you can never isolate a lot of these variables because we change a lot of things. Throughout the 20th century, we have all these non-native electromagnetic inputs. We started eating like garbage. We started moving more inside. It was all coinciding at the same time. And you'll see it's really a toxic threshold. And I'm here to talk about EMFs. I wrote a book half about the food system. It's everything. We have this toxic threshold, and it's only been ever increasing throughout the 20th century into today. So let's go to the cell phone tower. So 5G is really popular, right? Everyone always wants to know about 5G. Well, let me tell you that 3G, 4G are just as bad, and they've been around for a long time since since we've had cell phones, since we've had cell service. The difference is they're now moving to higher frequencies. And that's a problem because it's higher energy wavelengths, and there's actually no studies really done on 5G directly. So again, we get into this tricky situation of, show me the studies, and there are none because no one's researching it, because there's no incentive for it. A researcher that's going to test if 5G radiation is maybe like damaging for, cognitive health or mitochondrial function, they are not going to have anyone to fund that study. And if they have a negative outcome, it's going to blacklist them from their peers in academia. So there's literally no motivation to uncover the truth around these topics because it's so inconvenient, because we use this technology, and I'll get a bit more into that. But 5G is a problem. However, the higher frequency bands, 5G has 3 bands, the low band, mid band, and high band. The high band is the millimeter waves, which was what everyone was freaking out about in 2020 and 2021, especially during COVID, especially when they were saying it was causing COVID, which it doesn't even really matter. It's all toxic. And if you have a toxic threshold, if you got vaccinated, you live in a giant city with 5G towers next to your head, it's probably not good, right? So that's the only place where the high frequency 5G is actually rolled out, is in cities. Because the good thing about 5G is the range on those waves is horrible. It's like 100 meters and then it drops out. That's why they installed all these repeater towers everywhere, so that they could get the signals across. And if you live not in a downtown area, you're much less likely to be attracted to a 5G signal. However, density of living matters the most. And the more people you're around, the more devices are around, the more cell tower signals that are pinging, and the more exposure you have. And Wi-Fi and AirPods that I have on the right actually use the same exact frequency, 2.4 gigahertz, which happens to also be the same exact frequency that a microwave uses to heat up your food. So if it's dehydrating your food, it's very low power compared to a microwave. Imagine what it might be doing to the cells in your body. And then here we have some cool ones that are also unsuspecting. So we have the blue lit screens, which is obviously a very pertinent and pervasive non-native EMF. We also have smart meters, which are, I think, mandatory in all new construction in the US and Australia. And they're constantly pinging a cell tower, transmitting data like thousands of times an hour, which is an absolutely unnecessary exposure. And then things like a radar gun, they're using 30 gigahertz to track your speed, which I didn't even know. But if you go back to the 90s, they found that police officers have like a way higher incidence of testicular cancer, and there's all these lawsuits, and they never heard about it ever again. The top right might be my favorite one, and perhaps the favorite one for this audience, because I think this is something that was used on Australian civilians during COVID. It's called an active denial system. So this has been in the military for 15 plus years, and they started using it in some places for crowd control, right? So I think there was, some protests going on, and people experienced the wrath of a 90 gigahertz, roughly, electromagnetic weapon that the military uses and unleashed on civilians. And you can basically move people, you can cause their skin to feel like it's burning. This is the future of military, but it's also, concerningly, the potential future of control for our governments on, protests and outbreaks. And anyone who's in the military sphere knows that all warfare is turning to electromagnetic. It's EMPs, it's lasers, it's things like this. It's all going to this invisible warfare that we can't really control. So again, this has been around for 15, 20 years already, and now it's just getting out there. Oh, this was supposed to be, I wonder if I could change this. Okay, my PDF got messed up, unfortunately. How do I go back into presenter mode? I'll just talk about this as we get that sorted. So this is the frequency allocation chart, the radio spectrum that we have in the US. So as I mentioned earlier, and I'll just go back to this chart here. So we basically have nothing outside of the Earth's natural magnetic field, lightning, and visible light. It's like a tiny stick. Now we have the entire band is full of radio frequencies. So this is going from the kilohertz, the thousands of hertz region up to gigahertz, especially with cell phones and everything. So radios, I mean, a lot of this is isolated and cut off for military applications, for communications, for airport, telecommunications, radio, FM, AM bands. It's all part of it. So we went from having no radio frequencies to an infinite amount of exposure. And these waves are not just foreign because of their frequency, which is 100% the case. They're also highly different because they're pulsed. And pulse signals are very alien. And this is a very technical slide that I made for one of my EMF courses that I used to promote a lot. But basically, radio frequencies and as well artificial lighting are highly pulsed, and they do that for signal control, for having more bandwidth and signal modulation, and this is also a problem. And the research has shown, like from Dr. Martin Powell, that these pulsed waves, if you took the same frequency and had a continuous wave and then a pulsed wave, it has an even greater effect. So if you measure with an EMF meter, you'll see that radio frequencies are constantly going up and down, and you're constantly pinging the tower. So this is even more problematic than if we had a just continuous wave. So this is a video of a flickering phone screen that I don't think is going to work, so we'll skip that. But basically now, it's ubiquitous. It's everywhere. We have cell phones running our lives. We have artificial lighting, TV screens. I mean, you go on a flight now, and it's like, everyone's on the TV, back of their head, there's Wi-Fi at 30,000 feet. It's insane. So what is this actually doing, right? So Professor Ollie Johansson, who famously, I was talking about with Cameron, won an award for the quack of the year. That's like how the reputation of EMFs is in the mainstream. But he was quoted as saying, our current radiation exposure is a quintillion times higher than what our bodies are programmed for. And Pikachu is not a fan. So it's not even a real number because it's inconceivable. Like, we don't even know. The actual number is infinite because we'd never be exposed to any of these frequencies before, and now all of a sudden they're everywhere. And people are just like, well, it probably has no effect. Like, not everyone's dropping dead. We're probably okay. Even though Apple has a warning label on their product that says, never hold this next to your head. Yeah, and most people don't know that because they don't promote that. And who's funding a lot of these research studies, and why this is so important? Because we're electromagnetic beings, and we're meant to be on this earth. And there's a picture of me last time I was in Australia attempting to do a handstand. But if you think about the optimal human environment, and again, a lot of folks already touched on this today, it's just being outdoors. It's getting your feet on the earth. It is absorbing sunlight, full spectrum sunlight, and absorbing the natural EMFs in our environment. So just going to quickly go through why this is so important. Because we're electromagnetic beings, we've touched on the light story. Light is how our body tells time. Sunlight is an electromagnetic input signal. We run on biological clocks. If you distort that input signal, you distort it with artificial light, we're going to have chaos because our body is going to be running off different times in different areas and not optimized for our environment. Also, the ones that I really like to tell people to convince them, it's like, well, electromagnetism doesn't matter. How do you measure brain activity? An electroencephalogram. Our brain waves are in the low frequency range. Actually, alpha brain waves, which is kind of like a light, relaxing brain state, it's the one you want to be in when you just want to relax and chill, is around 7 to 12 hertz. The Schumann's resonance, natural frequencies of the earth, are in the same range. That's not a coincidence. And you can go up and down down to like 1 to 2 hertz for delta waves and up to 12 to 30 hertz for beta waves. And it's showing that we are electromagnetic beings. The heart. We use an electrocardiogram to measure heart activity. There's electrical potential every time your heart is beating. The ventricles are depolarizing, they're polarizing. It's electrical potential, it's voltage. That is how we are alive. And this is a more esoteric picture because there are no good images of this, but our heart actually emanates a magnetic field because of the moving charges in it, feet outward from our body. And you can measure this with pretty expensive, magnetic field reading equipment called a squid, which I want to buy at some point. But it's cool because it means that your environment and the people you directly interact with, you are directly interacting with their field or their aura, right? Like this is where science meets woo-woo really quickly, but it's factual, and it's factual that moving charges and electrical potentials are generating these fields. We cannot see them, but we can feel them and perceive them. It's very weak. You will never be able to measure this unless you're in a Faraday cage, but it is there, it's been recorded, and it's really undeniable. Another imaging or measuring of our body's health and activities, purely electromagnetic, is the MRI, a magnetic resonance imaging machine. It uses a very strong magnetic field to actually align the spins of protons in the water molecules of the organ that we're trying to measure, and then it blasts it with a radio frequency, and the protons, how they're aligned, then resonate at that specific frequency, and that gets pulsated back and is what's measured. So, I mean, like, what else do you need to know that, like, our whole entire body is being affected by electromagnetic inputs? They're literally using this to measure images of our biology. But if you stand next to a power line that also emanates a strong magnetic field, there's no way it could have any impact on our health. And then grounding, earthing. I mean, this one's like, I feel like I don't even need to tell anyone. Everyone already knows this. But grounding and earthing has basically gone mainstream because it's, I think, just fun for people to walk around barefoot and kind of stick it to, Nike and the man by walking, connecting to the earth. But it's really crazy. Like, literally walking barefoot on the earth, you get to absorb free electrons because it's negative surface charge from all those lightning strikes. Remember I was talking about lightning? And stronger at the equatorial regions, and then that improves blood flow. It's probably the best antioxidant that you could consume. The sweat glands on your feet and your hands are naturally more active, so that it improves the conductivity so that you can absorb these free electrons more, and that is an input signal that is also going to strengthen the relationship with the natural magnetic field and electric field of the earth. So grounding has been shown to improve cortisol rhythms and your circadian rhythm. It improves blood flow because blood is naturally, red blood cells are using negative charges to separate and to flow smoothly. The entire cardiovascular system, which if you weren't in Melbourne, Max did a brilliant talk on the difference in potential and the importance of biological water, how that plays into cardiovascular health, and how also sunlight plays into that role by affecting that biological water. So it's another example of electromagnetic beings. Voltage-gated ion channels are another one. They literally have a voltage sensor so that things like potassium, calcium, sodium can go in and out of the cell. I won't dive too deep. Mitochondria, that's a word that I'm glad people have already brought up. I didn't really know how deep to go on this, but the mitochondria, the most important aspect of our biology, in my opinion, they are literally creating a voltage gradient from protons, so proticity, not electrical current. The flow of electrons is electricity, and in our mitochondria, we actually have a flow of protons and a proton gradient. But about 150 millivolts across our mitochondria, about 1,000 mitochondria roughly in each cell. It depends on the type of cell, more in the heart, more in the brain, more in the eyes. We have 30 trillion cells in our body. You take that, it's like 4.5 times 10 to the 15 volts collectively. And that's where people like Doug Wallace, who's a mitochondrial researcher and expert, say this is the difference between being dead and being alive, is the electrical potential in our bodies. And the mitochondria are vastly important. They sense the electromagnetic inputs in our environment. They produce energy, which you could debate what exactly that is. They produce ATP and they produce biological water. Both could be said to be sources of energy. They're a communication hub for our immune system and a whole lot more. So I mentioned the magnetic field being vastly important as well to our biology. We actually can sense it. So I know every man in this room has a good sense of direction, even if they get lost sometimes and need to ask for help. But we actually have magnetic crystals in our brain to sense the magnetic field of the Earth. And this has been proven. 1992, this was proven that 5 and 100 million crystals per gram of magnetite, which is magnetically sensitive crystals, are in our brain. And, you think of ancestral times where people had to navigate. You think of other biological creatures, such as birds that are constantly transversing or migrating, whales, everything. How did they know where they're going? There's no GPS. There's no Google Maps, We can't go anywhere without, Google Maps. I mean, we're so beholden to our devices that we've lost this touch completely. And there's been some new research coming out that has proven this as well. So now I want to kind of get to the biological effects. Like, how bad is this stuff, Do I have to throw my phone out in the bin? Do I have to just move to the woods? What's going on? Like, how bad is this? So biological effects, artificial blue light, it's already been covered. Broken clocks, this is a big problem, leads to a lot of downstream issues. Blue light is the most dominant sight gaber to our body, so it's one that's setting the rhythm the strongest. Blue light suppresses melatonin more than longer wavelengths. I think this has been covered enough. Radio frequencies, extremely low frequencies, are classified as possibly carcinogenic. There is research showing that chronic exposure, and emphasis on the chronic, has been linked to show the increased risk of neurodegenerative diseases, reproductive issues, cancer, cardiovascular disease, diabetes, headaches, migraine. I mean, you literally go down the list. Anything that exists, it's been linked to. And here I have a lovely image of a study about a guy on his cell phone and how that's affecting his fertility, his sperm quality, and it's something that we're seeing, right? Infertility is just through the roof. Now, both male and female. I mean, typically it's blamed on the female when probably the guy has his cell phone in his pocket all day long, is eating like shit, doesn't consume enough, high quality nutrition and saturated fats, as Kiera mentioned in her talk, and no one's considering this. And actually, if you go to really good fertility clinics, they will bring this up. They're like the only people that acknowledge that. And yeah, I mean, not to call people out, raise your hand if your phone is in your pocket right now, like turned on. Probably a good amount, right? Because we don't even think about it. Like, nobody is telling us that this is like bad potentially for our fertility, let alone our health. And I'm going to get into what you can do about it, what matters in terms of what to be aware of. So I'm going to scare you, and then I'm going to tell you that it's okay. Like, it's going to be okay. So basically, everyone wants to see the studies. Now, I could handpick research. I can do this. I can say, it causes cancer. There's some crazy studies going back to the 60s. I mean, in the 70s, this was like a public health, public issue. You can go watch a 60-minute documentary on Project Sanguine in the U.S., which basically they put up this giant antenna, the Navy was trying to, and then these doctors testified against it, and it was like this whole ordeal. So in the 70s, the USSR, the Soviet Union, was big on EMFs, and that was like big in the US media, and then they swept it all under the rug, and then nobody worried about it, and then all of a sudden, the dot-com bubble happens, the tech boom happens, and we all just have these devices everywhere before any research is done, any safety. The FCC, which governs radio frequency policy in the US, hasn't updated their guidelines on safe limits and thresholds since 1996, which is the year I was born, which is before the Wi-Fi router came out. So yeah, pretty crazy, but people want to see research. So my favorite person to point to is this guy named Dr. Henry Lai. He's just this professor who had no agenda, at University of Washington, and he just started stumbling across a bunch of evidence. He just started realizing, like, wow, there's a lot of research out there on the negative effects of EMFs on our health. So he put together 2,500 plus studies in regards to non-native electromagnetic exposures, and he found that roughly like 80 to 90% of them showed harmful effects. So like you literally can't argue against such a vast body of research. And guess what else he found? He found that when industry funded the studies, they actually only showed biological effects like 30 to 40% of the time. So there's meddling going on, of course. And, I'm not going to read this whole list, but you can go down from radio frequency exposure to power frequency exposure, and it's the same thing. And they're always reporting on like oxidative stress and infertility and neuropsychiatric conditions. But one that I want to point out is at the top here, the 96% of 92 studies in the radio frequency exposure group had a specific absorption rate of less than 0.4 watts per kilogram. That might not mean anything to anyone who's not looked into this, but basically they measure radiation exposure from your cell phones with a metric called specific absorption rate. So they measure how much is the radiation is being absorbed into the tissue to your head, and then they do some on the torso as well. And this is like how they classify cell phones as safe. And this is it's below. It's like a third of what the actual threshold is. And 96% of these studies are showing effects below that threshold, significantly below that threshold. And you can get into this history. There was a doctor in France who actually revealed that 90% of smartphones on the market were higher radiation than their metric. And then if you really want to get pissed off, you can go look up how they do the testing, and they do it on a 6'2", 220-pound, I don't know what that is in kilograms, but large adult male. Imagine the testing is being done on Simon, and the same thresholds are being used for your 4-year-old or your 8-year-old, or anyone else, or a female, half the size. So that's a problem, right? How is that allowed? So here, just getting into more specific reasons, I'll probably skim over this, but why are these so bad for our health or our biology? They're stressors at a high level, and this is kind of what's been communicated for decades. They activate, cell danger response receptors, they activate voltage-gated ion channels, they weaken the blood-brain barrier, they disrupt our microbiome. All these things, for me, point towards dysfunctional mitochondria. And as mentioned, I think it's the most important aspect of our biology, being the electromagnetic sensors, being the energy inputs, the communication hub. And this is why, I think this was already mentioned by Cameron, so we really need to get more diverse speakers here, Max. We're all just saying the same things. But mitochondrial dysfunction plays a central role in aging and pretty much is related to all forms of chronic disease. And it's true. And if we compromise our electromagnetic environment, we're going to end up with dysfunctional mitochondria. We're not going to be able to have the energy, have the electrical potential and output to handle the stressors and handle the demands of our life. The ones I like to talk about, which is less biochemical and biological, is more so just like engineering and common sense. So these are words that seem to be like pretty popular, especially in the crunchy world of vibration and frequency and resonance. So, what's the vibe, man? Like, what does that even mean? I'm not resonating with that message. These are words that are thrown around, and actually, most people don't understand what that means. And this is all cool to me because I used to work in electronics where we would actually measure what's called EMI, which is electromagnetic interference. And this for me is the easiest way to explain why these things are harmful. So we have input signals that we want. We want sunlight. We want the Earth's natural magnetic and electric field. But we have all this other crap. We have radio frequencies, we have power frequencies, and they're causing incoherence. They are disrupting our biological input signals that we need. And then they're also disrupting or causing some resonance to happen in our biology that's very unnatural. So you can see the examples. And one thing that has kind of been thrown around is this resonant antenna effect. And back when like FM radio was really popular, that's around 100 megahertz. It's actually, the whole resonant antenna theory is basically the length of the wavelength and the length of the antenna has to be in the same ballpark. So that's why the higher the frequency they go, the smaller the antenna. So really old school 2G, 3G cell towers, they have way bigger antennas because they're lower frequency. 5G towers have these small little rectangular antennas now that you see, and there's multiple. There's like 12 of them on one tower. That's because they've raised the frequency. And the FM radio band happened to align at a wavelength of around, the frequency is 100 megahertz, the wavelength's around 6 feet, so the size of a human body. And they actually did research that showed there was a stronger biological effect, so they moved the threshold just for FM radio down like 3x, and that was what they did. So that was a while ago. No one really operates on FM radio too much anymore, but we can use that as an example. And the way I like to talk about it is, I'm talking in this room right now. Nobody else is talking. You can hear me very clearly, right? If everyone started talking right now, kind of like when Max is trying to round everyone up, he's literally got to tell 5 people to start whistling. You can't hear as well. The main signal gets diluted because there's so much noise on the line. And that's what's happening in our biology, right? We have the input signals that we need to receive from our environment, but there's so much noise in the room from 5G, from Wi-Fi, from that cell tower down the road, from some power supply, from your fridge, from the electrical power in the walls. So that's diluting the signal completely, and then we get something that is not optimal. And when our body is not communicating properly, we have biological chaos. You don't receive the instructions. It's like if you have 25 people in a line of communication, by the time the message gets to the last person, it's like in Japanese and it started in English. And what happens? We have inflammation, we have the wrong input signals, and we have all of this chronic fatigue, which is ultimately leading to chronic disease over time, over chronic exposure. And there's some cool kind of stuff coming out in the research that's showing the resonance of cells. We don't even understand really how biology is functioning at these levels. But a cool example here is the ATP synthase, which is this nanomotor in our mitochondria, which is pumping out protons. It's using the proton voltage to create ATP. Like, this is literally in our body. I mean, we have nanomotors in our body. It's amazing, right? Like, it's truly an act of God, and we have thousands of these, but up to thousands of these in each mitochondria, and I think I already gave you the number of how many mitochondria there are in each cell and in our body total, and it's incredible. And this generates a magnetic field because it's rotating at up to 7,000 rotations per minute. So you can imagine when you have all these unnatural fields, that's going to be causing some disruption, and that magnetic field is attracting things such as oxygen to the end of the electron transport chain to be that final electron acceptor. So combine that distortion with, say, things like no grounding that's blocking our blood flow because we don't have the proper negative charge, and you're getting hypoxia for no reason. So that's leading to a lot of biological issues. And then we have water. Water is so fascinating, and it's up there. It might be one of the most important, if not the most important aspect of our biology. It's the one that is the most under-discussed. It's kind of just like, what do we need to know about water? It's just there around the cell, but in reality, it's so much more. It actually has the potential, literally, to have electrical potential and be a battery. And Gerald Pollack's work has defined this through the exclusion zone and can be charged through sunlight and proper electron flow in our body. And then we also have coherent domains within our water. Basically, water is acting as an antenna. It absorbs the electromagnetic information in our environment. So the information that you give it is going to be the outcome that, the water has. So if it's absorbing a bunch of radio frequencies instead of natural frequencies, that's going to be problematic. And there's all these things, that will happen from non-native EMF exposure, such as disrupting the network of hydrogen bonds and coherence and the exclusion zone and decreasing the voltage of the water battery, and that's leading to impaired communication and energy production and mitochondrial dysfunction. So it's another component of our biology that's highly dependent on electromagnetic inputs. And just to summarize, this is a lot of information. Light is information, and light is really what's driving our biology. And if we give these incorrect input signals, we are going to have suboptimal outputs. And that's what it comes down to. So native electromagnetic fields, sunlight, seasonal food, temperature, oxygen, water, bacteria, these are the input signals that we want if we want optimal outputs. It's a system, right? I'm an engineer, so this is how I think about it, and it's that simple. Optimize the inputs, and you will optimize the outputs. So I know way over time here, so this generation smoking is what I think about our devices, and it's a problem because children especially are far more vulnerable. They have smaller body sizes, they have higher biological water content, their eyes let through more blue light, they're more sensitive to melatonin disruption, and they're on our device. They're on devices younger and younger and younger, and we have no alternative. So the basic TLDR for mitigating EMF exposure is elimination of the source, duration of exposure, distance is your best friend. You can work in shielding, but basically, if you don't need something, unplug it. Turn off your phone or turn on airplane mode. Don't carry it on your body because the intensity of the field goes down by a squared factor when you put more distance in between it. So use speakerphone, use wired headphones, and then the duration. Most biological effects in these studies are shown after 24 hours, 36 hours, 48 hours plus. So if you can minimize that duration of exposure, you'll minimize the harmful effects. So turn your Wi-Fi off at night. I turn the power to my bedroom off at night because I have a separate circuit breaker. I don't keep my phone or anything plugged on in my bedroom because the sleep is really important. That's when you're restoring and repairing the day's damage. So if there's one thing, if you can't control your day-to-day, you have a 9 to 5, you can't get outside, need to be on the phone, that's fine. Prioritize your sleep. Prioritize your bedroom and really allow your body to restore and repair from the day's damage. That is my biggest tip. We can't avoid this, right? Like, it's everywhere. Fear-mongering is not the answer. But if you literally use your cell phone smarter by using speaker, airplane mode, you turn your Wi-Fi and things off at nighttime, and don't hold your phone next to your head, you'll probably reduce your EMF exposure by 95+%. And that's a win. And then proliferating that message to your children and how they use devices and how they use screens is really, really important. So here's some memes. Better Call Saul. This guy was onto something, but the way you react to these toxins and stressors is going to determine their effects. So if you're constantly neurotic about EMFs and cell towers, I get all these questions. There's a cell tower like 600 meters from my house. It's like, all right, is your phone on in your pocket right now? Because that's probably more important. And the government is not blasting 5G into your window because they're worried about you. So yeah, use your speakerphone in public. Be that guy. It's better. And then just quickly, I'm happy to talk more about this afterwards, but my full-time job now is I work for the Daily Computer Company. We are the first company in the world that's building healthier technology, healthier computers. That's our mission. Someone's got to do it. Apple doesn't give a fuck about us. Neither does Google. Neither does Samsung. They're never going to innovate. They're not going to. There's no incentive. Apple sells 75 million iPads a year. They're a $3 trillion company. So my founder's been working on this for 6 years. I dropped everything I was doing to jump on board. It's been amazing. We just launched end of May. But basically, we have a new screen technology that's blue light free. It's reflective, so you can use it outside. It's low stimulation. It's not very dopaminergic. It's not going to suck you in like a Las Vegas casino type screen. You can use it outside, so you can touch grass and be productive. And yeah, it's flicker free. We have a custom amber backlight that has no blue light, so you compare it to an iPad Spectra, and yeah, it's alien versus more like a candle, as you can see on the left from some spectrometer readings. And we're just getting started. We're basically trying to take all the reasons why technology is bad for our health and address them. So that's our mission. You can check us out at daylightcomputer.com. Don't forget, nature is the real world. All the input signals you need are coming from the earth and coming from the outdoors. It's where our biology is designed to thrive. So go outside. Thank you.
Tristan Scott, everybody. Round of applause. Beautiful. Incredible presentation. We're actually about to have a Q&A, so if you've got any questions for Tristan, save them for them, because right now we're going to be this is a light and health Q&A on the underappreciated yet critical role of light on biology, featuring Cameron Borg, Dr. Max Gulhane, Kiera Lee, and Tristan Scott. Welcome to the stage.
So we might open up straight to the floor. Does anyone have any questions for any of the speakers?
It's a quick question. In your opinion, what is the most healthful thing to do from the point that the sun goes down to when you get yourself into bed? There'd be a few hours, I imagine.
Is that directed at anyone particularly, Mel?
I'm interested in everyone's opinion, I suppose, on, the sun goes down maybe 6:30, 7 o'clock, but...
So I mean, I understand, so it's going to be individual dependent. I understand that you're a very, very busy, productive, entrepreneurial lady with a family. So I would actually, and I don't have an affiliation with Daylight, but you're constantly making podcasts, Great Birth Rebellion content. You would probably benefit from having those lights really low at eye level or below, you working on something like a daylight computer for maybe an hour or two after sunset, and then commencing your wind down, but still respecting the circadian signals such that you don't have overhead isolated blue light and visible only light. And then at some point switching off from a work mode, which is hard, I know, and then really engaging in that deep wind down phase and having a dark pair of blue blockers on, if that's the case, that you have to have other light sources.
Yeah, I mean, I would just try and be low stimulation, right? Like kind of Max said, and don't eat late, don't exercise, try and wind down. And even if you're on a daylight or something, or have blue blockers or screen filter on, like whatever work you're trying to do, make it like pretty easy in terms of the stimulation level. But that's all I had.
I reiterate those points as well. I think low stimulation is the best way to put it, because it covers all aspects, not just the light, but you don't want to be doing really hard, involved intellectual work at 9 p.m. It's not really ideal. But everything, if you can just avoid any sort of high sort of stimulation, you'd be doing pretty well.
I think from a hormonal perspective, the work that you're doing, you really want to be quite conscious of the type of work you're doing, dependent on what time of the day it is. Too close? Oh, that makes sense, doesn't it?
Is it that mic? Maybe just use one mic.
Keep this one. So electromagnetic. So all of your hard work that you have to use your brain for, try and do it during the day, and then the more relaxing work that you actually enjoy, do it at night time. Also, a lot of devices, they give off EMF, which is doing what carbs do to your body. So upregulating blood glucose, which will make you crave carbohydrates. So I would just be cutting my food off at 5 o'clock. I wouldn't be eating after sunset, and then being really conscious because you don't want to block that leptin reception at around 10 p.m. You want to keep that open, which means that you want to keep insulin low, which means, turning off the Wi-Fi when you can, doing all the things, and then cutting your carb intake because that's the carb that you can control.
I've got a question for Tristan. Kids love iPads, on the plane, in the car, at restaurants. Do they enjoy the daylight computer as well? Do they still get stuck into it?
Yeah, absolutely. If you have a choice between like a daylight or nothing, like they will choose that every time. Obviously, they're probably going to choose like the bright blue Candy Crush like iPad experience. But the problem is when you take it away from them, like they throw a fit, right? I mean, I don't have kids, but I've looked up plenty of videos and anecdotal evidence. They lose their mind when you take an iPad away from them. Why? Because their cognitive development is trying to just be in that environment, and they're so much more sensitive to the stimulation. Whereas the daylight, the anecdotal evidence I have is that they're still upset, but it's not the level of tantrum to where like, the whole day is ruined. So it's something for me. I actually selfishly was like, wow, now I could give my future children a device and not be totally guilty about it. Whereas before I was like, you're not getting a phone till you're like 20. So, yeah.
Question
nice and short for
The
everyone.
question for Tristan, please. I've got the timber in the car for building my Faraday cage because I know I need to because I've got mitochondrial illness with damaged ion channels and mercury, lead, tin, nickel and aluminium that crashed. Mercury, lead, tin, nickel and aluminium that crashed cytochrome 4 basically. With regard to that, I'm putting silver threaded sheets in. Is there any dirty electricity coming from the mains ground? Because I think I need to ground it independently outside because our electricity our AC used to be pumped back to the power plant, but these days they just inject it into the ground. And if I use that existing AC ground, am I going to induce more issues?
Yeah, so the question about grounding, dirty electricity, and you guys sending your stray neutral to ground. I will always advocate for grounding directly into the earth, like 100%. I don't trust the wiring in my house. You're making yourself part of like the AC circuit, whereas if you isolate it with a conductive rod in outside, then that's way better off, and you're just it's just you and the earth. However, if you do have like power lines running underground, I would just make sure to, wherever you're sticking a rod in the earth, it's not near any power distribution equipment. But yeah, that would be my recommendation.
I've got a group of friends who we're like a chat group on health, and ironically half the group's gone vegan. I haven't had much success getting them over to the carnivore. And so we're all talking about measurements. You have to measure this, you have to measure that. And I say, well, I can just measure myself by how I feel, and maybe the odd blood test and the odd other. And one of them's pushing me to get a Garmin watch. So I'm a bit torn on that with the EMF. So I wonder what your views on those sort of smart watch devices are.
I mean, I'm not a fan of wearing anything that emits EMFs for an extended period of time. So again, the problem with AirPods, Bluetooth is really low power, but you're wearing them directly on your body and especially next to your brain. Same with the Garmin watch. I don't know if you can disable Bluetooth or what have you. The rest of the EMFs are probably not that bad, but how long are you going to wear it? Are you going to wear it for like a 30-minute run? Then sure, that's not like a huge, if you're training for a marathon, like that might be really valuable to you. But these people who wear Apple Watches and AirPods for 14 hours a day, I think if you're a finance bro, they sleep in them. So you really like the chronic duration and distance is problematic. And there's some meridians and important areas for your body on your wrist that, I mean, I'm wearing a Casio watch here, so I'm not a digital guy. Max is also based.
Thank you. What's your opinion of EMF mitigation devices like these Blue Shield things?
Is it a harmonizer, what is it? Just like
I can't remember actually what this is, but this is one of what they call their premier something or other.
Do you just like carry it and then like you're good? Is that their marketing?
They say you just carry. It's the travel version of it. I actually can't remember the science behind it.
Yeah. So those type of EMF mitigation devices, I'm highly skeptical about because there's no like physics for that to work, right? Like what I said in the beginning was our electrical power is 50 hertz. Our Wi-Fi is 2.4 billion. How is it harmonizing all of that and then keeping the good stuff from coming through? It doesn't make sense to me from a physics perspective. However, again, if you buy like a shungite crystal and it like makes you feel good and like placebo effect is real, and then there's always the opportunity that we don't know what we don't know, and some Swiss or German scientists, which is usually what these companies say on their website, figured out some proprietary thing and it's energy neutralizing. And I've talked to researchers that say the same thing I do, and they've measured it with some like equipment, and they'll be like 98% of them don't do anything, but then they're like for some reason like 1 or 2 do. So yeah, if it's $1,000, I would not buy it, but if it's like $50 and it makes you feel good about yourself, then there's no harm, no foul. But yeah, the research behind those things are not direct enough for me.
I'm not sure who I'm directing this at, but could someone just explain the difference between overhead light at night and putting the light low, below knee level, was it?
Max will probably be able to explain it better than me, but I believe that there's a different distribution of receptors on the top part of the retina versus the bottom. So at night, there's less receptors on the top, so if light's coming from the ground up, it's less disruptive.
Yeah, in the ancestral and evolutionary past, the time that you would have blue light is going to be overhead. This is based on the transition of the sun in the sky. So the density of that melanopsin in the part of the retina is greater, sensing light overhead. That means that potentially any kind of light, because there's a distribution of activation. It's not like 480 is 480 nanometers is the only point it activates. There's just a curve, action spectrum. So the point is just the position of light as well as the intensity, the lux, as well as the wavelength are all relevant. But it's complicated, but simply have one of those warmer lights, like candlelight perhaps, like a very low intensity red LED closer to the ground, and that feels good. Intuitively, it feels better. And remember, when the sun's lower in the sky, that is when we expected more of that red and infrared light. So,
thank you.
Cindy.
Who you can be next?
I love to read, and I have a Kindle. It's a Paperwhite. How does that affect me at night? Because I usually read when I go to bed.
Yeah. Does your Kindle have a night mode, or?
It's an old one.
Okay. So any of the backlights will still be emitting blue light. And then the night mode, whether it's on your iPhone or the new Kindles have a night mode backlight, they still have blue light. So on my presentation, the last one that I show with like the candle was like the iPad night shifted, and that still has blue light. Literally the only way a modern screen is blue light free is if you go to the settings and manually turn it to all the way red, and then that's a problem because you can barely see anything. So what we did at daylight was we made our own custom LEDs to have like a tiny bit of green, which your photoreceptors are more sensitive to, and then you can turn the brightness down. It has a lot of yellow, a lot of orange, and red, and then it's a more balanced spectrum.
So are you going to do a Kindle?
What do you mean?
Well, I want to be able to read.
Yeah, our product, the tablet we have, I'll show it around after, but it's basically a Kindle on steroids. So It's a Kindle that can be used for any other function, internet apps, etc.
And I have one more question. I spoke to Jalal Khan and I asked him about EMFs, and he said something, and I can't remember the name of it. but it's Egyptian lines, can anyone remember?
Biogeometry?
Yes, biogeometry. What do you think of that?
I haven't taken a deep dive into biogeometry, but I could say like geopathic stress, like feng shui actually, is tied to the Earth's natural magnetic field. And there are like geopathic stress zones based on the field lines. Biogeometry, I haven't gone down that rabbit hole, but yeah.
I'll just say something quickly. I read a book and they talked about an old practice where you wanted to build a house, they'd put horses in the field, and wherever the horses would lay down to sleep, they knew that was the place of least geopathic stress, and they'd build the house there and put the bedroom where the horses slept. I suspect we probably have the ability to know where geopathic stress zones are, but yeah, all animals.
I think cats like geopathic stress, and then dogs avoid it. So, yeah.
Go dogs.
No, I'm serious. It's like a thing.
Yeah, with you use near-infrared light and red light interchangeably. Can you differentiate the difference between the two, like red light or infrared light's warm, 53% of the spectrum, and then near-infrared, that's not warm, that's close to, next to red, infrared light, is it? What's the difference between NIR and IR?
The nomenclature is not very clear. So in the research, they don't really differentiate. Sometimes near infrared and infrared are used interchangeably. Red, I'll tell you how I like to think about it. Red, we can see. Near infrared is the first part that we can't see after red, before we get to the wavelengths that start to interact with water molecules. Which is why we feel heat from infrared, because it starts to interact with the water molecules. Basically, yes. Yeah, the infrared light and heat, it's a very difficult thing to talk about, and I'm certainly not the person to differentiate between the two, but yes, essentially that's red, we can see. Near infrared is the first part that is invisible to us, doesn't interact strongly with water, and you get that for a while, and then you get to infrared where it starts interacting with water, and that's where you get the thermal effect of longer wavelength light. I just want to also say about Cindy's question, with regard to being concerned about blue light at night, the ratio matters, and I think the ratio probably matters as much, if not more, than the spectral content. So Scott's bulb has blue and green in it, just like fire does. But the relative abundance of that visible light compared to the near-infrared proportion is so minuscule. Whereas if you have a visible-only light, like a cool white LED, the visible light is 100% of what you're getting. So I have no issues with getting a little bit of blue and green at night, because I know the relative abundance, the ratio of that visible to near-infrared is so minuscule, it's being offset dramatically, which is what firelight does. There's still blues and greens in firelight, but it's offset so dramatically by the long wavelength light. So I think this focusing on one wavelength or one small portion is sort of hamstringing us when we should be thinking about ratios and relationships, because I think the ratio of visible light to the longer wavelength light is possibly more important than the actual, does this have 450 nanometers in it? And I think people freak out too much about, oh, there's blue, it's bad. It's like, well, if blue's 1% of the whole spectral content, then does it really matter? So.
That's an interesting point you make, Cameron, because in your talk you mentioned that your goal is to unite the circadian and the light and life researchers who are quite siloed, and the circadian researchers are making visible only circadian friendly lighting, but their solution is just to make sure that there is no light in that 420 to 500 wavelength visible area, but they still haven't understood that we need that ratio we need that non-visible light, and we need a greater ratio to make it more ancestrally appropriate. So to be determined.
Okay, time for one more. Lisa, we'll finish with you.
Cameron, I've got a question for you regarding vitamin D. So I do DNA profiling, and we test for polymorphisms in genes, and one of them is vitamin D receptors. So some populations have problem converting vitamin D from their skin on a cellular level, and the only way that I know that can activate those receptors is with sulforaphane. What would you say to that? Just that population just needs way more sunlight. It's about the...
I probably wouldn't say much because I don't know very much about it.
Mm-hmm.
But genes and looking at genetic profiles can be a bit sketchy sometimes because we don't know how they're all interacting with each other. So yes, you may have one polymorphism there, but you don't know how that might be compensated by others. It's interesting, you look at populations that eat lots of white rice, for instance, and the more carbohydrate you eat, the more thiamine, so B1 you need to process that. And in cultures where they eat lots of white rice, they also consume foods that basically help offset that. So green tea is something that that helps. I can't remember specifically, but there's all these relationships with all of the different foods that they're eating to help offset things that are going on genetically. And yeah, it's a very tricky thing. I mean, I don't really know how much to read into polymorphisms because it's a thread in a tapestry. You know, you're taking one small piece of information, and if they are genuinely outside a lot, and they should be making a lot of vitamin D, and their levels aren't reflecting that, then maybe something's going on. But who knows? I mean, there's so many different factors that could be contributing to that as well, it's very, you have to be very careful with genetics because the underlying message when you tell someone they've got a genetic polymorphism that's doing something bad is that the patient has no power over that whatsoever. And I think it's a very dangerous line to tread as a practitioner to imply to your patient that they're helpless. Whether that's true or not, you know, I think that needs to be sidestepped quite delicately, because you don't ever want your patient to think that they're helpless in the situation that they're in and that their health outcome is predetermined, because I simply don't believe that. I don't think genes work like that. We don't really understand genetics very much at all, as well. Like, we seem to think we understand what DNA is. I don't think we have the slightest clue what DNA is. So I'm very careful and cautious about talking about that kind of stuff because I really don't understand it, and I don't think anyone does. But I think the main point is not to have people even subconsciously think that there's something wrong with them, and that that their health outcome is predetermined by a polymorphism of some description. So yeah, I wish I had a more helpful answer and say, oh yeah, just do this, this, and this, but I just don't know. Yeah.
The other point that perhaps could be made is that when we get beyond a certain window of UVB exposure, vitamin D is generated from this 7-dehydrocholesterol, but there is so-called irradiation products that actually get produced post vitamin D. So the vitamin D structure accepts more UVB light and then essentially gets photometabolized or photoconverted into other vitamin D-like products, like one's called testosterol, lumisterol. These have unique properties, and these have unique enzymatic transformation steps that are distinct from vitamin D itself. So whether there is some polymorphism, and that patient might be getting all kinds of benefits from these metabolite compounds that are not necessarily 25-hydroxy vitamin D, but they're still having the amazing anti-proliferative, anti-cancer effects, the amazing immunomodulatory effects, the amazing cell differentiating effects on that keratinocyte layer. So we don't know. So I think that the answer is not that it's futile. Go to Chemist Warehouse and grab a big box of 1000 IU tablets. It's, still work on these principles, because as Cameron mentioned in his talk, 25-hydroxy vitamin D and that storage form, that's only the tiniest sliver of the whole picture of sunlight and health.
All right. Thanks, guys. Give it up for Max, Tristan, Cameron, and Kiera. We're about to have another little break. Go stretch your legs. Got about half an hour. And then we've got our last speaker. We're almost at the end. I can't believe it. It's a little bit sad. Yeah, that's all right. Yeah, go stretch your legs, get a drink, whatever you need to do. And we'll see you back in 15-20. guys got in here quick. Didn't you have to do any rounding up? I'm proud of yous. I can't believe we're almost here. Almost at the end. I know. Does anyone want to like share anything that they feel like they've taken away from this weekend so far? Anything that they're going to implement? I'm going to throw my phone in that fire after we're done. But yeah, does anyone have anything that really resonated with them, that they feel like, you know what, I'm going to spread the word about this? You don't have to. Yeah, that's beautiful. That's beautiful. Yep. Alistair, you've been so enthusiastic this whole time. You've got the patron of the weekend, I think. Beautiful.
For everybody. You know, I used to compete with Olympians, and I wanted to stand on top of the podium. But then I realised, no, we all stand on Earth at the same level. There's no need to stand on the podium. And I've got two government journalists that are friends. I've got lots of different people like that. And what you realise when you work with them is that they're just people.
Yeah.
And it's really beautiful.
Beautiful. Wisely said. Wisely said. Good on you, bro. I can attest to that. And it's just great to come here and not be at home. I'm just some meat-eating weirdo that gets in the sun too much. So it's nice to be around people that are meat-eating weirdos that gets in the sun too much. So, yeah, no, it's been great. And I'm so stoked for Max and Simon to have invited me along. Like, making videos ranting about the system to being invited to host a health summit. I'm definitely flattered, and I don't think I deserve that, but thank you. Legends. Thank you. And yeah, give it up for these guys, because these guys have done so much work. I can't wait to see where the next one is. It's a mystery. It's not locked in yet. Bet there'll be more. Also, an informal gathering at the Bended Elbow. Yes. We got the hot tip. A few of you guys apparently going there. So if it wants to be an informal after party, anyone's welcome. I'm probably going to bed at 6 o'clock, but it's been good seeing you guys. I got another raw steak to eat in my bathroom sink. Oh. Are we ready for our final speaker of Regenerate Albury 2024? Yeah. All right. Our final speaker for today is a regenerative farmer and a wizard in natural sequence farming and land contouring, educating people on how subtle land shaping maneuvers can radically improve water retention and fertility of the land. Presenting his talk today called Reshaping Landscapes, a showcase of natural sequence farming. Please stomp your feet and clap your hands. Go wild. It is Stuart McWilliam.
Thank you. I'm mildly shitting myself. So we've had a little technical difficulty. The Canva program that we were using, we don't have enough internet, so I've got it as an MP4, so I'm going to lurk around the computer a bit more than what I would have liked to have, but let's get into it. This is my young family, my wife Amber over here. I drag them all over Australia in a caravan, building contours and ponds and rehydrating farmland. She's very patient. So our farm journey started in a suburban backyard that was full of funnel webs, 3 doors down from the last death in Australia. We didn't want to use chemicals to kill the funnel webs, so we brought chickens. And from those chickens, we bought more chickens. And we leased 15 acres at Wilton, and we had a roaring egg trade because we were on the back of a new estate. So every Sunday afternoon, I'd drive around with a big stack of eggs in the passenger seat, and we'd just go from house to house selling the eggs. I soon realised it wasn't a good way of making a living. So when we got into the cattle industry, we went all out and we bought a 6x4 box trailer off Gumtree. Now, this animal here, he's the same animal that was in that last slide. He's Steve. He's had a few brushes with the law. When we're at Wilton, we're on the back of a new estate, and I'd see these videos up on the community page of Steve eating people's rose bushes. I had a phone call from the police one day and said, "Oh, do you have a red and white cow?" I said, "Oh, I do." He said, "Oh, he's walking down the bike lane on the Hume Highway." Another time we got home and he was at the front gate with a highway patrol parked behind him, with him looking at us going like, "What's wrong? Like, hurry up and open the gate and let me back in." So I think he's been here before. He absolutely shits me, but I have a bit of a love for him and a bit of a soft spot, so he will die on our farm. So this is Charlie Arnott. So when we were at Wilton, we come across Charlie Arnott's podcast, and then we realised that he did a biodynamics course. So Amber and I went across to the Southern Highlands and did a biodynamics course, and it really opened our eyes up with how we could farm without chemicals and taking our shoes off, looking at the stars, the moon cycles, and getting in sync with our landscape instead of spraying chemicals over it and just destroying it. So from Charlie Arnott, we come across the Tarwin Park training course for natural sequence farming. That was held at Burrawa at Charlie's property. Just bear with me for a second here. This is at the Tarwin Park training course. This information that I'm talking about, Peter Andrews, this old bloke here that's rousing on us, he's been doing this for about 50 years. He's had scientists study this. This isn't something that I've brewed up at the pub. Some of it is, but anyway. So this is Peter's work. That's Peter's son there, Stuart, that does Tarwin Park training. He's the man that's trained me to what I'm doing today. It's Peter's information, but Stuart's taken me under his wing and put a lot of effort into me. So after doing the Tarwin Park training course, we bought our own little farm. We bought 100 acres in Lagan, New South Wales. We're 45 minutes inland from Gulhane, near Crookwell, 10 minutes from Crookwell. The house sits at 980 metres above sea level, hence the snow. This is a photo of Stuart that I remind him I've been leaning on him to adopt me, but he says I'm too risky, so I'll just keep him as a mate and a mentor. So the five pillars of natural sequence farming is slow the flow, let all plants grow, careful where the animals go, filtration is a must know, return to the top to recycle the lot. So these 5 pillars, they're all part of the jobs that I've been working on, and that's the basis of natural sequence farming, is those 5 pillars. This is Dr. Pran's property. So these are tools that I use before or when I go to a farm to assess it. So what I'm looking at here is there's 10 metres elevation change in these lines. So I use these lines to work out where we should put structures in, where there's fertility, where we can move water. That's a river system there. No, not Gulhane, no. This is the other tool that I use. So this is a laser level. This shoots a beam out to my receiver, that will run 400 metres out this way, and it'll run 400 metres out the opposite way. So as I walk the paddock, I've chosen a spot where there's a suitable spot to put a contour. So I walk around with a laser level, and it's got set to being at 20 mil on point. So once it starts to beep and it makes the right noise, I put a mark on the ground. And when I'm in the excavator and I'm working, they're the marks that I'm consistently looking for as I'm working, because you think you can try to do it by eye. I've been doing this for years, and I still sit in the machine and I look at the marks and I go, fuck, I hope that's calibrated, because that looks like it's going downhill. But you trust the gear. It's a few $1,000 laser level, and it's never let me down since. That's at Little Plains. It's one of Charlie Arnott's blocks. This is another tool that I use. So what I'm showing you here just quickly is that I put the dirt down at the bottom, and then each time I'm digging, I'm taking the grass and I'm laying the grass back along the top. When there's no vegetation, that's not possible, but by laying that grass across the top, it means after a couple of rain events, your contour starts to vegetate and it all holds back together. So this is Talaganda. This is John's farm. Man up the back there, throw your arm up. He's been doing this work with me, hand in hand, running around with a laser level, going getting compost, doing the whole lot. It's near Braidwood, New South Wales. So this is what I started with at John's place. The first time I got there, I'm just going to take this speaker off because I think this is something that we need to hear.
Should be the softest, fertile soil on the block, as hard as a cat's head.
So that's on a floodplain after the wettest 2 or 3 years we'd had since the 50s. It's not wet, and it's like concrete. It's dead. There's no microbes, no worms, nothing's going on. Sorry about some of these videos. A lot of these videos were just hanging out of the side of an excavator, or they were just Instagram stories that I never thought I'd be up here talking about, travelling around the country, building this sort of stuff. So this is the same floodplain, just looking top to bottom before we've done any work. John's put a couple of little structures in there with some sticks and stuff, but nothing too crazy. This is a pond that I've put in. Now the reason I put this pond in, we need to get water back out onto this floodplain. This is an erosion gully. You can see the erosion here. And what's happening with this erosion, it's like a microbial network cutting an A4 sheet of paper and putting half of the A4 sheet of paper over there and the other half over here, and wondering why those microbes don't talk to each other anymore. It's because of those edges there, that there's no fertility and there's no hydrology linking it all together anymore. So now putting this pond in, the messages from the microbes over here can now talk over here and spread all back out to here and spread water laterally out across the landscape. So that's the same spot. That's that pond that I was just talking about then. So what we've got here is, by backing this section up here, it's now pushed water about 160 metres all the way back up to there. It took me 4 hours to put that in there. It's not, not a lot of effort. Now this water here, once that's full, it comes out this spillway and starts to rehydrate this floodplain. Now what we've got up here, we've got a bit of a Y in the creek, so when we want to put some water into this contour is what rehydrates the whole top section of the floodplain. There's a worm farm here and a worm farm there, and we've got another compost heap. So we have a spillway here that's pushing water down through the worm farm, pushing the microbes and all the fertility back out onto the floodplain. Now when this floodplain is absolutely soaked and it's had enough water, John comes up in the corner, he goes down there most weekends, comes up in here, stacks a half a dozen rocks, which pushes the water back down into here and starts filling these ponds, and it comes back down into here and floods the bottom part of the floodplain. We do have some other ponds up here that are fed by a 50mm bit of polypipe from the creek. So there's a pond up the back here we can't see, which feeds this pond, and then that feeds this pond, and once it's all full, pushes back out through here. This work here to this video I'm about to show you is 6 months difference. That's the same floodplain. Bit of biodynamic preps on some compost piles, those worm farms, roadkill, blackberry, whatever we could find, weather damaged hay put in piles. When you get the hydrology right, that's how quick this can happen. It doesn't always react this fast, but it doesn't always react this fast, but being a floodplain and a fertile floodplain, it was just missing a bit of biology and it was missing the hydrology. And you can hear the frogs. Like, when we were working down there, we were working till dark. You didn't hear any frogs. And in a matter of 6 months, they're back. So this is a contour that's on the floodplain. That's the contour that I was talking about that ran around the back. This is that contour. When I dug it, it was dirt. There was no vegetation. Little bit of rain, fixed the hydrology, bit of biodynamic preps, a bit of compost, and look what the landscape's done. No chemicals. Something that I've learnt with this work, it's amazing what you can learn when you take your shoes off and you walk around, and you can walk on a farmer's paddock and he might tell you you're rotationally grazed. You can feel it under your feet, you can feel things are locked up, you can feel it's tight, and then you can walk into another paddock or a neighbour's paddock and it feels spongy. You can tell the management differences. Just sometimes we've got to take the blinkers off, take our shoes off, piss your phone off and just walk around and just feel things and start to look at things and just start to slow down, get back in tune. So this is Hannah Minnow, this is Charlie's home block. Some of these slides are Little Plains. He's owned Little Plains for about 15 years. The better country is Hannah Minnow in the slides, and the erosion is Little Plains. So this doesn't look like much. This is a little bit of erosion. It's probably taken a couple of years to get to that. The cattle are quite curious with what I'm up to there. You can see the water bottle there. It's probably a foot and a half. You wouldn't think it's much. You wouldn't think you need to do anything about it. You can just leave it. Well, this turns into this. That's what happens when you don't manage those little cuts. They turn into this. Now this hasn't happened overnight, and this isn't Charlie's management. He's bought the property. Sheep have been on there for 100 years, set stocked, droughts, floods. So this has got nothing to do with Charlie's management, but he's putting the effort in and paying me to rectify this. So this is the erosion here and some of the work that I've been putting in. I'll pause a couple of times to start pointing some stuff out that might not be clear to everybody. So what we've got here is we've got a pond here. So just like at John's place where we had a pond at the bottom, that pond will eventually fill up with water. Set it with a laser level. It'll eventually spill water out to here. Now I've got another pond here. This water here will back up all the way to there. This pond here, I know it's hard to see, but that then backs this water up to this tree, and I've got another pond. And what we're doing is we've got water touching water. The microbial network can spread. The fertility that's coming from up the top here, when we start dropping some weather damaged bales of hay, chicken shit, like whatever we can get to start to accelerate the biological process and the fertility. So as we come further up, there's a pond to a pond. You can see the pond here. There's another pond that's up over here. There's another pond. So what we're having is this water up in this catchment instead of it just rushing down, it's going pond to pond to pond to pond. We're slowing the flow, we're slowing the intensity down. So what we've got here is, I've just put this little bank in here just to stall this water up a little bit, spill it out this corner where there's a bit of vegetation, because we've lost a lot of vegetation and it's cut down to bedrock there. So that's just a little pond, stall this water up just a little bit. But with this contour here, when you have 100 mil of rain in 24 hours, this contour has to fill, and there's no spillways in this contour until I get out over the corner over here, meaning that the water that leaches through this will be so slow and so subtle that we're not going to cause any more erosion. We're going to start to repair it. Now this erosion's been fenced off for 15 years, and it's got so bad that on the opposite side over here, the erosion went all the way across and it swallowed the fence. They had to move the fence 40 metres away. So sometimes just fencing it off, it doesn't fix it. When the damage is done and it's really bad, sometimes we've got to step in and do something. So this will show the contour runs, and this is level. All of this, everything that I'm building is dead level. It's within 10 or 20 mil. Even if I put a contour in 15 kilometres long, it wouldn't be any more than that far out. If you wanted to and you had the right landscape, you could move this water 100 kilometres, 200 kilometres. You can see a bit of water. I had 20 mil of rain overnight when I was building it. It's quite light country. Would have been good in its day, but before white fellas come in and flogged it to death. Nah, not at the moment. So there'll be little puddles. So 20 mil of rain will put a little bit of water in it, and what we can see here is this is a natural sequence. That this is sort of stuff that I'm looking at when I fly a drone over your farm. That's rushes. That's telling me that they got wet feet, that there's water sitting there. There's a little bit of loss of oxygen, that the rushes can outcompete the grass. So when I'm walking around and I'm thinking, where am I going to put a contour? They're a telltale sign of where I'm going to put a contour, because there's water there and we want to spread that water further out of the landscape. The next stage with that erosion is to bring some weather damaged hay and just start dropping it in. We won't spread it out, just cut the baling twine off and just leave it there. And you'll find after about 12 months there'll be worms that'll come back. You don't need to put the worms there. They're there, they've just gone so far down in the ground that they're non-existent to the human eye, or when you're digging with the excavator, you're only 1.5 foot down, you don't see any of them. I dug there for 3 days and didn't see one worm. So this is at Hanamino. This section here is some erosion that we need to put some ponds in later on, but this whole catchment here used to run down here, and it used to flood Charlie's house and cause a massive issues down here. So what I've done is I've put a pond in, and we're going to link this up to the main water source that Charlie uses for stock water. So now this whole catchment here never helped to fill this dam. From about there, it would run down here. So that contour now and that pond fills this dam. When this dam's full, it can start to push the water back out of this contour. But the benefit we have now, this is all catchment. Everywhere here will fill this dam, all of that. So now having a catchment that was 100 acres, it's 400 or 500 acres. And when it's water that you use to feed for your livestock, it's pretty important that you keep it full. So now this is full of water, so that dam is full, and it's now starting to push this water back out of the contour, and it'll start to spill out these spillways to help with production to grow more grass. Because most of the farmers that I'm working for, they want more production, they want to grow more grass. They've got to justify paying me to do this sort of work, and on average we're getting a 25% production increase. So if you're turning 1,000 steers off a year and you can turn off another 250, that might be the difference between making money or not. Has anyone been to Hanamino here? You've been here? Alright, so what you'll notice now, the water from the shearing shed when those tanks are full end up in this contour, and they'll fill that dam. And that's 1.5 k's away from where that dam is. So it comes down here, runs down this gully, fills this pond up. Once that pond's full, a bit of water will go that way, and the water will start making its way back to the dam. And even the water off that whole road now goes underneath the pipe here and comes into this contour, and it helps fill that dam. We've got to utilise every drop of rain that we're getting on our farms. You know, the extremes with the drought now, you get 20 mil of rain, you want to utilise that 20 mil of rain. So this is looking back up at the shearing shed that I'm talking about. So the tanks up there, when they're full, they end up filling that dam 1.5 k's away on the other side of the hill. So this is showing what I'm talking about when the contour starts to fill, and then it pushes the water into the dam, and then when the dam's full, it pushes it back out the contour. I started building this contour, went and had lunch, and we had about 25 mil of rain. This is showing what I mean, how subtly the water starts to fill the dam. You can see the colour, the difference in the colour in the water. So this is water, it was already in the dam, it's not too murky, but obviously because I've just been excavating it, it's a bit silty. And now you can see that after that rain event, you can see the contour's full, and now it's starting to push the water back into the dam to fill the dam. And when the dam's full, it goes back out the other way, back out in your paddock. This is a contour at Charlie's I built a few years ago. Once they're vegetated, they just become a part of the landscape. Don't have to do anything with it. Preferably when I put them in, if you can keep the stock off them for a few months, get the grass kick-started and get the process happening, that's ideal. Sometimes I put contours through the whole part of the farm and you don't have an option. Well, you put the cattle in, or you put a hot wire in the base of this and just try to keep them from walking on the bank and squashing the bank down. This is Green Hills, Central West. It's at Kalula. So what we've got here is, this is a main dam at Matt's place. He wants to make this dam link to this dam, and he wants a big island in the middle here so he can have wetland birds come back and start laying without being eaten by the foxes. So what we have here, that's a 23-tonne excavator, and I've been at this for a week. It doesn't look like much, but we shifted a lot of earth. Before we had rain, I dug about 2 foot out of this whole area. We had a big part of erosion there that was starting to cut the back of the bank out. So we excavated all this and trucked it around the back of here and tipped it and fixed that erosion, and then I've kept digging the edges out. And the reason that I've dug it so deep and so wide is that in this next slide I'll show you why we've done this. So that's it. It's not at capacity. It's probably got another 80 centimetres to go. You can see the ring of the old dam there. I've made that 3 metres there, and at a minimum 1.2 metres, so that when the Kambunji grows here, the Kambunji doesn't like to grow in more than about 1.2 metres of water. So that'll never vegetate enough that the foxes can walk across the Kambunji and go and eat the wetland birds or the birds that are trying to nest there. So what we have is weather damaged hay again, trees planted all over it, and that'll just be a little oasis that the birds can go and nest and not be eaten by the foxes or the wild cats. So then after it's full, it pushes out this contour here. I've got a spillway here and a spillway here to fill these ponds. Now these spillways that I've put in all along here, once the dam's full, is same as this here. So in heavy rain, some of your water comes around the back and the other comes out these spillways, fills the pond I put in, then that pond fills this pond, that pond fills this pond. And what I've done with this section here, I used gabion baskets. You've seen the wire baskets on the side of the highway full of rocks. We've used these in the back of here and just filled it with rocks and hay, so that'll vegetate and it'll just leak. So it means in a massive rain event that the water in here, it eventually ends up in the river. It just might take a week to get there. And this is the same river that links to Bathurst that's helping for the flooding when they had the last flood. This is where the water's coming from, this catchment. Yeah. Yeah, that's a pretty bold statement, but I'll show you a contour in a minute that if every 1,000 acre property in that catchment had a 2.5 kilometre contour, there's 2.5 million litres in that contour. That's 2.5 million tonnes that were slowing from rushing down the river. Common sense would say if you had 200 of those contours, do you think you'd have a flood in Bathurst? Yeah, we'd be jumping on Noah's Ark's boat if you did after you put those contours in. So look, it is a big statement, but we could reduce it. You wouldn't have, like in Lismore, when the flood just roared up and 2 hours later it dropped. You'd still have a flood. What you would notice is the flood would just incrementally come up. Once all the contours and all the ponds and everything are full and they start to spill out, the flood water will rise. It just doesn't happen in 2 hours. So this is the contour that I was talking about. It's 2.5 kilometres long. And I've modified, there's an old quarry here. All the water from this quarry was rushing down the road and destroying the road. So I've tapped into that quarry, put this water into Matt's place. Now that quarry runs this water all the way out over this, rehydrates a quarter of his farm. This is all level, remember? Everything's built level. Goes all the way around, links all the way up here, and goes out of the screen. It's 2.5 kilometres long, 2.5 million litres of water that was rushing down here, down the quarry, causing issues. Now put it out on his paddocks to grow a bit of grass for him. Now this is the same again. This is on the opposite side of the quarry. That's the road that links into it. Water runs in here, runs off the road, causing erosion all through here. So we've got some stacks of hay through there to get a bit of biology, get some grasses starting to grow. So instead of this water now rushing all the way down here, there's a bit of erosion down here. It ends up going over the top of the road. We've put this water into this contour and now starting to rehydrate his paddock from water that was giving him grief in the corner of the paddock. So this is something similar to John's with putting the pond in the erosion gully. We put a new dam in. There's not a very big catchment where this is. So now you put a pond in. This dam's never run dry, so there's no issues with pinching a bit of water from it. This pond fills, runs down the contour, fills the dam. This spillway here is the same as this spillway, is the same as this spillway. So once it's all full, spills water back into that dam, runs a bit of water down the paddock, and you can start to see the stream where the water's starting to run down there and the change in the colour in the grass. This is Levenvale, which is Bellow Beath on the mid-north coast. High rainfall, this is before we started. Now, contours are quite important in this high rainfall country. They're certified organic and they're rotationally grazing their cattle. If they get 200 mil of rain, what do you think happens to the cow shit up the top of the hill there? Washes down into the river. So that's the contours put in here. So that's a gully there that gets massive amounts of water causing issues here. The dam blew out, so the dam had to be fixed. So what we've done is contour in here, and the spillways are on the ridges. And the reason they're on the ridges, your ridge is shaped like that, gullies like that. So when you've got a ridge and you put the water out over a ridge, it subtly goes this way and it goes that way and it goes that way, and it's spreading out really slowly. So what I've done here is you've got these gullies, and now I've got spillways here. So the water that was rushing down the gully is now hydrating this area now. This contour here is the same height as this. Unfortunately, they don't own this block of land, so we just had to skip that bit out. This here is terra firma organic chicken shit. So being certified organic, I can't bring straw in, nothing that's not certified organic. So it's an expensive way to put the fertility up the top, but it is what it is. That's, they're certified organic, so they've got to comply. Same thing again, contour, bit of a gully picking the water up, another gully pond, spilling it on a ridge, spilling it on a ridge, spilling it on a ridge, spilling it on a ridge the whole way. It's the same height all the way around. Once we finish there, it'll actually link past the little Airbnb, and it'll come all the way back around and link all the way back around here and come back up over here. It'll link the whole lot together. So this here is a pond. It's an old dairy. That pipe there, that's all the runoff from the dairy, and then it runs into there, goes out that pipe, 200 metres down there, it goes straight in the river. That's a contour we put in, and I've got a little video here that I'll explain what I built.
What we've got here is, that was a pond there that had previously been catching all the shit and piss out of the dairy for about 100 years before Georgie and Sam purchased the property. So what we've done is we've broken the bank there, we've put a contour in here, we've got one spillway here on Datum. You can see the water now just starting to push out our spillway, and see how it's pushing out evenly. That's the purpose of using the laser level and having your spillways smack bang on level. So what this is going to do now is spill water from here, the next spillway there, it'll spill out there, and I have a spillway at the end. So the benefit of this now is we can now get into this pond, get the tractor in there. There's a green tractor trailer there. We're going to dig this whole pond out, and we're going to put all that fertility back up at the top of the hill and let the system recycle it. What do you think, Banksia?
So that's a smart way of using the fertility on your property. The terra firma pellets are thousands of dollars a tonne, like very expensive. So now we're going to use that build-up of manure that's from the dairy for 100 years. We're actually going to dig that material up, take it all the way up to the top of the hill, and let the system recycle it again and start to grow more grass from. So this contour here, this was a real eye-opener for me. I'm not a real fan of plantations, even though I was an arborist for 10 years, but something I noticed with this contour that it blew my brain. When I was digging through here, I've never seen so many worms in my life. I mean, every scoop, there was thousands. It was insane. And for hours, I'm racking my brain and I'm thinking, what's different? Certified organic. This plantation's 30 years old. It hasn't had chemical use or anything for 30 years. The biology in there hasn't been touched for 30 years. When they've gone certified organic 5 or 6 years ago, that biology has just started working its way down, and now the worms that are in this paddock, there must have been 500 of these little wetland birds. Every time I was digging and I was putting dirt down, I was nearly squashing them, that they were just fighting for the worms. And I've never seen anything even close to that, and that's a perfect example of how important vegetation is, even if it's a monoculture of eucalypts. This is Larapinta in Molong. This is what we started with. This creek is trickling. There's not much water pushing through, but look, there's a little bit. That might be, at the best, a foot deep. So this is a structure that I put in. I put an angle on the structure so the water's flowing down like that, and it's hitting the rocks on an angle like that. That wouldn't even be hip height. All these rocks are from a rock picker 50 years ago. They were just in the paddock. It's cheaper to use what's on the farm than cart it in. So a small little structure like that. The reason I don't make it very high is I keep the fisheries off my back. That it's a stock crossing, and it's under 30 centimetres tall. So you got to learn to play the game. That's after we put that structure in. So now we have water backed up. You can see how wide the water is now. Same tree in the background. That water pushes 100 odd metres around the back. And what I've done a similar thing about 150 metres down. So what we're doing is we're pushing the water up, higher up in the floodplain, that now this water will start to move laterally with capillary attraction with backing up the floodplain. Now this would have done this without us, but for years of overgrazing, set stocking, see all this here, cattle and sheep walking in and out. Every time there's a flood, it only gets a little bit worse. Years ago there would have been phragmites and combungi that would have slowed this system up enough that the water would have been backed up to here, but years and years of overgrazing and stock walking up and down the creek, it's down here now. So this is that crossing that I was just talking about. There it is there. You can see how far this has backed that water up from that first photo that was, that deep to maybe a foot. There's sections here that'd be 1.5 meters deep. Now you've got capillary attraction through your landscape where your water starts to spread this way. Has anyone seen a bucket of water and you put a newspaper in it and people say you can't make water run uphill? If you put that newspaper in a bucket of water and you leave it for 24 hours, the whole newspaper's wet. What do you think happens when the floodplain for 6 months or 12 months is 1.5 meters, the creek is 1.5 meters deeper? That water's now gone 500, 600, a kilometre sideways through capillary attraction. So this here is an area that I will say fencing off. In that last slide you could see where the sheep and cattle had been walking on the edge and the damage. 2 years ago they put this fence in. There's a fence that runs along there where those trees are. Look what's grown in 2 years. Careful where the animals go. That situation, just fencing it off at Charlie's at Little Plains, it's so far down the line, you pass the point of just throwing a fence around it. So this is same property. We've got a dam here that was catching a bit of water off the road, all running down the back of here, runs down the side of the driveway, floods the shearing shed. They run merinos. If you're trying to shear sheep and they're standing in mud, makes it hard for the shearer and the fleece is worth less money. So what we've done here is fixed the back of this bank, dug this corner out and I dug that corner out, fixed the bank so it's not flowing over the back. We put 3 ponds in. So this contour now, this is all catchment. All the rain that falls here will help fill that dam. They use that dam for stock water. Once that contour is full and the dam's full, the spillways start to activate. This pond fills, spills into the next pond, spills into the next pond, spills into the dam, comes around the corner here, goes down the contour with a couple of spillways that, look, you'd need 200 mil of rain now to flood their shearing shed. Now we put these in, slow the flow, slow the fertility loss, helping the grass grow. It's even greener. It's probably 4 months after I've put this in, and this is in winter, and I've already noticed a difference with it's a bit greener on the property. And see these natural sequences? Rushes, rushes, rushes. It just tells me that water's moving down, and they're little steps in the landscape where the water's moving down and it's just a little bit of a kick, and that's enough for the water just to settle there a little bit, pinch a bit of the oxygen and allow these rushes to start to grow. So if I was to put another contour in, I'd put another one up here above the rushes. It's not a very complex process. So here's some chicken poo that we brought in. Reason I use chicken poo on this job, it's mow long, there's shedded birds and free range birds 15 k's down the road. We've got to use what's bang for buck, what's cost effective. So we brought 300 cubic metres of this in. We got the truck in dry weather as high up on the landscape as we could, tip these piles off. We'll leave these piles, they've been sprayed with a biodynamic prep. We won't spread this out of a fertiliser spreader. If you spread that 300 cubic metres out of the back of a fertiliser spreader, you lose about 50% of it back to the atmosphere. Whereas if you leave it in this pile like this, the water and the land, it'll spread the fertility out of this for the next 10 years, 15 years. let Mother Nature do the work. This might not look like much, but I'll explain the details in it. This here is predominantly eucalypts. The elevation difference from here down to here is about 35 metres. It's almost all rocks and predominantly eucalypts. So what we have here now is you've got this nice green grass area. That's telling me that all the tannins and the salts and everything from here that's leaching out, it's going underneath this area here. And where do you think it's popping back up again? Where the rushes are. It's just a natural sequence in the landscape. When we learn to take our blinkers off and start to look for things, this is the things that we're looking for. And they're not just a little rush like that. They're about that high, and they're spiky, and they're unedible. They're pretty gnarly. It got to the point now where we've got to put a contour in here, and we're going to have to bring a big tractor with a mulching head on it and mulch it down because they've got out of control. Mulgranai Creek. Did I get it right, Jackie? This is Jackie's property. She's put a lot of faith in me, Jackie. When I got to the property, there was still a bit of chemical use. She was all ears. She listened to me, and she's backed me 100%. Ben over here is working with me. Put your hand up, Ben. Helping Jackie with the grazing. So we're going to turn this property around from having previous chemical use to running the whole joint without any chemicals. Thank you, Jackie. So this is what we started with. So same again, large catchment. This dam wasn't handling it. We had big bits of erosion around each corner. This was starting to get eroded. So put a contour out here, helping make this catchment as well. But now when that's full, and this is full here, we're starting to spread the water out slowly. Same process. Helping with production, growing more grass, grow more grass, you can run more cattle and hopefully be a profitable farmer. So with this property, needed a bit of fertility. So we've done a little bit different this time. We could get these weather damaged bales of hay. They're 450 kilos and they were $25. So we ran over to Dunedoo and picked up 2 truckloads. One was 41 bales and one was 40. So now we're going to start putting these bales higher up in the landscape to start making some fertility on farm. And the reason that I like to make the fertility on farm, yes, you can buy stuff in a bottle and it has a good success rate. But when you can make it up on a ridge up here, that's where the truck is. So we've got some chicken shit there to mix with the hay, so you've got a good carbon and nitrogen ratio with the hay. So now Ben's jumped in the tractor, ran all those bales up here. We've got bales up here, we've got bales at the water tank, and we've got bales there. Now we're going to put a contour the whole way around here and link this whole hill, that all that fertility and the straw and the chicken shit for the next 20 years will slowly rehydrate and put fertility over this area without using any spray rigs or anything fancy. We're just using the rain that falls from the sky and the hay and the chicken shit that we've mixed together. It's not very technical. He's been in the tractor bringing the bales up. I will say this is some steep, gnarly country, and the blokes that run tractors around this country got bigger balls than me. So here we have, these are the repair plants. When chemicals are used, the repair plants come out. So don't just go out there with more chemicals and spray them again. They're just a messenger. They're going to belt you over the head eventually and tell you what's going on and what's wrong. So we let these plants come in and they'll start to repair the soil. When they've done their job, they'll disappear and the more palatable plants will come up. And we'll accelerate this with the compost piles that are leaching down onto this area. After 6 or 12 months with that fertility leaching down towards them, they won't like that and they'll eventually move on. Got some thistles. This is the KBD Valley. So this is a crossing that Stuart and I put in. So what we've got here is the water's coming from up this way. We've used timbers from trees that have fallen down. I've got a pipe that runs through the middle here. Why it's in a wing a bit like this is that this here is 20 centimetres lower than these timbers. These timbers here run up 20 centimetres, so it's on a bit of an angle like that. Water's coming down from here. This doesn't look like much, but it's about 150 metres downstream from where I put that crossing. And the reason I put these rocks in this order, they're from the size of about a wheelbarrow to a half a Toyota Corolla. So what happens is the water, it hits that rock, creates a bit of turbulence and hits this rock, that hits this rock, that hits this rock and that rock, and it just goes left to right, left to right. That slowdown of that water, just a little bit now when there's not a lot of a flow, in a flood or a high rainfall event, that slows that water down just enough that the exit water at this crossing that I'll show you in a minute, it doesn't wash it away. I'd love to talk to some engineers and some council people how they build their bridges, because I'll show you 100 mil of rain in the Kapiti Valley over the top of a crossing that was built less than 24 hours ago. So that's after 100 mil of rain. So you can see the crossings here. We just finished with the machines. We finished building this in the dark. A lot of water. See all the turbulence there? We've stacked rows and rows of rocks and we've put them in an order that creates this washing machine effect and creates this turbulence. This water here is leaving slower than what it came down from here. The exit water that hits your structure is what does the damage. You want to slow the water that's leaving, not the water that's arriving. That's 48 hours after the rain event, and this was a real eye-opener for me. When I was walking around with the angle of the crossing, so I'll explain this. So the water's coming from this way and your crossing's like that. When you've got stones here, the water's coming down, and because you've got it on an angle, the water's actually forcing the stones down into the crossing. So I'll show you a photo of 20 mil road base that we put on that crossing that's had over a metre rain over it for 48 hours. I'll show you what's left of the 20 mil aggregate that we put down on this crossing. You'd think it'd wash it all away, wouldn't you? That's after that rain event. That's 20 mil aggregate. There's our gabion stones, sands underneath, gabion, top capped it with that. It's all to do with the way those timbers are, the angle that we put the pipe in, the rocks in the corner here. Has anyone been to a council crossing out in the sticks and it's concrete and you get to the crossing but all the material in front of the crossing's washed away? Well, that's because the turbulence, once this backs up and comes out into these corners, it starts this circular effect. That's what chews it away and takes it away. That's why we have this wing of rocks here, and the way they're stacked in order with big, small, it stops that turbulent effect, like that spinning, and just creates the washing machine effect. Not very technical. How many people have, if they're farmers, have put crossings in, put aggregate in, put it level, the first flood washes it all away. And you just go and do it all again. The contractor loves it. Stuart, Andrews and Megan. Stuart's put a lot of effort into me. He's like a father figure to me. I wouldn't be standing here today without Stuart and Megan, so I'd like to thank him. He's put a lot of effort into me. Thanks, mate. That's it. Thank you. Sorry, a bit emotional, but thank you. Yeah, has anyone got any questions?
You mentioned, or you showed us dehydration, where the soil is like concrete. And from everything I understand, and a trouble that I have in my body is dehydration. What are the symbiotic or metaphysical lessons that we can learn from doing this? that we can adopt into our living liquid earth filled by sunshine on the mitochondrial membrane with like water, living water in our bodies.
So what you've got here, that's your main arteries, and in here there's kidneys, there's wetland plants. It's not too far off the human body that little creeks are your little veins, the rivers are your arteries, the wetlands that have got the phragmites and kabungi, they're your kidneys. We need them to process what's leaching off the landscape. Why do we think we're having problems in the Great Barrier Reef? It's leaching from the farmlands. They've drained all that area that's close to the ocean that used to be floodplains. Years ago, all that fertility was processed in the floodplain. It didn't end up in the ocean. We went and drained the floodplains. Yeah.
Stuart, I've got a question for you, mate. Epic presentation. I really, really enjoyed that. Two questions. One, where do you transport your excavator with you, or do you access an excavator at each job?
It depends really. So at Jackie's place, she's got a 20 tonner and a D6 dozer, so I've done some of the work for her on her machine. The last lot of contouring work there, we needed a smaller machine. The 20 tonner was overkill, so I carted one of my machines. But the job at Bellingen, we did that with high gear out of Coffs Harbour, 14 tonner, and then finished it with an 8 tonner. We're about to go to Dalby, Queensland and do a 15 kilometre contour in Dalby. I'll pick Stuart Andrews' dozer up and an excavator and we'll cart that out there. So it all depends really. You can do some of this stuff without a machine, like those rocks from the rock picker. There's nothing stopping anyone here if you had a farm and had a little creek through it. When you're driving around in the side-by-side, just start picking the rocks up and start throwing them in the creek. You could throw them in and make them that high and you'll start to see a difference. Not everything needs to be done with a machine, but predominantly the work I'm doing is done with an excavator or a dozer.
Yeah, great. And the second question was the lifespan of these contours. And obviously it's going to be a function of the stocking density in the paddock, I'm presuming.
They'll last forever.
They last for, so you don't need to renew them or they need to be redug?
Well, what you would do eventually, so see how I was mentioning about the spillways. If you left a contour for 12 months and it was fully vegetated like your front lawn, when there's a spillway where we've been letting water out, you could go and roll some weather damaged hay there and bring that spillway up by say 50 mil. Now 50 mil, it doesn't sound like much, but if your contour is 2.5 kilometres long and you just brought it up by 50 mil, you're managing a lot more water. We're not trying to control anything, we're just trying to manage it. Yeah, so you look after your contours and you don't let stock overgraze it, they'll last forever.
Thanks.
Great presentation.
Thank you.
You touched on the fisheries and how you get around them. And did any of the others, waters, any other people interfering, or can you get out and do this on your own?
You better to ask for forgiveness. Look, don't take the piss. You know, if you've got a big healthy creek and you go and get a 20 tonner in and stack a heap of rocks in it and don't put a pipe in it and start pinching water by pumping it out and stuff, you're going to get in trouble. What they want to see is that putting those rocks in, the water is only, say, 60 centimetres from each other because I've put another structure further down. The fish will actually get up that. Once the flow rises a bit, the fish will still move around. There's no fish in there. There's not been fish in that creek for years, but you got to treat it like there's fish in there. The next thing you could do is you could just put a pipe in there so the fish can go through the pipe. Keeping the structures like that and keeping them on an angle like that the water's running into it and pressing your stones back down to the ground and not taking them away, you should get away with it.
Dams? Do you have to get approved for dams?
It depends how big your dam's going to be. So if you've got 100 acres, if you own this 100 acres around here and down where that road is, you put a 30 metre wall in and you dam this whole catchment, your land to water ratio would be out, and yes, you'd get in some trouble. So, any other questions?
That's the use of the word ponds. I loved it.
And ponds. I don't build dams. I build ponds. Or leaky weirs, or.
I had some of Peter's work done at home a couple of years ago with the excavator driver or operator. Sorry, he did them. I said to him, "Are they level?" Because I stipulated, you would have been through this a lot. Stipulated they need to be level. They need to be level. I said, "Are they level?" And he goes, "They're roughly level." And I'm like, "Oh, doesn't cut it." So would I be able to, with what you were saying with the hay, modify those areas that are a bit lower?
You'd have to check and see how far out. So when I'm working, I've got the laser level and I've got a mark here, and I'm working along with the excavator and there's a mark here. I'm digging right to the edge here. I want to keep the pink mark. I'm conscious of how high the bank is, but my level is the actual mark on the earth, not on the top of the bank. So I'm not so worried about the bank. Yes, I want the bank pretty close to the same height, but I'm following the level, the marks on the ground. So if you're over 500 metres and you're 600 mil out at the top of your bank, look, you could come back through and excavate a bit and put a bit of material up. Depends how long the contour is. I've had one job where I let the client help the laser level, and let's just say I was digging and I was having one of those moments going, this is not level. I'm actually convinced that I'm going downhill. And I continued the day, and then we're sitting having dinner, and they were telling me about when they had the laser level and they were walking around and they couldn't work out why it wasn't beeping. And I said, "Oh, but you had the laser level on the ground while it was beeping." And they said, "Oh no, we just walked around till like we could hear it." So let's say I just spent the next day, I just backfilled the whole lot and started again. I did actually start to measure it, and I thought I can make it deeper and fix the back of the bank. But by the time I stuffed around with that, you're better off just, if it was 3 kilometres long and it was 100 mil out, we could fix it.
Okay.
If it was 3 kilometres long and it was 3 metres out, you got to drain.
And one more question: what about driving over? Do you put? Because that's what I find my biggest thing. I've got these contours everywhere. I want to access something, and I'm like, culvert. Like, do you put a pipe in?
Nah. So what I do is, I'll get a bit technical with this stuff here. So I'll make a spillway at, say, plus 150. So what this means is all the other spillways are level, but this spillway is 150 mil higher. So for that to have water come out of it, all the other spillways already have 150 mil of water roaring out of them. I make them as your crossings. So that will be a bit of give when you're driving over with a vehicle and it starts to get a bit of a rut in it. You got 150 mil tolerance before you're making it into a drain.
Oh, that's awesome.
And when I do that, I do my normal spillways, I'll make them 10 metres wide, but the vehicular ones, I'll make them this wide. So when you're driving along the contour and there's big ones, and then you see one like this for a cruiser, and then I've battered the backside, that's the one to drive over. Yeah. If you start putting pipes in, you spend a fortune.
Yeah.
And I won't get much done. Any other questions?
Yeah, I have one. Sorry, just with erosion happening behind the dam. So it's a great dam, but then there's a natural fall. Obviously, the natural fall's been dammed. So now it's starting to erode behind the dam. You said something that I didn't quite get. So how do I fix the erosion behind the dam from the dam runoff?
Slow the exit water.
Right.
So the water that's actually leaving your dam. You've got your dam, and then you've got the corner of it. Your water's just going out of the back of the dam and straight down. So that's why when I was building those ponds and dams, I put the contours out the side, and I actually had the spillways, say 30 or 40 metres away from your dam bank, so it doesn't ever wash your back of your dam bank away. The problem that you're talking about, almost every farm I go to has the same thing. Get my details and send me some photos, and I'll steer you in the right direction.
Awesome.
And that's the same for anyone else here. If you've got some questions, Blackbird and Beast on Instagram, or hit me up and get my number. I'll be happy to help steer anyone in the right direction in the room.
Just with those contours, to the uneducated eye, it almost looks like a landslip. Do you ever have people complaining that you're putting these on the hill, and do they ever collapse? Because do you have to get it right so they don't Water doesn't come along and sort of slide this.
Very,
slides down.
very rarely. If you build it properly and you put enough spillways in, the spillways are the fail-safe. If I built them like a bank the whole way along and there was no spillway, 90% of them have failed because you get 20 mil of rain, the whole thing would fill up with water and push against the bank and it'd just blow the back of the bank out. So those spillways, they're your fail-safe. And if you're digging, you're putting the vegetation back on the top, first spring rolls around, a few months into it, it'll be vegetated. 12 months down the track, if you haven't had stock on it, like Jackie's got a contour where she hot-wired both sides, and it might have been built 6 months ago. You can barely see it. You know, it's got grass a foot high growing on it. Anyone else?
Yeah, hey Stuart. I'm not from a farming background, so I'm just trying to get my head around this spatially. When you say the contour and it's level, so if this is the hill, like along here,
yeah,
the contour is like level dead in the middle here, for example. Is
yeah.
that what you mean?
Yeah. So if I'm looking, I'm in the excavator now, and I'm looking downhill, and I've got my marks on the ground like a bow, like the chairs here. I'm digging the earth from there, and I've got my level mark, and I'm digging a chunk out here, and I'm laying it there. I'm digging a chunk out here, and I'm laying it there. So what's level is that mark that's on the grass that I'm watching the whole time that I'm moving.
And
behind the mark. I always want to continue to see the mark. So as I'm working along, you know you're continuing on level. And there's times where it bows around and wiggles, and you just got to trust the laser level.
so that means that as it's coming down the mountain, then it's filling up here, so that it slows down.
Yeah, so your fertility and your water that's up the hill, it started working its way down the hill. Instead of rushing all the way down the bottom of the hill and going to the river, it hits this contour like a set of lungs, fills up like a set of lungs, and then slowly just dissipates. And that slow release of the water, and with the contour, because you've put dirt on top of the grass, it actually goes in the subsoil, so it's right underneath where the roots are, so you get less evaporation, and you're making it easier for the grass to grow because you're putting the water at its roots.
Yeah, thank you.
Maybe I'll just ask you maybe a final question, Stuart. You mentioned in your talk that you could see, your farmers see maybe around a 25% increase in stocking capacity after they implement these techniques. And it really called to mind a question that we had yesterday, which is a common one with regard to the consumption of animal foods and animal protein, which is, you know, how can we feed the world? And what it prompted in my mind is that what do you think the carrying capacity of Australia, of agricultural land around the world could be? One, if we integrated more regenerative type grazing practices, but two, on top of that, implemented these type of contouring and natural sequence farming methods.
I don't know if I'd say that you could raise the stocking capacity, but I think we could stop being sustainable and actually be better and be regenerative, and maybe run the stock numbers that we're running, but not depleting the country and pouring super and spraying stuff out and putting crops in over and over. I think we could run the stock that we're running, but just do it better without depleting the landscape.
Great, thank you.
Thank you.
Stuart McWilliam, everybody. Good on you, mate. Follow him on Instagram, Blackbird and Beast. And if you do want to follow any of the 10 speakers that we had over this weekend, go to the Regenerate Instagram page, regenerate.oz. Regenerate.oz. Go back to the previous post and you'll see all their handles there. So get it if you want to get in touch. But we've come to an end, guys. That's it. We've had an awesome 2 days. I'm sure we've all learned a lot, and we're going to apply that moving forward. So, yesterday, decentralizing food and farming. Today, light and health. Guys, I think it's been a bloody productive weekend. What do you reckon? Yeah. And I just want to bring up Max. If you want to come say a farewell.
Yeah, of course.
Max Gulhane, everybody.
Yeah, so on behalf of Simon and I, I'd like to thank everyone for coming and participating today. Thank you to the caterers if they're still here, or they might have gone. I think everyone enjoyed a really delicious feed of very, very I guess, ideologically aligned food. It was delicious, and it is all about what we're doing here. So thank you to the speakers. Thanks for all of the effort that you put in to be here and to put that effort into preparing your presentation. I know how much time and effort goes into that. So really thankful and appreciative of your effort and the amount of wisdom that you've shared with everyone. I'd like to thank Simon for his amazing job doing the preparation on the day where I was sitting in Gold Coast Airport after the plane engine that I was supposed to be travelling in started smoking. So he's been a real great partner in this this journey that we've embarked on. So thanks, mate. And again, thank you all. You guys are all part of this. It's such a fun journey to be on. I think that the more these discussions happen, the more learning that happens, the more we talk to our friends and family about the ideas that have been discussed today, the quicker and the more impact that we can have to actually change things. So thank you all again, and see you next time. Woo! And Scotty Brizzle, what an amazing job. Thank you, Scotty.
Thanks, guys. Enjoy your evening, and remember, bend at elbow tonight, informal gathering. We're getting fucking on it. Soda waters, let's go. Thanks, guys.